Yes, good morning, guys, to all of you. I welcome you all on this wonderful platform that is BYJU'S Exam Prep. So, guys, please tell me, am I properly audible and visible to all of you or not? Yes. Sai Prajit, good morning, dear. Yes. So, guys, today we are going to discuss the subject machine design. So, today we will see complete machine design in one go. It is a subject which is having a weightage from 5 to 6 marks in general. So guys, today you are going to ensure your 5 to 6 marks. Okay, yes, Raghu, I am fine. So just guys, like and share the session so that other students can also join us. This is some detail about me. Those who are watching me for the first time, my name is Dheeraj Sardana and these are my areas of expertise, and today's topic is machine design. So guys, I already told you that on Saturday we are going to have once again the tone and vibrations. Okay, so the pending part we are going to discuss on Saturday. Jyoti Prakash, good morning, dear. So guys, this is one more very important point, that from 10th January to 16th January, you can appear for All India Open Mega Mock Test for GATE 2023. This is the test you are looking for and you will be getting the video solutions also for that. Yes, moving further, guys, moving further. So guys, if you are preparing for GATE, you can download the ebook, you can register for the free workshops, and you can also go for the scholarship test from the links given in the description. Now we are starting the subject. Yes, Sharma ji ka beta, hello ji. Selvam, good morning. Malesh, good morning. Madhuvamshi, good morning, good morning. So now we are starting, guys. So I will be teaching you just like in the tome we have seen everything from the basic, and today we will complete machine design. Complete means I am starting from the loads, then we will go to fatigue loading, then we will go to brakes, theory of failures, then other topics: reverted joint, bolted joint, welded joint, bearings, all the types of bearings, then gears, shaft, spring, everything we are going to cover. Yes, bhai Surya, good morning. Today only machine design, and on Saturday we are going to discuss tone plus vibration. Vibrations we are going to discuss completely, and balancing gyroscopes, governors, cams, all those topics. Madhuvamshi, we are coming with engineering mechanics marathon, and there is a surprise. Not only me, we would be there, me, Abhinav sir and Sonu Chauhan sir. Entire mechanics we will be covering. Okay, so don't worry, that is planned either on Monday or Tuesday. You will get information by Saturday. Okay, so now let us start the session without wasting the time. Vineet, good morning. So guys, first of all we need to see the weightage. As I already told you, 6 to 7 marks for GATE. For engineering services, 9 to 10 questions in objective for 16-17 marks, conventional 25 to 30. This is the weightage. So before we enter into this machine design, we need to understand what is actually the engineering design. When we are going to define about engineering design, what it is. So guys, when we are talking about the engineering design, first of all, something is starting from the needs of the human. Need is coming first of all. Like I always give the example, there was a time when we wanted to communicate with each other when we are far away from each other. So when we wanted to communicate with each other, at that time there was no device. Then landline came into picture. When landline came, there was a restriction, because that landline is not a movable thing. You were having that at one place. So if you are going here and there, you wanted help at some places, STD PCOs are there, but still every time you was not having that communication device. Then mobile came into picture. So what was that? Actually, this was the improvement. This was a kind of iteration happened. And my dear, when this iteration happened, you were having the mobile. Initial mobiles were only having the calling feature. Then my dear, camera was included, music player included, FM included, and one by one all the things included. And nowadays, your mobile is having what kind of feature. So guys, that is how the improvement happens. So whenever something comes from the human side, to satisfy that need, engineers are going to work and they are going to provide the solution for that. And that solution is going on iteration by iteration. So my dear, with that iteration, finally every time we are having some improved version. So this is an iterative process, never going to end. Okay, starting from the human needs, and to satisfy that we will be giving the solution, and every time we will be improving upon them. You know, every week, every 15 days, bi-monthly or monthly, all the mobile companies, Samsung, be it Xiaomi, any, they are launching their new mobiles with some new feature. Because once they will be saying that we cannot make better than that, that would be the end of the company. So that is why every time iterations are done, some improved version is given to you. So guys, when we are talking about the engineering design, it is the iterative process. Okay, it is the iterative process or decision making to satisfy the human needs. And when we are satisfying the human needs, the target is to always achieve something better, to convert raw material into some better product or service. Bhomik, Ashok, and Vineet, yes, good morning to all of you guys. So guys, when we are talking about the design process, generally students are thinking design means finding out the dimension. Generally student feels that design means finding out the dimension. But I would like to say it is not like that. It is not like that. You are thinking that finding out the dimension is the design. But my dear, design is much, much, much beyond that. If you want to see the entire design procedure, I will be telling you in some steps. Okay. So as I said, the ultimate aim of design is to prepare a drawing, okay, or chart. And that also for what? To get shape, size, material, and appropriate dimension. So means what you want to know? You want to know the shape, you want to know the size, and also you want to know the material and also the manufacturing process. So generally these four things comes under the design. So that is why in short form we are calling design to be CMP. C for configuration, M for material, P for manufacturing process. And this configuration means what? Configuration means size and shape. So guys, this is what is the ultimate target of design. So that kind of design you study in your college, that is only covering this size part. Because in the question you have never seen that examiner is asking which material to be used. You have never seen that examiner is asking which manufacturing process to be used. They are only asking you one thing: what would be the dimensions? And guys, we are lucky that GATE also asks the same. So means in real design means all these things. CMP is the, you can say, understanding what design is. But my dear, in our syllabus, we need to find out only and only size. Jobin, hello dear. Same here, Jobin. So that is what is the requirement of design. So in general, we can show this procedure in this simple 8 steps. So first step is specify the function of the machine element. It means we first of all need to see what we want to make. So for example, I would be giving you the example of a shaft. So let us say we wanted to transfer a power of 2 kilowatt at some speed of 1000 rpm. So this was the need of our. This is what we wanted actually. ये हम चाहते थे. So for that, you already know what would be the second step now. Now for the second step, we are going to see that what are the kind of load which are acting. Power is 2 pi nt by 60. By this you get to know that torque is going to be the load. Okay. Once you get the type of load, you will be going for the selection of shape. Now my dear, as you know, we wanted a device which is going to rotate obviously. So for rotation, you can have square shaft, circular shaft, but shafts are always kept in the bearing. Bearings are of circular shapes which are going to bear the load of the shaft. So my dear, for that we will be choosing the circular shape. So when we are talking about the shape, we will be going for the circular shape. For circular also we can have solid circular, we can have hollow circular. So these are the two options for us. Then you know, in the SOM we have told you, if radial space is a constraint, we will go for the solid shaft. And if weight is the constraint, we will be going for the hollow shaft. So once again, that will be depending on the conditions given. Then my dear, we will be going for the selection of material. Now my dear, that you need to check whether you want the property like ductility, toughness, or you want the property like hardness and brittleness. because ductility and toughness generally go on together. Hardness and brittleness, they also go on together. So based on that, you will select either ductile or brittle material. Either you need mild steel or cast iron, aluminium shaft or some other material. So this is how selection of material will be done. After that, my dear, we will see the mode of failure. Once you decided material is ductile, ductile material fails in shear. Once you decided material is brittle, they get fail in tension. So after selection of material, you will get to know the type of loading on which material will be failing. Ganesh, very good morning, dear. So after selection of that, what you need to see? Now we will be going for the strength of material equation. Now we will be using the strength of material equation to find out the stresses. So my dear, this is the very important step, because here you will get to know that which formula to be utilized. Okay. So in strength of material, we have just completed on the first day of marathon series, where we have seen normal stresses direct, normal stresses indirect, shear stresses direct, shear stresses indirect. Okay. So the same stresses are going to induce. Okay. Today we will see two more type of stresses, that is bearing and crushing. That also we will discuss, don't worry. So guys, this is how we will be using the formulas. After that, selection of manufacturing process, then make a drawing and chart giving all these points there. This is how the procedure is done. Ganesh, today will be only and only machine design. Yes, Brahma, good morning. Ajay, hi dear. Today will be only machine design, because machine design is a complete subject. But on Saturday we have vibration and tom. Okay. Why I kept that Saturday? So that if class extend, then guys, you and me both shall not have any problem. Because last Saturday we have done tom, na? So maybe some students have college and all. So that's why we have kept once again tom at Saturday only. So that if class extends, everybody is comfortable for that. You and me both. Because I also will not be having the paid course classes on Saturday. Okay. Fine. Yes, Aju, sir, what the order of subject that you will be taking today? Dear, today I will be taking only machine design. First, we are going to see loads. After that, theory of failure, then fatigue loading. After that, we will be entering into the brakes, then bearings. After that, joints, then gears. This is going to be the sequence of the topics. So we will complete machine design. It comes for, and I will be teaching you in such a way, even if you don't know anything about that, then also you will be able to get 60 to 70% marks without any problem. And if you have already done, 100% are going to be sure. I will teach you everything, but as you are doing in one day, so keeping that efficiency factor, I am saying that. Okay. Clutch will also, dear, clutch is covered in the bearing, so you know that for gate. Their marathons were actually helpful. Yes. Definitely, Ashok. Let's move further. So guys, these were the steps. Now I am coming with the types of loads. Okay. Now I am coming with the types of loads. We will see the types of loads now. Okay. So guys, when we are talking about the loads, I will be telling you when we are talking about loads. Generally, the first classification of load is done with respect to time. With respect to time, load are of two types. One type of load is said to be static. Other kind of load is said to be dynamic. If loads are not changing with time, they are static. If loads are changing with time, they are said to be impact. Yes, Naveen, good morning, bhai. Yeah, sir, but how? Okay, that we will discuss. We need, don't worry. Sir, what about, dear, that would be on Saturday. Joseph, tom and vibration, you can see in the playlist. Next Saturday we are having, means this Saturday, after 2 days, means tomorrow is Friday. So day after tomorrow we have tom plus vibration session. There everything left out and vibrations would be covered. Okay, Venu, good morning, dear. So now we are moving further. So my dear, when we are talking about the static load, it is of two types once again. The first type is said to be the dead load, and second is said to be the gradually applied load. So dead load is the load which is constant with the time. Gradually applied load is going to vary to the maximum value very slowly and then becomes the constant. So this is gradually applied load. Dead load is like the weight of a body. Okay. And gradually applied load is like if I want to apply 5 Newton, I start with 0. 1, 2, 3, 4, 5. This was the assumption of strength of material also, that loading is gradually applied loading. Then my dear, dynamic loads are of two types. One is impact, other is fatigue. So my dear, when we are talking about the impact loading is that in which load becomes maximum in small time and become constant. So this is the time required to become constant. This is the time required to become constant. So if this was gradually applied, this is impact loading. Okay. Then I would also like to tell you, if time required to become maximum is less than T by 2, then it is said to be impact load. And if T is going to be more than 2T, then it is said to be the gradually applied load. Here capital T is the time period of phononical vibration. Okay. Yes. Ashok, Maji, good morning dear. Advat, good morning. Yes, very good guys. So just like and share the session. We have just started it. Okay. Then my dear, for fatigue loading, there are 4 classifications that we will see in the chapter of fatigue loading. Otherwise, they are there in this slide. But for that, we are having separate chapter. So that's why I'm not going into that. Okay. Then my dear, second type of classification is based on the area of the loading. So that you have studied in the SFD BMD. You would be aware of when we were having a cantilever beam, there is a point load, there is a UDL, there is a UVL, है ना? So I feel that we have already covered in SFD BMD, and that is not required in machine design because we have covered it in SOM already. Yes guys. So just do like and share the session so that others can also join it. Then my dear, we are having with respect to direction. So with respect to direction, when we are going to talk about, if we have a body like this in 3 dimension, I am saying, then you know that this point is said to be the centroid, and any axis passes through the centroid is said to be centroidal axis. So this XX, YY, they are said to be centroidal axis. And my dear, you know this is centroid. Similarly, for this cross section, this is centroid. If I join the line which is having all the centroids of the body, that is said to be longitudinal axis. Longitudinal axis is perpendicular to the cross section. So if any load is perpendicular to cross section, that is parallel to longitudinal axis. So guys, the load which are perpendicular to cross section, parallel to longitudinal axis are said to be normal load. If those loads are passing through the centroid like this, then this is said to be axial. If they do not pass through centroid, they are said to be eccentric axial load. Okay. And then my dear, if the load is parallel to the cross section, it is said to be the shear load. And shear loads are of 2 types, direct and eccentric. If they pass through centroid, direct. If they do not pass through centroid, it means eccentric. So this S2 is direct and S1 is eccentric. Okay. So longitudinal axis is the line joining all the centroids of the body. Now we are talking about the couple. So guys, these are 2 forces, 2 equal and opposite forces separated by a distance D. So if D is the distance of separation, this body, when we are talking about, will not be in equilibrium actually, because these 2 forces have different line of action. So 2 equal and opposite forces separated by a distance, they constitute a couple. Very good, Madhuvamshi. Ganesh, theory of failure. Ha Ganesh, because theory of failure is in the machine design syllabus. So today we will cover it. And testing of property I will be taking in material science. Okay. Material science is also coming. Engineering mechanics is also coming. So don't worry. Okay. So you have the schedule till Sunday. Monday, Tuesday, we are having these things. Material science, engineering mechanics. So everything is going to be covered as per our promise. And maths aptitude is also planned. So guys, just like the session, share the session. और शाम तक बने रहना, तभी लूंगा मैं मटेरियल साइंस, क्योंकि that is low weightage subject. If you are not interested, why shall I be interested? Okay. Yes, let's move further. So guys, 2 equal and opposite forces separated by a distance will constitute a couple. So we are going to define the couple like this, F into D. Okay. So equal and opposite forces separated by a distance. Couple is a vector quantity, you know that. So this is force, this is force. So you just rotate the finger of your right hand in the sense of rotation, because couple is creating this effect. So this is the direction of the vector. So my dear, I would like to tell you that you can make this couple about any point, because the effect of this couple is what? Effect of couple is moment. When you will find out summation moment about any point. The point can be anything. Any point you can take. You will get the value to be F into D. So it means the couple's effect is independent of point, and such vectors are said to be free vector, because it is independent of point of application. If you will see, couple is going to give you moment. Okay. Forces are also going to give us moment. But if we are going to find out moment because of forces, that depends on the location of force. At different point, effect will be different. Like if we have a beam like this, if you see the moment due to this force at this section, it would be different. At this section, different. At this section, difference. Because force into distance is the moment. But for couple, it is independent. Okay, if we have the same beam and one couple is acting, the effect of this couple is going to be same at every section. That is why couple is said to be the free vector. That was also an objective question in 1 mark. Okay. So guys, now we are talking about two types of couple. One is bending, other is twisting. So my dear, let us say if we have this body. Let us say if we have this body, okay, and to this body one force is acting like this, other is acting like this. This will be producing a couple like this. This couple is perpendicular. This couple is having a plane perpendicular to the plane of cross section. So such couples are said to be bending couples. And if the plane is parallel to the cross section, such couples are twisting couple. That also we have seen in SOM. That's why I'm not going into that much detail of this. That is covered in the strength of material. So this couple is bending couple because you can see this is cross section and this is the plane of couple. Both are perpendicular. Such couples are said to be the bending couples. And guys, when we are talking about these bending couples, this can also be a bending couple. Both of these couples are along the centroidal axis. So you can see this couple is about YY and previous couple was about XX. Both are centroidal axis. But my dear, if we see the couple about ZZ axis, like if we have a shaft like this is the axis, you are going to apply two forces like this will be creating a couple like this. This is the twisting couple. Okay, so my dear, if the plane of couple is parallel to cross section, twisting couple, plane of cross section and plane of couple are perpendicular, then it is a bending couple. Very good Vineet, बहुत ही बढ़िया. So I am going fastly because it is a revision session, but I am telling you everything. So we have already seen what is bending couple, what is twisting couple. Twisting couple is acting about longitudinal axis. Okay, so my dear, you have seen generally we are talking about three axes: XX, YY and ZZ. So about XX and YY we have seen bending couples, and about ZZ we have seen twisting couple. Always remember, we are making longitudinal axis as ZZ here. Always remember this. Moving further, guys. Now we are going to see the equivalent effect of load. So in strength of material, if load is passing through centroid, we know the direct formulas. But if load is not passing through centroid, we don't have the direct formulas. So we need to see what is the equivalent effect. So if load is not passing through centroid, we see the effect at the centroid. Sachin, good morning, dear. So if you have force passing through centroid, you know formula is sigma equals to P upon A. But if we are going to have a member like this, where force is acting at a distance of eccentricity E, okay, then my dear, you cannot write stress is P by A. For that you need to see the equivalent effect. How we will find out? We will make one force here, one force here. So these are two equal and opposite forces separated by distance. Will make a couple. So net effect will be a force and a couple. Now you already know, because of force, stress is P by A. And because of bending couple, stress is My upon INA. So now formulas are already given in strength of material. So that SOM formula we are not going to derive again. We are going to directly utilize. So this is the formula for the bending stress. I feel all of you are remembering it. Then my dear, we will see the next effect. Next effect is the effect of DTSL, direct to transverse shear load. So if we have a beam like this time the force is passing through centroid because longitudinal axis consists of all centroid. But this time if you will see the effect of this force, why I am looking at this? Because at different section this will create different moment. So I can take one section here, other section here. If you want to see effect, you will make one force downward, one force upward. So this and this will make a couple. So the effect at any section will be coming like a force and a couple. So this is P into X. So guys, one direct TSL is creating one direct TSL plus one bending couple. The difference is previous couple was a constant P into E. Here couple is a variable, that is P into X. That is the difference. Okay. Moving further, guys. Moving further. So after DTSL, we will see the eccentric TSL. eccentric transverse shear load. Okay, so this time, my dear, the force is not passing through the centroid. You can see. So when force is not passing through centroid, you will apply one force downward, other force upward, and this force will make a couple. So this time you will be having one direct TSL and one twisting couple. So you know that because of direct TSL, shear stresses will come, which you have also seen in strength of material as a Y bar divided by INA times B. But in machine design, we are not going to use it because in the beams, the cross sections are quite bigger. So we know that at every point, stresses are different in case of shear stresses in beams. But in machine design, we are talking about the components having small cross section. For that, we can go for the average shear stress. And you know, average shear stress is defined as simply force bate area. So guys, we will be directly going with this formula in machine design. Only in the spring part, we are going to see this. Otherwise, it is not going to be used generally. Okay. But wherever it will use, we will not be going for this. We will be going for the average shear stress. And you already know, due to twisting moment, also the shear stress comes. That is TR by J. Everybody remember this torsional equation? So I feel now you would be getting a remembrance of these formulas. Bending, torsion. So DTSL समझ नहीं आया, वापस समझा दो. Okay. Dear, DTSL means direct transfer shear load. The load which is passing through the centroid. Like if you have this beam, then this is direct TSL. This is direct TSL. You want to see the effect of this. You will make one force downward, other force upward. This P and this P will make a couple. So you would be having the effect like one force and one couple. This P is direct TSL. Direct TSL means what? Passing through centroid. A shear force which passes through centroid is direct. Which do not passes through centroid is eccentric. Okay. Okay. You got it beneath? So guys, just like and share the session. We are going from the basic. You can see everything I am telling you from the basic. Bending couples are shown by semicircles and twisting couples are shown by semi-ellipse. You show bending couple like this and twisting couple like this. Okay. So that is also something you need to remember. Moving further, guys, now I feel one question I will do for you so that a little bit practice can also be there. I will solve this question. This will give you all the ideas. Okay. We will see this. So guys, this member is AB, BC and CD. Okay. So I want to see the effect of P and Q for AB, BC and CD. So we want to see the effect of P and Q for AB, BC and CD. For AB, BC and CD. So my dear, if you are going to see the effect on AB, if we are going to see the effect on AB, okay, then my dear, you can see this force is perpendicular to longitudinal axis. The force which is perpendicular to longitudinal axis passing through centroid, that is said to be what? You will be saying P for AB is direct transverse shear load. Q for AB is parallel to longitudinal axis, so it is normal and it is passing through centroid. It is perpendicular to cross section. So guys, it is axial load. Very good guys. बहुत बढ़िया नवीन, बहुत बढ़िया अद्वैत, बहुत बढ़िया मधुवंशी, बहुत ही शानदार, बहुत बढ़िया, मजा आ गया. So guys, now we will see for the BC. This is the longitudinal axis for BC. Now you can see, my dear, we can in engineering mechanics you have studied. If this is a force, this is its line of action. We can take that force into its line of action anywhere. So my dear, if you see this Q force is there, then the line of action of this Q force is this. Line of action of this Q force is this. So my dear, if that is the line of action of Q force can be taken anywhere along this. So if you will make Q force here, it is passing through centroid of BC and perpendicular to that. It means it is DTSL. So Q is DTSL for BC. And if you see the P is parallel to longitudinal axis. So it is normal load. But do not pass through centroid. Have some eccentricity. So you will say it is eccentric axial load. Similarly, if you will see CD. For CD, Q is parallel. Parallel means normal. But this is at some eccentricity. So we will call it as eccentric axial. So Q for CD is eccentric axial. and P's line of action is passing through centroid and perpendicular, so DTSL. I feel everybody got it. This is the beauty. So guys, very good, very good. बहुत बढ़िया शर्मा जी का बेटा नवीन, अद्वैत, सूर्या, मधुवंशी, बहुत ही बढ़िया guys. Yes, hope everybody is enjoying the session. So guys, just show your love by liking, sharing and subscribing the channel. So we are moving further guys. हम आगे बढ़ रहे हैं. With this first chapter is over, that was load. But my dear, before we go further, I would like to tell you some basic terms which you need to remember, okay, which you should be knowing before going into the next topic. Okay, so before we go for theories of failure, let us see some things which are important. Let us see that. Okay, so here I will be telling you about the factor of safety. Yes, first of all, factor of safety. Then we are moving to the theory of failures. So when we are talking about the factor of safety, my dear, factor of safety is defined as sigma failure divided by sigma permissible. Okay, so my dear, let us say in your pocket you are having 500 rupees. Okay, then my dear, out of these 500 rupees, you are going to save 100 rupees on the daily basis. So if you are looking for a saving of 100 rupees, you will allow yourself to spend only 400 rupees. So my dear, this is said to be permissible, which you are allowing yourself to spend. This is what is the actual capacity, after which you will become zero. Okay, so this is said to be the factor of safety. So for this case, factor of safety will be 5 by 4. Factor of safety is given to provide some reserve strength, or you can say to provide some savings, which is defined as sigma failure minus sigma permissible. So generally, sigma failure is either yield strength if material is ductile, or ultimate strength if material is brittle, or endurance limit if loading is fluctuating. So fluctuating loading we have not studied yet. So when we will discuss about that, then we will see about endurance limit also. YTUT, you know, by strength of material. I feel everybody got it. Moving to the next important term, guys. When we are talking about the designs, designs are of two types. One is said to be the safe design, other is said to be the failed design. One is said to be the safe design, other is said to be the failed design. So my dear, when we are talking about the safe design, in machine design we are going for the safe design. Safe design is something where we are going to provide less value of, means permissible stress would be lesser than the failure stress. So it means we are not allowing the material to fail. Okay, so we will not allow the material to fail. You know, factor of safety was sigma failure but a sigma permissible. So factor of safety will be more than 1. This is in machine design we are going to do. We will not allow the stresses to cross the yield strength of the material. Then my dear, in fail design you have studied in the metal forming. Here my dear, sigma failure is going to be less than sigma permissible. Means we will allow the failure to happen. It is like we have 500 rupees and we will allow ourselves to spend 700 rupees. Obviously you will be getting some credit of 200 rupees which you have to give back someday. So that is the story. So if we are talking about this, for this case factor of safety will be less than 1. We are doing this in metal forming because in metal forming we are allowing the material to fail. In metal forming we are allowing the material to fail. Okay, this is about safe design and failed design. Moving further guys to the one more thing, there are two types of design criterias. Okay, there are two types of design criterias. One design criteria is said to be the strength criteria. Other design criteria is said to be the rigidity criteria. Okay, so my dear, when we are going to write sigma induce less than sigma permissible, it is strength criteria. And when we write delta induce should be less than equals to delta permissible, it is rigidity criteria. Means when we are designing based on the stress value, it is strength criteria. When we are designing based on the deformation value, it is said to be the rigidity criteria. And my dear, in real life, we are going by both, and we will be choosing a dimension such that by both the criteria, material or component should be safe. But in machine design, in our syllabus, we are going to deal with the strength criteria only. So I feel, guys, within this 36 minutes, we have completed one chapter, which in classes I take 3 hours. So 3 hours task is completed in 36 minutes, and you guys have performed really well. You have answered everything. We are moving to the next topic now. Okay, so we will move to now the next topic, and next topic is nothing but the theories of failure. Are you ready, guys, for the next chapter? The next chapter is theories of failure. Next chapter is theories of failure. Yes, everybody. Wonderful, 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 guys. So guys, when we are talking about the theories of failure, first of all, we shall see the need for theory of failure. So my dear, when we are going to have the uniaxial type of loading, uniaxial loading is there in the first chapter. When you see the tension test and all, you know, if the load is P, you can make the stress distribution like this. In the SOM, you have seen that every point stress is P by A. This is the first thing. And when we are talking about the bending, that is also giving you the uniaxial loading. Okay, so my dear, this is the case. Okay, so you know that here sigma induced maximum is going to be m y max upon z upon INA. This is the formula you apply. So my dear, here if you want to see the state of stress at this point, let us say it is 5, then you would be showing this point like this. So this is also uniaxial loading. For both these types of loading, my dear, we are having a tension test. So when we are going to perform tension test, that is also uniaxial loading. You will go by tension test, you know material is failed at a stress of SYT. And what you need to do, you need to just write sigma induced maximum is going to be less than equals to sigma permissible. This is the design. You know that factor of safety should be more than 1. So sigma induced maximum, what it is? This is going to be either P upon A in this case, or it is going to be M upon ZNA for bending case. Okay, you would be taking this. This is the sigma induced maximum less than equals to what is sigma permissible. Sigma permissible is sigma failure divided by factor of safety. So you will write here SYT upon N. SYT for ductile material, or for brittle material it is SUT upon N. So my dear, when you will be applying this, you will be getting the desired dimension. This is the design. Factor of safety is not something for which we are doing it. Factor of safety, we decide how much saving we want to go for. But in questions, they give you everything and they ask factor of safety. So questions are theoretical. Practical application design is done for the dimensions, you know that, not for the factor of safety. I feel everybody got it. This is the possibility for uniaxial loading. Why this possibility? Because we are knowing SYT from the tension test. Why we are taking this value for this? Because if this is mild steel and this is also mild steel, then shape and size do not affect the property. Its size shape can be different, but this strength is defined for a point, so you can use this failure value for this, because the type of loading is also same, material is also same. But my dear, if type of loading is not same, like we are going to have in reality the combined loading. What is combined loading? Sigma XX, sigma YY, tau XY. So if we are going to have the combined loading, then my dear, you will be knowing from this the principal stresses, sigma 1 or sigma 2. Here these are the induced maximum stresses. So if in the combined loading, you will try to write sigma induced maximum should be less than equals to sigma permissible, then sigma induced maximum will be either sigma 1 or sigma 2. No problem in that. What is sigma permissible? People says SYT by N. Then I will say this is not correct. I will say this is not correct. Why? Because sigma 1 and sigma 2 are coming because of combined loading, where one component was fighting with a number of stress component, sigma xx, sigma yy, tau xy, tau yx. Here one person was having fight with 4 persons. What are 4 persons? Sigma xx, sigma yy, tau xy, tau yx. But my dear, in this case, when we are talking about the tension test, here the loading was uniaxial. Here the loading was uniaxial. So my dear, maybe you take the same material at left hand side and right hand side, but the loading is different. So it is like if Amitabh Bachchan is having fight with 1 person or 10 person, he may give the same result because movies are hypothetical. But in reality, if you have the fight with 1 person or with 10 person, the results would be different. South Indian movie maybe with 1 person or 100% result is same, but that is not reality. In reality, if you will have fight with 1 person, you may win. 10% chances are very rare. Okay, so guys, that is the beauty of movies. They are going with theory, but in reality it is not happening. So we cannot use uniaxial loading result for the combined loading. So for such cases, many people thought let us go for the combined loading. But when we go for the combined loading, you know, in the combined loading we have sigma xx, sigma yy, tau xy. So when you would be making the combinations of these three, because at one time you can vary one type of stress. So there are three things. You will be keeping 2 values constant and you will vary 1. Likewise, if you will try to make, you will get infinite number of experiments. Infinite number of experiments are required to find out the yield strength under combined loading, which is next to impossible. For that we need infinite years. Means we have to wait for infinite years for using the combined loading. We cannot do that. Everything is in combined loading. Your home beams are in combined loading. Highways, combined loading. Power plant shaft, combined loading. Everybody is in combined loading. So because of that, we cannot wait for that long. So that is why, my dear, some theoretical, some hypothetical statements were given. And when, okay, you are asking something, we need factor of safety value will be depending on various conditions. That will depend on the unknown loading condition, the type of assumptions you have made. Okay, so generally I will say when you will calculate, you will be getting 2, 3, that kind of value. In some of the country may be lesser, where loads are coming lesser. In country like India, where resources are less, peoples are more, it may go up to 3, 4 also. So that depends on the application to application, country to country, that varies. Okay. So when we are talking about these theories, you have infinite number of experiments to perform, which is impossible. So my dear, some hypothetical statements were given, and the hypothetical statements which were given, those were found to be valid for some of the loading condition, for some of the material. Like if I say that one person is having fight with one sumo, and the same person is having fight with 4 sumo. You will say, sir, performance will not be same. I will say performance can be same if all the sumos are coming one by one. So under some conditions, uniaxial loading and combined loading can give you same result. Similarly, for theory of failure also some statements given which relate combined loading with the uniaxial loading, which is tension test. So my dear, otherwise these two are different things. But for some condition, for some material, they were found to be valid. So for the condition they were found to be valid, we are generally going to use them. And those hypothetical statements were given the name of theories of failures. Okay. So there are many theories of failure. Out of them, you need to study 5 out of them as per your syllabus. So we will be going one by one for the theories of failure. So that we have already seen for tension test, that kind of things. Okay, that we have already discussed. Factor of safety is already discussed. Okay, so let's move further. So you know why theories of failure? You can say why factor of safety actually. Factor of safety is required for unrealistic assumption of SOM, unknown loading condition, some typical environmental condition, stress concentration. Stress concentration we will see in the fatigue loading topic. So you know that in SOM you have assumed the loading should be gradually applied. In reality, loading may not be gradually applied. You say member is prismatic. In reality, member may not be prismatic. So because of those assumptions, we use factor of safety. Unknown loading condition, like in the lift it is written that not more than 10% 68 kg each. We see already 15% are there, but still we enter. You see the buses have a seat of 55 people max, but 200 people are traveling on the days of Deepavali. Trains are having some 72 seats, but you know that in the sleeper coach, you have seen more than 100, 150 people are going every time. So what is that? This is unknown loading, because they have designed it for less, then it would have been failed. So we know this unknown loading condition, that is why they are designing it for the more capacities. That is the meaning of factor of safety. Okay. Definitely we need. So guys, now let us move further. I feel all these things we have discussed. So we will see the first theory of failure now. So guys, you know that when I teach these topics, I go with a number of stories which help you to remember all the things. But unfortunately, this is not the time for those stories, because either I can cover the syllabus or stories in 6 to 8 hours. Okay. So that's why I'm skipping the stories. I'm just telling you point to point what is required. Means we are covering everything without entertainment. Okay. That is the only difference. This is not the time for entertainment. So first theory of failure is maximum principal stress theory, because it is revision class, or maximum normal stress theory. So guys, when we are talking about this theory was given by Sir Rankine. So it is also said to be the Rankine theory. So what this theory said, this theory says that induced stresses maximum value. If maximum value of normal stress induced under combined loading, if this is going to exceed the same, if that is going to exceed the same under tension test, material is going to fail. So Sir Rankine thought that materials are getting failed under normal stresses. So my dear, when he have said that, then he said, if you want to keep material safe, then you need to take care for normal stress under combined loading should be less than or equals to the same for the same material under tension test. So he said a material or a component shall not fail if the induced value of maximum normal stress because of combined loading shall not exceed for the same material under tension test. Means maximum normal stress under combined loading, if it is less than the maximum normal stress under tension test for the same material, your material is going to save. Okay, you need not to remember the statements not required in GATE. You need to remember the expressions and the diagram. So what we said, that the sigma maximum value of normal stress under combined loading, which is nothing but either sigma 1 or sigma 2. You know, magnitude wise any one can be bigger. Mathematically sigma 1 is bigger than sigma 2. So if sigma 1 is more than sigma 2 mathematically, means if sigma 2 is minus 50, sigma 1 is plus 10, then mathematically this is bigger, but magnitude wise this is bigger. So failure happens by this magnitude. Why? Because we are making an assumption that material behaves same under tension and compression. This is our assumption in SOM. You know, in reality it is not, but this is our assumption. So because of that, my dear, either sigma 1 or sigma 2 will be more in magnitude. Then what is the maximum value of normal stress under tension test? You know, that is equals to SYT. So you would be saying what? This is the failure stress. If you want to find out permitted stress, you will say SYT upon N. So the equation will be sigma 1 or sigma 2 is less than equals to SYT by N. If you know this equation, this is required for Rankine theory. Okay. So you need to remember two things. One is this equation. Second is the failure envelope. Now what is the failure envelope? My dear, failure envelope is a diagram which is made on sigma 1 and sigma 2 axis. Sigma 1 and sigma 2 axis. You know, we have written the equation sigma 1 or sigma 2 is less than equals to SYT by N. N is the factor of safety. If you are talking about failure, you will consider factor of safety to be 1. So when sigma 1 is reaching to SYT, material will fail. Sigma 2 is reaching to SYT, then also material will fail. If sigma 1 is reaching to SYT in tension, material will fail. If sigma 1 is reaching to SYT in compression, material will fail. Same here. So you can see these are the 4 straight line equation. It is like x is equals to plus constant, x is equals to minus constant, y is equals to plus constant, y is equals to minus constant. Is it clear? Yes. So my dear, if you see this is y axis, this is x axis. So you would be having these 4 lines like this. And as you know, in reality, you are not having the equal sign. In reality, you have less than equals to sign, which means towards the origin. So my dear, when you will be going through towards the origin, then this would be the feasible region. And if someone asks you what is the shape of this envelope which is enclosing this entire region, this is a square. Always remember this is square. Why? Because we are assuming in tension and compression yield strength is same. This is our assumption. So that is why this failure envelope is a square. When we say failure envelope, it means the inside region is going to be safe. Okay, the inside region is going to be safe. And my dear, if you use factor of safety, what do you mean by that? When you will be using the factor of safety, like you are putting N to be 2, then this will become SYT by 2. Then this value will come to half of it. So the envelope will become like this. When you are taking factor of safety 2, what do you mean by that? In real, failure happening at these boundaries, but you are not allowing yourself to cross these red boundaries. That is the meaning of factor of safety. Okay, so I feel you understood now. This was the first theory of failure. Please tell me guys, are you getting it or not? And do like and share the session guys. And if you want to know for which material it is applicable, this theory of failure is applicable for brittle material under all loading condition, and for ductile materials only when sigma 1 and sigma 2 are of same nature. Same nature means they both will be tensile or they both will be compressive. This is the condition for application. So one theory of failure is over. Now we will be moving to the second theory of failure, which is maximum shear stress theory. Okay, when we talked about maximum principal stress theory or maximum normal stress theory, there the criteria for failure was chosen to be the normal stress. Yes, very good. So this theory was given by Guest and Tresca, and they have said that material is going to fail under shear. Okay, that was their belief based on their experiment systems. So they said that if the maximum value of shear stress, in combined loading is less than equals to maximum value of shear stress under tension test, then material is not going to fail. This was their belief. So my dear, then material is going to be safe. This was their belief. So when we are talking about this tau max in combined loading, it is nothing but absolute maximum shear stress. What is absolute maximum shear stress? It is the maximum of sigma 1 minus sigma 2 by 2, sigma 2 minus sigma 3 by 2, or sigma 1 minus sigma 3 by 2. Out of these three, whichever is maximum, less than equals to. What is for the tension test? You know, tension test is performed like this. Uniaxial loading. For uniaxial loading, Mohr circle is like this. You know, this is the radius. This is sigma. So you know radius will be sigma by 2. Because radius is diameter by 2. Sigma by 2. If radius is sigma by 2, material is getting failed when sigma reaches to SYT. So you can say radius is SYT by 2. Okay. So you know you will be using factor of safety. So you will write SYT divided by 2N. 2 will get cancelled out. From here you will say sigma minus sigma 2, sigma 2 minus sigma 3, sigma 1 minus sigma 3 is less than equals to SYT upon N. Okay guys, this is what is the case for maximum shear stress theory. So my dear, when we are talking about this, this is for the 3D case. But in your syllabus, 2D is there. For 2 dimensions, sigma 3 will be 0. So if sigma 3 will be 0, what you can write? Then my dear, you can write it in this way. That sigma 1 minus sigma 2 or sigma 2 or sigma 1. That should be less than equals to SYT upon N. So when you see this, generally student feels that, sir, what you need to think here? Obviously sigma 1 or sigma 2 will be bigger. I will say no. Why? Because if sigma 1 is 100 and sigma 2 is minus 50, then my dear, will you check sigma 1 minus sigma 2 is going to be the bigger one. So my dear, if this will be the given thing, then my dear, that is possible if sigma 1 is 100, sigma 2 is 50. For this case, sigma 1 is going to be highest. So which out of these three is highest? That will depend on the nature of principal stresses. Whether they are both tensile, both compressive, or one tensile, one compressive. Yes. Shruth, that I have told you in the strength of material, that for brittle material, tensile compressive strength is more than tensile, shear and more than tensile. For ductile material, shear is the lowest one. That we have seen in SOM. Okay. So that is not required here actually. And that values are also given to you, that you need not to worry about. For same nature of principal stresses. Okay. For same nature of principal stresses, you know, if sigma 1 or sigma 2, that is going to be bigger, sigma 1 minus sigma 2 will be smaller. So this will be the equation. This is the same result as given by Rankine. So here, this is the same result as given by the Rankine. That's why for Rankine I have written, it is valid for ductile material if the principal stresses are of same nature. Vineet, sir, tension test एक बार repeat कर दो ना. Dear, tension test was not of Guest and Tresca. Tension test of ours only, which we have done before. This is the tension test. Uniaxial loading. For uniaxial loading, this is the Mohr circle that you have studied there when I was teaching you. So this is the Mohr circle. So my dear, for this Mohr circle, the diameter is sigma. Because you know one principal stress is sigma, other is 0. So what is the radius? Radius would be sigma by 2. Now you tell me when the material will fail, when sigma reaches to SYT. When sigma will reach to SYT, then radius will reach to SYT by 2. Why I am checking the radius? Radius is the tau max that we have studied in the strength of material Mohr circle. If you remember, we have just seen this on the last Wednesday. Okay, so I am expecting that you know that. Okay, moving further, guys. So for same nature of principal stresses, Guest and Tresca and Rankine agreed at the same point. But my dear, there may be unlike principal stresses. When sigma 1 is tensile, sigma 2 is compressive. For that case, sigma 1 minus sigma 2 is bigger. So for that case, equation will be like this. Equation will be like this. Sigma 1 minus sigma 2 is less than equals to SYT by N. Okay, guys. So now we have these two cases. Now we will be going for the failure envelope. You said for the same nature of sigma 1 and sigma 2. You know that when I will be making the failure envelope this time, in the first quadrant, sigma 1 and sigma 2 both are positive. In the third quadrant, sigma 1 and sigma 2 both are negative. So in these two quadrants, we will be getting the same failure envelope which we got in the previous theory. So in the previous theory, we were getting a square like this. Like this. So for this, I have made it with the dark line. But for opposite nature of stress, we have the equation sigma 1 minus sigma 2 is less than equals to SYT. You know, and we will be taking as 1. This is like x minus y is equals to C. You know, for tension plus, for compression minus. So y is equals to x plus minus C. You know, y is equals to x line is like this. Y is equals to x. X plus C is this, x minus C is this, which will be passing through C at here and there. So it means the equation for this should be giving you this curve. But this is valid only for opposite nature of stresses. And because of less than equals to sign, they are indicating towards the origin. So you would be getting the failure envelope and safe region. This would be the safe region. And the envelope which will enclose this safe region is the failure envelope. Is it clear for everyone? Is it clear for everyone? Very good. So Madhuvamshi is saying it is most conservative theory. Very good guys. But that we will see at the end, because right now we have not seen envelope for everyone. So guys, this theory is going to be utilized for ductile material. Okay. For brittle materials, we have seen MPST. For ductile materials, we are having MSST. Now we are talking about total strain energy theory. Okay. So my dear, you have seen that MPST was valid for brittle, MSST was valid for ductile. So we wanted some theory which should be valid for every material. So for that, one theory came from the side of Hayes, which is said to be the Hayes theory. It was given by Sir Hayes. And my dear, this is said to be total strain energy theory. And my dear, here the failure criteria is strain energy per unit volume. So that is denoted by small u. So this time they said that total strain energy per unit volume by combined loading shall be less than equals to the same because of tension test. So every time they have compared it with the tension test only. Guys, this theory was found to be neither for ductile nor for brittle. This was neither valid for ductile nor for brittle. That is why this is not going to be there in the part of your exam, but still as per the syllabus, I need to teach you that. So when you will be finding out the strain energy, generally strain energy for one direction is defined as half into sigma into epsilon. But if we see the three-dimensional system, in three dimension there would be three principal planes, sigma 1, sigma 2 and sigma 3. So for three dimension strain energy scalar, they will be directly added up. Okay? Madhuvamshi. Shruti is saying, sir, in MDET we use to write relation. Dear, wait for that. MDET we have not seen yet. So we are coming to that. Okay, so just wait for that. So when we are talking about this strain energy per unit volume under combined loading, when you will be going to add all of them, what you are going to get, I am writing it. Okay, then you would be getting the final expressions as sigma 1 square plus sigma 2 square plus sigma 3 square minus 2 mu sigma 1 sigma 2 plus sigma 2 sigma 3 plus sigma 1 sigma 3 1 upon 2e. This is the expression for strain energy per unit volume of combined loading, because strain energy is given as half into P into delta and strain energy per unit volume is given as half into sigma into epsilon. So we have utilized that relation. And my dear, after addition you will get this. Then my dear, for tension test when you will find out, for that you would be getting 1 upon 2e SYT square. But if you are using the factor of safety, it will become n square. Because when you use factor of safety, you are going to keep SYT to be SYT by n. We are not dividing the equation by n, we are dividing SYT by n. Okay? So when you will be doing that and you will be equating them, you will be getting the relation to be sigma 1 square plus sigma 2 square plus sigma 3 square minus 2 mu sigma 1 sigma 2 plus sigma 2 sigma 3 plus sigma 1 sigma 3 less than equals to SYT square upon n square. Okay? Is it clear for everyone, guys? Are you getting it? Everybody getting it? This is going to be the relation for 3D. But you know, 3 dimension is not in our syllabus. So don't worry. you need to remember the result of 2D. So we have seen the 3D case. Very good, SK Aditya. So for 2D case, you will be getting sigma 3 to be 0. You will get sigma 1 square plus sigma 2 square minus 2 mu sigma 1 sigma 2 is equals to SYT square upon N square. And if you see, this is the equation of generalized ellipse. Now you might be thinking, sir, what is generalized ellipse? And you need to remember this equation only. You need to remember this equation only. Very good, Umar. So you need to remember this equation only. This is for 2 dimension. Okay. So my dear, if that is the case, this is the generalized ellipse. What is generalized ellipse? When we study ellipse, we have studied the ellipse for which x-axis and y-axis were major and minor axis. But if that condition is not there, ellipse can have any axis as major axis, any axis as minor axis. We call it as generalized ellipse. So this equation is of generalized ellipse. So when you would be making the failure envelope, you will be getting this generalized ellipse, where this is said to be semi-major axis, this is said to be semi-minor axis. And when you will be calculated the semi-major axis, they can ask you in the paper, semi-major axis is coming out to be SYT divided by 1 minus mu. And when you will see the semi-minor axis, to remember it is very easy. Major axis will be bigger in length, minor will be smaller in length. So it is going to be SYT divided by 1 plus mu. So this is semi-major, this is semi-minor. I feel everybody got it, and obviously this region will be the safe region for the failure envelope, which is an ellipse. So failure envelope is a generalized ellipse. Guys, do like and share the session. Why there is difference in that number? So those who are watching, they do not like the session. Yes, shall we move on now to the next theory? Please tell me, MSCT is clear to everyone? I already told you MSCT is neither valid for ductile nor for brittle. Okay, MSCT is not utilized for ductile or brittle until examiners say this to apply. But if examiners say you need to apply, but till date there was no question in GATE from that. Midun, fine, very good guys. So now we are moving to the fourth theory of failure. Which is the maximum distortion energy theory. Maximum distortion energy theory in short form is said to be MDET, and this was given by von Mises and Henke. So we call it as Mises and Henke theory, or more famously as von Mises theory. So my dear, when Sir Hayes have taken the criteria to be strain energy per unit volume, it was thought that it is going to be most successful theory, but it got failed. Then von Mises tries to find out the reason for that. When he tries to find out the reason for failure of Hayes theory, he have an in-depth study of total strain energy per unit volume. Then what he have seen, that total strain energy per unit volume is having two components. One is volumetric strain energy per unit volume, other is distortion energy per unit volume. Okay, sir, हाँ, फिश वाली स्टोरी, बट स्टोरी नहीं सुनाऊंगा, ठीक है, क्योंकि स्टोरी सुनाएंगे तो फिर मशीन डिजाइन भी पूरा नहीं हो पाएगा. ओके, तो ये रिवीजन है, स्टोरी इसको सिर्फ पहली बार समझने के लिए यूज किया जाता है. तो नाउ वी अंडरस्टूड, नो नीड टू गो फॉर दैट. ओके, बट आपके ध्यान में आ गई ना, that is the reason why I told you the story. At reaching to the topic, you remember the story, you remember the everything, whatever is required here. So total strain energy per unit volume is having two components. One is volumetric strain energy per unit volume, other is distortion energy per unit volume. So my dear, I would like to say, when we are talking about the volumetric strain energy per unit volume, it is responsible for change of size, and distortion energy per unit volume is responsible for change of shape. You know, whenever distortion happen, whenever deformation happen, one thing is volume changes, other thing is change of shape. So for volume change, volumetric is responsible. For shape change, UD is responsible. So my dear, based on different theories, when Sir Tresca have seen, von Mises. Von Mises get to a conclusion that he was knowing the fact at that time that ductile material is getting failed due to shear. Okay, shear means the change of shape, and brittle materials are getting failed in tension, and tension means the change of size. So he was knowing that when different materials are getting failed because of different reasons, then why we are keeping the total energy as the failure criteria. That was the reason of the failure of that theory. So he said, if we are talking about ductile material particularly, it fails due to change of shape. So for ductile material, we need to consider the UD, and for brittle material, you need to consider the UV. Volumetric strain energy per unit volume should be considered for UV, and distortion energy per unit volume should be considered for the ductile material. So when both materials have different reasons of failure, when they are getting failed in different ways, how we can use one theory for both of them? So he came to the conclusion that we need two different theories for them, and he was knowing that MPST was quite an exact theory for brittle material. So he concentrated on ductile material. So he have chosen the failure criteria to be distortion energy or shear strain energy per unit volume. So what he said is, he said if distortion energy per unit volume of combined loading is more than tension test, material will fail, and if it is less than, then material is going to be safe. And my dear, when we are going to calculate this distortion energy per unit volume, when we are going to find out the distortion energy per unit volume, then my dear, UD for distortion energy per unit volume for combined loading, that came out to be 1 plus mu upon 3E into sigma 1 square plus sigma 2 square, sigma 1 square plus sigma 2 square plus sigma 3 square, minus sigma 1 sigma 2 minus sigma 2 sigma 3 minus sigma 1 sigma 3. That is the value. And you can also rewrite it as 1 plus mu upon 6C, multiply and divided by 2. Then you will get sigma 1 minus sigma 2 ka square plus sigma 2 minus sigma 3 ka square. There will be 3 perfect squares. In both the ways you can write. Even you know E is equals to 2G into 1 plus mu from strength of material. So my dear, 1 plus mu divided by E can also be written as 1 by 2G. So you can replace this by 1 by 12G. In the GATE, many times they have asked the question, the expression for distortion energy per unit volume, where this was in the option. So I have given you all the 3 expressions for combined loading. When you will be going for the tension test, okay? When you will be going for the tension test. Tension test is a uniaxial loading. So Shruth, now your question will be answered. So tension test is a uniaxial loading. For that, in this equation only, you need to keep sigma 2 0, sigma 3 0, and sigma 1 to be SYT by N. You need to put this. When you will be putting this, this is 0, this is 0, this is 0, this is 0, this is 0. Everything is 0. You will left with 1 plus mu upon 3E SYT square upon N square. This is what you are going to be left with. Is it clear for everyone? Is it clear for everyone? Yes. Then my dear, what you are going to get? What you are going to get? You are going to have sigma 1 square, sigma 2 square, sigma 3 square, minus sigma 1 sigma 2 minus sigma 2 sigma 3 minus sigma 1 sigma 3. That should be less than equals to SYT square upon N square. This is the equation for MDET. That 0.577 things that I will be telling you when we will be making the relation between shear strength and normal tensile strength. That would be the task at that time. So guys, this is the equation for 3D. This is von Mises theory for 3 dimension. Now you know for 2 dimension we need to just keep sigma 3 to be 0. When you will be putting sigma 3 to be 0, you will be getting the 2D equation. You will be reaching to 2D equation. So what is the 2D equation? I feel you are aware of that. Okay. Sir, if question asked, find out distortion energy, which formula used? Dear, I told you na, 3 formulas. You can use any of the 3 formulas. You can use any of the 3 formulas. Okay. So depending on what is given to you, you can use any of these 3 formulas. One is this. Second is this. Third is this is replaced by this, rest is same. All 3 are valid. Sir, as we have relation, tau is sigma by root 3. Dear, that we are going to come after 5 theories, na? What you are asking, that is for pure torsion we see. That we will see. But first let me complete all 5 theories. Then only we can do that, na? That we will see with the, when we see the relation between shear yield strength and tensile yield strength. In that we see that. Very good, guys. So I feel you guys are getting it properly. Moving further. So we are going with a very good speed, I feel so today. Okay. So my dear, when we are talking about, this is the expression. So when you will be making it in 2 dimension, it will be there. Sigma 1 square plus sigma 2 square minus sigma 1 sigma 2 is less than equals to SYT square upon n square. This is the equation for 2D. You can see 2D part is very easy to remember. Now you will be keeping factor of safety to be 1. Then sigma 1 square plus sigma 2 square minus sigma 1 sigma 2 SYT square upon n square. N is 1. So this is the equation for 2D. And my dear, I would like to say this is once again the generalized ellipse. But this generalized ellipse is different than the previous one. In the previous ellipse, failure points were lying inside the safe region. That is why it was neither valid for ductile nor valid for brittle. Failure point should not be there in the safe region. So here this ellipse is passing through all the 6 corner points of the hexagon made by MSST. Because that theory was also for ductile. This is also for ductile. So my dear, here the semi-major axis is root 2 SYT and semi-minor axis is root 2 by 3 SYT. This is how we can find out semi-major and semi-minor axes. And my dear, this ellipse is passing through all the points of the hexagon. Okay. And my dear, here failure points are either outside this envelope or lying onto this envelope. But in the previous ellipse of MSET, failure points were coming inside. That is why that was neither applicable for ductile nor for brittle. So this is giving us the exact picture because failure points are really lying at the failure envelope. So that is why this is said to be more exact theory of failure, and that is why this is said to be the best theory of failure for ductile material. But my dear, if nothing is said to you, then my dear, you will be going with your choices. Your choice will be for brittle, you need to go with MPST. For ductile, you need to go for MSST. Okay, because MSST's failure envelope is lesser. So when you will find out the dimension, MSST will give you more safety. Okay, MSST always provide more safety, and that is why MSST is said to be the most conservative theory of failure, because it is having smaller failure envelope. Smaller failure envelope means smaller boundaries. Chances of failure are becoming lesser. That is how the things are going to define. Okay, so please tell me everybody got it. Then we are moving to the next theory. So for this also we got the ellipse only. Now we are moving to the 5th theory of failure. Okay, so guys, even here generally I talk about some interview points also, that how we can convert the total energy component into normal and shear. Okay, so that is required for interviews, not for the GATE or ESC exam. Okay, so still if you want, okay, for that I can tell you directly without derivation. Without derivation I am telling you. Okay, so that nothing is missed from my side. If you are given like these 3 stresses, okay, this is sigma 1, this is sigma 2 and this is sigma 3, and you need to write the component which are responsible for change of volume and the component which are responsible for change of shape. Okay, so what you need to do, 100, 30 and 50, you will be taking the average, sigma 1 plus sigma 2 plus sigma 3. In the classes I have done the derivation of this. But in this marathon session, we are avoiding derivation because we are going for a quick revision. In GATE, derivations are not asked. Even in ESC objective, derivations are not asked. When you will be going for this, 100 plus 30 plus 50, 180 by 3 will be 60. So you would be making here 60, 60 and 60. This is the volumetric components. Now if this is 100, this is 60, we are left with 40. So 40 will be coming here. If this is 60 and this is 30, we are left with 30 here. If this is 60 and this is 50, we are left with, okay, this is 30 and this is 60. So this should be, sorry, I am writing it again. Actually, what I want to say is, whatever this component is, this should be this plus this. So this is 60, so this should be 40. So that 60 plus 40 is 100. Here it is 30. We already have 60 here. So here should be minus 30. 60 minus 30 is 30. Here this is 50. We have made 60 here. So here should be minus 10. This is distortion component. Distortion means they will be changing the shape and they will be changing the volume. Is it clear for everyone? Yes. So we are going into that much depth. You see, I have given you the interview point also. Are you getting it or not, bhai? Bolo. We are coming to the last theory now. After this, within 10 minutes, this chapter will also be over. So we are going with a very nice speed because in 1.5 hours, if we are going to complete 2 chapters, we are going very nicely. Okay. So let me once again share it. Okay. Fine, guys. Fine, guys. Fine. Moving further, guys. Moving further. So we are moving to the last theory of failure, that is Saint-Laurent theory. And Saint-Laurent theory is also known to be maximum principal strain theory. Here they say the reason for failure is not stress, but the reason for failure is strain. So here they say that the maximum value of strain under the tension test, maximum value of strain under the tension test, sorry, not under the tension test, under the combined loading, should be less than equals to the maximum value of strain under the tension test. Okay. Then you know, for combined loading we have 2 principal strains in 2D. Sigma 1 minus mu times sigma 2 by E, sigma 2 minus mu times sigma 1 by E. And when you will be going for the tension test, you know, this is epsilon max for combined loading. When you will be going for the tension test, you know what we need to do? We need to just put sigma 1 to be SYT by N. Sigma 2 will be 0. So here epsilon 1 will be coming out to be SYT upon NE. And epsilon 2 will be coming out to be minus mu times SYT upon NE. You know, mu is always less than 0.5. So epsilon 1 is going to be more. So epsilon maximum because of tension test will be SYT upon NE. I feel everybody got how we got these 2 values. Just by putting these values in the previous equations, you will be getting these 2 values. So maximum will be this for tension test. Using this, we will be writing that sigma 1 minus mu times sigma 2, okay, upon E, or sigma 2 upon E minus mu times sigma 1 upon E. That should be less than equals to SYT upon NE. You know, EE will get cancelled out and you would be getting either sigma 1 minus mu times sigma 2 or sigma 2 minus mu times sigma 1 should be less than equals to SYT upon N. This would be the case. This would be the case for the maximum normal strain theory. Sir, I have shared a question to you in WhatsApp. Okay, sure. Umar, you will get the solution by tomorrow. Any student who have asked the question, tomorrow you are going to get the answer in the second half. Okay. So tomorrow, as I don't have any marathon, so I will try to answer you all. Okay, guys. Now let us move to the next part. So when you see this here, how the failure envelope will be there. Let us see that. For failure envelope, you have one equation as sigma 1 minus mu time of sigma 2 is less than equals to, we are going to put n to be 1. N to be 1, inequalities are converted to equation. Plus for tension, minus for compression. Then we have sigma 2 minus mu times sigma 1 plus for tension, minus for compression. If you see, these are the four equations. One equation is x minus mu times of y is plus minus syt, and y minus x times of mu is plus minus syt. These are four straight lines. So four straight lines, when you will be plotting like this, they will meet each other and make a rhombus. And this region was said to be the safe region by Saint Venant. Okay, this was said to be the safe region by Saint Venant. But my dear, what happens actually? What happens actually? When they have made this failure envelope, this was very, very big. It was that much big that before that we have a big ellipse, MSET. That big ellipse, which is already having failure points, lies inside this. Means ये उस ellipse से भी बड़ा है. The ellipse which were already having failure point, rhombus is even bigger than that. So my dear, definitely failure points will lying in between in a very large number. So this is said to be the worst theory of failure. Neither valid for ductile nor valid for brittle. Once again. Okay. Neither valid for ductile nor valid for brittle. Now we are coming with the torsion test. Okay. Torsion test is a special condition where pure torsion is the type of loading. We get sigma 1 as plus tau, sigma 2 as minus tau. So you can see nature of stresses are opposite to each other. So my dear, when we are talking about the materials, whenever material is brittle and they are not mentioning which theory to be applied, you will be going with MPST. And when we are talking about ductile and they are not mentioning which theory to be used, there are two options. MSST, MDET. MSST's failure envelope is small, so it gives you more dimension. So it is said to be safe, but uneconomic. Why uneconomic? Because it will say take a 20 mm diameter shaft. On the other hand, MDET says take 18 mm diameter shaft. So MDET is also safe. So if 18 mm is safe, you are going for 20 mm. Definitely more material, more cost. But definitely this safe will be going towards safest. And economic will go towards uneconomic. So if you are looking for economy, go for MDET. If you are looking for safety, go for MSST. But if nothing is mentioned, we will give priority to safety. We will go by MSST. Generally, I derive this also in the classes, but that is wastage of time here. Okay, here derivations are need to be skipped so that we can save the time. Okay, so I feel you are getting it. Otherwise, how 40 hours subject can be complete in 6-7 hours? But definitely what I am giving you, that is only the revision part. In revision, you need not to go for derivations. Okay, so guys, this is what we are talking about, the torsion test. Now we will compare the strength, shear strength and tensile strength, okay, for various theories of failure. So when we are going for MPST of the pure torsion case, you know that here you write sigma 1 or sigma 2 less than equals to SYT. Okay. Upon N also you can write, but I am taking N to be 1. So sigma 1 is tau, sigma 2 is minus tau, less than equals to SYT. So you know that tau is nearly equals to SYT. Tau we will say as shear yield strength. SYS is nearly equals to SYT. So as per MPST, material is going to fail at the same value of shear stress what it is getting failed at the same value of normal stress. Means it want to say the strength of material is in shear and in tension is same. Obviously it is not correct. That is why it is not valid for ductile material, because ductile material fails in shear. Okay, that is the reason. Okay, because it says shear and tension have same effect, which is not. Second theory, when you will see MSST, you know, for opposite nature, sigma 1 minus sigma 2 is less than equals to SYT. You can consider factor safety 1. Tau minus of minus tau is equals to SYT. So tau will be coming out to be 0.5 times of SYT. So we are saying that shear yield strength is 0.5 times of SYT. Okay. So it is taking half, which is nearly same. That is why this theory is giving correct result for ductile materials. Then we are talking about MSET. For MSET, you have sigma 1 square plus sigma 2 square minus 2 mu sigma 1 sigma 2 is equals to SYT square. Put sigma 1 as tau, sigma 2 as minus tau. It would be tau into minus tau, SYT square. Tau square, 2 tau square minus 2 mu, minus minus will be plus, tau square. So you would be having, guys, tau square 1 plus mu, SYT square. So tau will be coming out to be SYT by square root of 2 into 1 plus mu. So this is yield shear strength is SYT by 2 into 1 plus mu. Is it fine, Shruth? You were asking about this. Okay. Would you like to do this question for a change? Would you like to do this question for a change? Yes, solve it then. And guys, do like and share the session. Do like and share the session. We are moving to this question. A thin cylindrical pressure vessel with mean diameter of 10 meter. So radius is 5 meter. And wall thickness of 20 mm. Is subjected to an internal fluid pressure of 0.4 MPa. If the yield strength of the material of the cylinder is 200 MPa. Factor of safety you need to find out by MSST. You know, for thin cylinder, both the stresses are of same nature. If this is PR by T, this is PR by 2T. As both are tensile, you will say sigma 1 or sigma 2 is less than equals to SYT upon N. So you need to find out the answer. Tell me that. Very easy question. Very easy question. So I feel Midun have given the answer as D. What about others? What about others? Very good, Umar. Very good, Madhu Vamshi. Answer will be D for this. Okay. So this is sigma 1, this is sigma 2. Manas. Okay, Manas is also there. Advait. Very good. Shruth. Very good. So guys, now we will see for MDET. Okay. We will not go for that much number of questions. Okay, this is one more question. Then we will enter into the next part. So guys, we have almost completed 2 chapters. Okay. So I feel we are going with a very good speed. So in 1.5 hours around, we have completed 2 topics. This is a good sign that we will be able to complete entire syllabus today. And next topic is going to be fatigue loading. We try to complete fatigue loading also in 1 hour. Okay. Okay. Malesh, very good. So now Madhu Vamshi is saying the answer to be B. What about others? Shruti is saying B. Very good. Bhomik. Yes, guys. B is the right answer. You know sigma 3 is 0, as you can see this. This is a 2D state of stress. Sigma 1, 2, xx plus 100 minus 100 by 2 का square. Okay. So you will be getting, I feel so, 100 plus minus 50. So 150 and 50. So when you would be considering principal stress to be 150, okay. So 150 is going to be less than equals to SYT upon N. So N will be coming out to be 2. As same nature of principal stresses, MPST, MSST will give same result. So A should be equals to B, which is in A and B. So obviously C and D cannot be the right options. Then you know that MDET is going to be more safer. So that will be giving you more factor of safety. So answer will be B for this. Okay. Sir, your Tom marathon is enough for good revision. Nah, as I got gap with Tom for revision and learnt it from. Okay. Madhuvamshi, I would like to say that whatever I have taken is enough. But definitely in marathon, when we are going for, this is a revision session. So if you are not good at the concept of any chapter, then for that, I don't know whether you are getting it properly or not. That reason I cannot say. But otherwise, conceptually, I have covered, you can see in the nice way. But still, you can go for the questions. You will get to know after solving the question that whether it is prepared for you or not. Okay. But yes, I am covering everything. That is for sure. But without derivations. Okay. Not me. Everybody in marathon will be not going for derivation. So now we are talking about MDET. For MDET, if you are going for pure torsion, sigma 1 plus tau, sigma 2 is minus tau. Then you know that sigma 1 square plus sigma 2 square minus sigma 1 sigma 2 is equals to SYT square. So you will be putting tau ka square plus minus tau ka square minus tau into minus tau is SYT ka square. So you will be getting tau is less than equals to, or tau is equals to SYT by root 3. So you will get SYS to be 0.577 times of SYT. Is it clear for everyone, guys? Very good question, Advait. If both SYT and SUT are given, for ductile material, we will write SYT. That already actually I have answered. For brittle, you will have SUT. In the starting of theory of failure, I answered this question. For ductile material, we will go for SYT, and for brittle material, we will go for SUT. Because brittle materials do not yield. Okay. Moving to the last theory, that is maximum principal strain theory. Sigma 1 minus mu times sigma 2 is equals to SYT. Sigma 1 is tau minus mu times of minus tau SYT. You can write tau is SYT by 1 plus mu. So SYS is SYT upon 1 plus mu. I feel you got it. Wonderful, guys. Malesh. बहुत बढ़िया यार. Moving to the next question. Design of machine element under fatigue loading. Okay. So are we ready? Shall we start, guys? Are we ready? Shall we start, guys? Okay. Fatigue loading. So we are entering into chapter number 3. Okay. This is the chapter number 3. We have completed the introduction chapter, then theories of failure. Now we are having fatigue loading. After fatigue loading, we will enter into brakes. After brakes, we will enter into bearings, then joints, then gears, and then shaft and spring. Let us see what is fatigue loading. So guys, if magnitude, okay, let me take the water first. Yes, yes. So when we are talking about the fatigue loading, what do you mean by fatigue? So guys, if magnitude or direction or both, if magnitude or direction or both changes with time for a load, such type of loading is said to be the fatigue loading. We call such type of loading to be a fatigue loading. My dear, generally fatigue loading, as magnitude directions are changing, that creates micro cracks in the material. Because of that, vibrations also results, and that is why fatigue loading is said to be the more dangerous type of loading. Because of this, vibrations are coming into picture, and you know vibrations are inevitable. Vibrations, you know already, but we are going to discuss on Saturday. There I will prove that force damped vibration, when we will study, that you cannot make their effect to be zero. They will always be present in the system. So you need to design your system as per that. So that design we are going to do here. Okay, because vibrations are inevitable, we need to design the system for that. So that is why we are designing here. When vibrations are there, components are going to fracture after some duration. So in this chapter, our target is to find out that duration up to which a system will work, so that after that system is going to fracture. Before that, we change the system. Like I get to know when the fan, ceiling fan is going to come down, is going to fall from the position, then before that I'll be changing that. That is the criteria, that is the understanding of fatigue loading here. So when we are talking about fatigue loading, it is of four types. First type of fatigue loading is completely reverse loading. So my dear, if fatigue loading is said to be completely reverse loading, if maximum and minimum magnitude is same, like if maximum value is +5, minimum is -5, I will say it is completely reversed, because +5 and -5 are completely reverse of each other. So the condition will be explained as, if the magnitude of maximum, magnitude of minimum is same, we will call this loading as completely reverse loading. Very good, Ajay Krishnan. Then repeated loading. If the minimum value is 0, then we will call it as repeated loading. Fluctuating loading. So my dear, if we are going to have variation of stresses unidirectional, it is varying from +2 to +5, only magnitude changes, direction do not, then such type of loadings are said to be fluctuating loading. Last one is alternating, as the name suggests. One is plus, other is negative. But my dear, maximum magnitude and minimum magnitude are not same. Then it is said to be the alternating loading. These are the four types of loadings. So my dear, when we have seen four types of loading, completely reverse loading is said to be the most dangerous type of loading out of that. So now we will see the terminology of that. Maximum stress is denoted by sigma max, minimum is denoted by sigma min. Mean stress is denoted by maximum plus min by 2. Then amplitude stress is denoted by maximum minus min by 2. Maximum minus min by 2. It is also said to be stress variable or amplitude stress. Stress ratio is defined as minimum by maximum. Range of stress is defined as maximum minus minimum. Then amplitude ratio is defined as sigma amplitude by sigma mean. It is coming out to be 1 minus stress ratio by 1 plus stress ratio. If we are going to define everything for completely reverse loading, for completely reverse loading, this is plus sigma, this is minus sigma, this will be 0, this will be sigma, this will be -1, this will be 2 sigma. Can you find it? This is going to be infinity. Yes or no? Very good, Ajay. Moving further, guys, moving further. So guys, now we are moving to the next thing. Okay, next thing is Sir R.R. More experiment, where we are studying ascent diagram or Wöhler diagram. You know, Sir R.R. More have taken a special kind of specimen of this shape. This is the specimen which was having a minimum diameter of 7.5 mm at the center. The curvature is of 220 mm and length is around 85 to 90 mm. Okay. Then my dear, he have taken the bearing here and bearing there, and here they have connected it with the motor, because we want to make the loading to be fatigue. Loading is becoming fatigue when we are going to give rotation with static loading. For example, if we have a beam like this, we are going to apply bending. Under bending, this beam will be bending like this. You know that the stress distribution, when you will see at top, it would be compression, bottom will be tension. Let us say here stress is -5, here it is +5. This is static loading. Now if I give rotation to that, then after 180-degree rotation, A point will reach to B point. So +5 will be reaching to -5. So loading would be changing now at the same point. Why? Because the point itself is moving. So that is why static will become fatigue with the rotation. So that is why motor is applied. Here we have revolution counter. Revolution counter will count the revolution before the first fatigue crack will come. This is where we are providing the loading. Okay. So what we have done, we have started the experiment. Okay. And when we have done the experiment, how we have taken the result. We have written here loads, here amplitude stress, here number of revolution before failure or fracture. So when, let us say, there was some load W1, corresponding to that stress was ultimate strength. Material fracture without a single rotation, because at ultimate stress, fracture happens directly. Then my dear, we reduce the load to W1, and then for that stress or strength was reduced to 0.9 times of SUT, and because of that we have seen material component fracture after 1000 revolution. This is for mild steel. For other material this value can be different. Then my dear, we have changed the loading to some value Wn, for which material got failed at a stress which is given the name of endurance limit, and for that the number of revolutions were 10^6. So this was a very big number, so we stopped the experiment there, because we thought if a component survived that much, we will change before that 1 million of revolutions. At that time we have seen like that. And when the diagram was plotted between amplitude stress and number of revolution, so number of revolutions were going to 10⁶, which is a very big number. So we need a scale factor. So we have taken the scale factor of log base 10 on both the sides. Okay, because when we are taking the scale factor, now 10⁶ directly converted to 6. This is the best scale factor for such values. And when we have plotted it 0 to 3, the graph was having this value SUT to 0.9 times of SUT, and from this to this value changed drastically. Okay, here it is reaching to SC. If you are saying that SUT is coming in the range of 700-800, then you will find SC is coming in the range of 70-100. So that is why SC is very, very less. So as SC is very, very less, it is quite lesser than yield strength. So my dear, whenever a material or component failed before its design stress, that phenomena is said to be fatigue. So here component is getting failed much below the yield strength. That is why it is said to be the fatigue. So when you make this curve, here this angle is different, here this angle is different. So the point is, when component is getting failed before 1000 cycle, we call it as low cycle fatigue. And this failure's reason is said to be the yield strength. Here yielding is said to be the reason for the failure. Okay. And my dear, when we are talking about the high cycle fatigue, this is really considered as the fatigue failure. Low cycle fatigue failure is happening in the component like nuts, bolts, studs, okay, that kind of component. High cycle fatigue is happening in gears, in shaft, in spring, in bearings. So that kind of component. So that is why for us high cycle fatigue is more important. So from now onward we will be taking only that part of the curve. So we would be considering the curve from this to this. So our curve will be starting from 3. After that we have not done the experiment because we assumed before that point we will change the component. Like let us say if you have a fan in your home, that fan is having a life of more than 100 of years. You know that within 50 years, within 20 years at the max, you will be changing the fan. You're not going to keep it before that. Maybe those fans would be having a life of 200-300 years, but they are testing it for 70 to 100 years because they are expecting before that you will be changing it. So that is why we are doing the testing only up to certain point. after that we are assuming it will not fail. Why? Because you will change before that. So the stress corresponding to 10 to the power 6 revolution is given the name of endurance strength. And my dear, in reality, this stress, which is 10 to the power 6 revolution, is considered to be as infinite life, because otherwise we cannot go for infinite years for the experiments. So we are calling this 10 to the power 6 cycles as infinite life. And my dear, stress corresponds to this is said to be endurance limit. SYT is yield strength, SUT is ultimate strength. Both of them are the properties of material. So my dear, because of that, as yield strength and ultimate strength are property of material, if size changes, shape changes, anything changes, these values remains unaltered, because properties are independent of all these facts. But endurance limit changes with size, changes with shape, changes with surface finish. That is why it is not a property of the material. So unlike yield strength, unlike ultimate strength, this is not at all the property of a material. So please tell me guys, you got it or not? Keep commenting so that I get to know that you are there, you are listening to me. Is it clear guys? So this is something about SN diagram. So my dear, we have defined the endurance limit, low cycle fatigue, high cycle fatigue. Now we are reaching to the next heading, that is stress concentration. So guys, what is stress concentration? Actually, my dear, whenever we are having some abrupt changes of cross sections, so because of that abrupt changes of cross section, sometimes the stresses exceeds the normal values. Then my dear, when these stresses are coming very high as compared to the normal values, what are normal values? What it should be based on strength of material equation. So if the stresses are coming quite more than those values, we call this the stress concentration. And this is happening where abrupt changes of cross sections are there. For example, if we are having a hole, so when you are going from 1,1 to 2,2, there is an abrupt change of cross section. If we have a reduction or increase in area like this, so my dear, here also abrupt change in cross section is happening. If we have some kind of notch, this is also you will have the effect of stress concentration. If you have some holes to be drilled in a shaft, so wherever holes are drilled, there you will find the abrupt changes of cross section. So wherever you find the abrupt changes of cross section, you will find the stress coming is quite high as compared to the strength of material equation. Like my dear, let us say if we are going to have a plate like this. This plate is having a width of W and a thickness of T. Okay, and a thickness of T. And let us say we are having a load acting on this like P. If I ask you what will be the stress normally, you will say stress would be P divided by W into T. Okay, because everywhere cross section is same. Now if I make some abrupt change of cross section and I am going to drill a hole of D diameter, then you know that cross section is going to be minimum. Cross section is going to be minimum about this. About this, the cross section will be W minus D into T. This is the cross section. You know, if load is same everywhere, where area is minimum, stress will be maximum. Yes, Abdul. Thanks Abdul for your wonderful words. So I feel your preparations are going fine. So my dear, when we are having this condition, P divided by W into T, that will be changing to P divided by W minus D into T. Because if load is same throughout, if area reduced, stress will be maximum there. But this is as per the strength of material. This is given by the strength of material. When you are talking about the real values, they are coming quite more than this value. So when you are talking about the real values of stress, they are coming quite more than this value. And when you will find out the maximum value of stress, in reality, it is coming out to be some KT times of this value, which is said to be the nominal stress. Nominal stress is the maximum value of stress as per the strength of material equations. So, but it is coming KT time, where KT is said to be theoretical stress concentration factor. Okay. So point is how we will be finding out this. To find out this, we need to go for an photoelasticity experiment. You need not to cover that in much detail. I will give you some hint for that. There is a device known as polariscope. In that polariscope, what we are doing, we are keeping the component of same size and shape but made up of some synthetic plastic. Like we are going to make a material of resin, okay? So epoxy resin type of material. So we are making a component of epoxy resin or some synthetic plastic of the same size and shape. Why we are doing that kind of material? Because for doing photoelasticity experiment, we can use only such type of materials, because we need to see the stress concentrations, stress lines. So when you are going to putting your component, like this is the component na, so this is the component, I am taking half of that because I need to see the stress concentration. So this is the half of the component, but the component we have made is of synthetic plastic. Synthetic plastic. Actually, it is not made up of the mild steel. Real material is mild steel, but we are using for testing is synthetic plastic. So when you will be having the stress distribution, you will be finding the stress distribution is going to be quite more in the vicinity of hole. So your stress would be increasing like this. And the reason for that is the stress lines. Like if we have a component normally like this, then you can see the stress line in polariscope in the photoelasticity experiment. These are the stress lines which are going like this. But in the same case, if you are going to produce a hole like this, then the stress lines which are coming, they are same in number. Okay, but when they will be passing from here, they need to shift it like that. So they are coming same in number. So the same number of lines will be coming in the lesser area. So they will be creating more lines in less area. Because of that, the stresses induced in the material are quite more as given by the strength of material equation. So my dear, this value which we are saying as sigma maximum is found to be KT times of sigma nominal. KT is theoretical stress concentration factor. So guys, why it is said to be theoretical stress concentration factor? This is said to be theoretical stress concentration factor because you are taking some different material for the testing. So material is not same as mild steel, it is different. Second thing, real loading is fatigue, but in polariscope we are applying the static loading. So because of these two reasons, this KT is said to be theoretical stress concentration factor. Many people thinks that it is theoretical because we are calculating it theoretically. No, you have seen, we have found out it experimentally. In reality, when we are talking about the KT, then my dear, KT can be found out in the three ways: mathematical, experiment, and finite element analysis. How experimentally we can find out, you have already seen. Umar sir, 1000 reverse stress given, can we do 0.9s directly? Dear, if it is not mentioned, nothing is mentioned, then you have to take it, because for mild steel it is 0.9 times. But it have been seen in the previous year's GATE question that they are providing that for 1000 cycles the value is 0.7 times of SUT. So when these values are given, you would be taking the given values. If not given, then you can take it 0.9 times of SUT for sure, because you need to remember it only for the mild steel case, nothing for not for any other thing. Okay, so guys, experimentally how we can calculate, you have already seen. What is the meaning of mathematical? Like let us say we are given an elliptical hole like this. Okay, we are given an elliptical hole like this. For this elliptical hole, this is 2A and this diameter is 2B. And let us say, my dear, we are applying the load in this direction. So perpendicular to the load is 2B. So KT will be coming experimentally as 1 plus 2B by A. Everybody understand that? This is coming experimentally, let us say. So how we remember? Perpendicular to this load is 2B. So 2B will be coming here, 2B by A. This is coming experimentally. Let us say on some other day, we have the same ellipse but in this way. Okay. Or let us see in this way, that even we are having the shape of ellipse to be this only. But the point is, this time loading is here. So you know, perpendicular to the loading this time is 2a. So this time you are not going to once again do the experiment. You will directly write kt is equals to 1 plus 2a by b for this case. Similarly, on some day, if this hole is becoming circular, for circular wherever be the loading, you will say a is equals to b, kt will directly comes out to be 3. This is mathematical. We are calculating once with experiments, then we are using the mathematical techniques. Okay. Similarly, if someday they say that a is 0, this type of hole is there. Sometimes they say, okay, I am taking my own diagram. If sometimes they say this is the diagram and loading is like this. So if you were considering this a to be 0 and this is the 2b. So perpendicular to the load is 2b. So you will say kt is equals to 1 plus 2b by a. A is 0, it will be coming out to be infinity. For the same case, if loading is like this, you know that for this case, as perpendicular is 2a, so you will say kt is 1 plus 2a by b. Here this time you know that this distance is 2b. This time a is 0 will give you 1 only. So this is how we are going to see the things. Please tell me everybody got it or not. So this is said to be the mathematical analysis. I can show you also, many students feel that whatever we are talking about is theoretical. So I can also show you that. Okay, for that I need to show you a small thing. I also show that in the classes. Those who know, those who have seen last year marathon, there also I have told you. Okay, so let me take a small page for that. Okay. Okay guys, I am showing you this. Let us say this is the sheet in front of you. Okay, so if I will apply a load like this, you know that sheet is not going anywhere. Okay, it means this time kt value is 1. Okay, now if I will be making a hole perpendicular to the load, this is the condition same as this a is 0. You can feel it. So when a is 0, I can show you this with more clarity. A is 0. So now if a is 0, this time if I will be applying the force like this, you can see in the first attempt it got failed. If you are thinking I am applying more force, you can try this at home. This experiment can be done without Ajay Devgan. Okay, so you can do this by your home, at your home. Okay, very easily. Shreyas, okay, fine dear. So my dear, this we have already seen. Now if the same hole is done like this, this time I am applying the load, you can see it is not going anywhere, similar to without hole case, because this time b is 0. Okay, kt is once again 1. I am applying the same level of forces, no difference. You can try this. Okay, so this is the beauty of the concept. I feel you understood everything. Shall we move on now? Today I feel Teju is not there, Jabir is also not there. Some students have already done MD. Okay guys, so moving to the corrected endurance strength. Yes, Bhomik, are you getting it or not? Yes, Malesh, very good. So my dear, now we are moving to the corrected endurance strength. You already get to know endurance strength. Very good, Surya. So you already know that endurance strength is not at all a property. So as it is not at all a property, it have been seen, it even changes with the surface roughness. It even changes with the size. It even changes with the shape. Okay, Umar. Fine, Kartikeya. So as I said, my dear, if diameter is going to change, like Sir R.R. More have considered the diameter of 7.5 mm. Sir R.R. More have taken diameter of 7.5 mm. So if you are going to take diameter more than 7.5 mm, then my dear, you would be getting different values, because endurance limit is depending on size, shape and surface finish. So that is why corrected endurance limit is defined as Ka, Kb, Kc, Kd and n number of such factors into Se. This Se is the endurance strength given by Sir R.R. More experiment, and the diagram made is said to be the Wöhler diagram. SN diagram is said to be Wöhler diagram. So this value is from that experiment, and this is the value you have to use, because your component may have different size and shape. But in general we talk about only 4 factors, but if any other factor is there, they will give you in the paper. So when we are talking about these 4 factors, Ka is said to be the surface finish factor. Ka is said to be the surface finish factor, and Ka is given as A times SUT to the power B, and here A and B are said to be Shigley and Mischek constants, based on the name of researchers who were doing the work onto this. This is from the data book, you need not to remember it. Okay. Then my dear, if the surface finish is mirror polished, if surface is mirror polished, Ka will becomes equals to 1. Then Ka will become equals to 1. Kb is said to be the size factor. Okay. If my dear, we are talking about the size factor, if your diameter is less than 7.5, just like Sir R.R. More's experiment, your Kb is 1. If D varies from this to this, Kb is 0.85. If it is more than 50, Kb is 0.75. Once again, these are from data book. You need not to remember it. In the paper, these values would be given to you. Okay. Then we are talking about the reliability. Then my dear, if reliability is more than 50%, 50%, Kc is 1. 90% 0.897. These are the values once again from data book, you need not to remember. The point is, what is reliability? So my dear, reliability means how much reliable is someone. Like if you are in problem 10 times, one friend is coming to help you 9 times. He have a reliability of 90%. So 9 out of 10 times he is going to help you. So we will call it as a reliability of 90%. Okay, so this is the reliability factor. Okay, so I feel you got it. This is reliability factor. Then we are moving to the next factor is Kd. Kd is said to be the factor that account for stress concentration. This is factor which accounts for stress concentration. So this is said to be the Kd. And my dear, when we are talking about Kd, Kd is defined as 1 upon Kf, where Kf is actual stress concentration factor. It is actual stress concentration factor. Actual stress concentration factor. Okay. What is actual stress concentration factor? So my dear, we have seen theoretical. Theoretical is coming from experiment, and that is in the central polariscope. Experiment was photoelasticity. But when we are talking about this Kd, my dear, Kd or Kf, this is the actual. It is like when you are going to someone and ask how many years I will live, then my dear, he can predict your age, okay, based on his kundli and all. So he can predict it. That is a theoretical thing. But the real, when really you will die, that would be your actual age. Okay. So Kf will be coming when actually a component is going to fracture. But if the component is fracture, what we will get to know about the age? Then what we will do? Nothing. So that is why Kf you can get only about exact absolute failure, absolute fracture. So that is why we are not using Kf values generally. We are going with Kt values. But if they are giving Kf, you can use it. But in reality, everything is done by Kt values, because Kt we have, Kf we don't have. Kf we have after failure or fracture. So after failure and fracture, we cannot use those values before failure and fracture. because kf values are not known to us before. Okay, is it clear to everyone? Please tell me. Let me share it again. Yes guys, are you getting it or not? Just like and share the session so that other students can also be benefited. And please tell me, are you getting it or not properly? Please tell me, are you getting it properly or not? If any doubt you have, do ask me. If any doubt you have, do ask me, guys. Wonderful, guys. बहुत बढ़िया, बहुत ही बढ़िया. So guys, now we are talking about notch sensitivity. Notch sensitivity is defined as the sensitivity of a material towards notches. The sensitivity of a material towards notches is said to be notch sensitivity. So when we are talking about notch sensitivity factor, so notch sensitivity factor is defined as, it is defined as the actual increase in stress due to stress concentration divided by theoretical increase in stress due to stress concentration. Okay, due to stress concentration. So you know, actual means what? Sigma naught is becoming kf times sigma naught, and theoretical means sigma naught is becoming kt times sigma naught. So actual increases kf sigma naught minus sigma naught. Theoretical increases kt sigma naught minus sigma naught. So you can also define it. Very good, Ajay. You can also define it. Q can be written as kf minus 1 by kt minus 1. It was asked in one of the previous year's GATE paper, so it is important. So when we are talking about kf minus 1 by kt minus 1, notch sensitivity factor. So when we see experimentally, you are getting the Q values lying between 0 to 1. 0 is for insensitive material. Okay. 1 is for extremely sensitive material. So my dear, when we are going to take minimum and maximum value of Q, when Q is kept to be 0, when Q is becoming 0, you will be getting Kf is equals to Kt. And when you are going to have Q to be equals to 1, sorry, Kf is equals to 1, sorry. You are going to have Kf is equals to 1. Kf is equals to 1. Here you will be having Kf is equals to Kt. So what we get to know from here, that actual stress concentration factor varies from 1 to Kt value. 1 to Kt value. So when it is varying from 1 to Kt value, means Kt is the maximum value of Kf. So my dear, what do you mean by that? If we are designing with Kt, we are doing the best design, because Kf can never be more than Kt. So that is why design is always done with the theoretical values, never with the actual values. Actual value we don't have actually. So guys, that is why Kt is used for the designing purpose. Okay. So I feel everybody got it. This is notch sensitivity factor. Now we are moving to the second last part of the chapter, that is fatigue diagram. Then we will be entering into the minors rule. With that the chapter will be over. So within 20 more minutes I feel chapter will be over. Then we will be entering into breaks. Okay, I'm not talking about lunch break, I'm talking about breaks, topic breaks. Okay, so let's move further. Fatigue diagram. I already told you, my dear, what is the fatigue phenomena. Okay, so like in reality the material is getting failed at SYT. In reality the material or component is getting failed at SYT. But my dear, in our cases we are saying endurance limit is the failure stress. So in reality material was about to fail at 210, incorrectly, rightly it is getting failed at 70. So if material is getting failed at a value much before its real failure stress, this phenomena is said to be the fatigue. So my dear, when a number of materials were considered, and we have seen their values of failure in terms of amplitude and mean value of stresses, we found out a lot of failure points. Different researchers have done that. Someone have done the test for mild steel, someone has done for aluminium, someone have done for magnesium, and they have plotted the failure points, and they got that kind of scattered region. We cannot use this region. That diagram is said to be fatigue diagram actually. So my dear, then some of the researchers tries to conclude that. So those who have concluded, what they have done, first of all, Soderbergh came. He said, here I will choose YT, here I will choose endurance limit, and I will join it. And this line was given the name of Soderbergh criteria or Soderbergh line. You know that we can write the equation for Soderbergh as this is sigma m by SYT, sigma A by SC is equals to 1 by N. Is it clear or not? Wonderful. Then my dear, another researcher came. Goodman was the name. I'm not saying Goldman, I'm saying Goodman. So Goodman said here SC is fine, but here it should be SUT. And his line was represented as sigma mean by SUT, sigma amplitude by SC is equals to 1 upon N. And then my dear Gerber came and he have done the Gerber. He said the points are correct, but it would not be a straight line. It is going to be a parabola. And this parabola is of this nature, sigma mean square upon SUT square plus sigma amplitude upon SC. I will say this to be 1. Why? Because how this factor of safety is coming? In reality, the equation is like this. This is the equation. So when we are putting SYT to be SYT by N, when we are putting SC to be SC by N, then this equation changes to sigma mean by SYT plus sigma amplitude by SC is equals to 1 by N. This is how the equations are going to change. Similarly, my dear, when we are talking about the Goodmans, sigma mean by SUT plus sigma amplitude by SC is 1 by N. It is coming because you are dividing it with N. Here when you will be doing, you will be getting sigma mean square upon SUT square into N square plus sigma amplitude by SC into N is equals to 1. So this time I cannot divide it by N because you know we are not really dividing by N. We are just putting the strength by N to be the permissible stress. That is what we are doing in reality. Please tell me you got it or not, then we are moving further, guys. Please tell me you are getting it or not, then we are moving further. Is it clear? Very good, guys. Very good, guys. Moving further, guys. Okay, moving further. So this is the fatigue diagram and fatigue equation. Now I would like to tell you one more thing, that there are some other things also. There is said to be a yield line. There is something called as yield line. So yield line was taking here also SYT, here also SYT. That line was given the name of yield line. That line was given the name of yield line. Is it clear? That is said to be the yield line. And similarly, there is something called as ASME ellipse. That ASME ellipse was having SC here and SUT here. That ellipse was like this. So the equation for that is sigma mean by SUT का square, sigma amplitude by SC का square is equals to 1. Okay, obviously you can write it 1 upon N square because here both the side you have SYT का square or SC का square. This is said to be ASME ellipse. But questions are coming only from 3. Soderbergh, Goodman. Even Gerber question have not been coming. Now Umar was asking about modified Goodman. Actually, modified Goodman is just a modification on the Goodman, But till now, whatever the question have been asked from modified Goodman, they also have been solved by Goodman only. So you have made the Goodman like this. This was the Goodman. This was SC. This was SUT. Okay. I just told you yield line. What was yield line? Yield line was like this. Yield line was like this. This is SYT. This is SYT. So modified Goodman says, Umar, are you there or not? Modified Goodman says, from this to this, consider the Goodman. After that, consider the yield line. This is the modified Goodman. This is the modified Goodman. Modified Goodman. So for modified Goodman, you cannot directly write any equation because it is not a line. Okay. So that is why when this is asked generally, questions are solved by Goodman only. So it is not very important, but once it came into the paper, and guys, I will be having a practice session also for you for machine design, but that I am not taking today because I found now you guys are getting tired after 8 hours marathon. Then you go for self-study, you don't have time because next day once again marathon is there. So this time I am keeping the practice session on Sunday. And on Sunday, I will see some of the questions on this type of thing. Modified means all new questions I am about to take on machine design. So just be there for that session. You will get a lot of new things in machine design. On Sunday, I am already announcing this. Sunday, I will not keep it midnight. We will keep it 9-10 p.m. Okay, that is how we are going to say. That's why Umar I said, not only on this, there are all the topics from which questions are desired. So, okay, so I don't have statement right now, but on Sunday, I am announcing right now. On Sunday, in 9 p.m. or 10 p.m. This would be the time so that you can easily attend. This would be a MD practice session. MD practice session, where I will be covering everything, all the types, and the number of questions would be around 30 to 35 because I will cover entire machine design in one shot. Okay. Everything would be there. Everything would be there. Okay. Yes. Fine, guys. So we are moving further. So guys, we have already seen, okay, one thing I would like to say, for ductile material, we will be following Soderbergh. For brittle materials, we will be following Goodman. Okay, and this is when, if nothing is mentioned, if they say there is a mild steel shaft, aluminium shaft, you will go for ductile. If they say cast iron shaft, you will go for that. Otherwise, if they give the name, use Gerber equation, you will do that. You know, there is no question from Gerber till now, but in my practice session, I will keep 1 to 2 questions on Gerber also. So my practice session of machine design will cover everything. That would be the complete machine design CTQ. Okay, because this is a numerical subject, practice is required. Okay, but in marathon, if we go for practice, then we are not able to complete the syllabus. That is why we are keeping in that way, and you get a time gap of 2 days for revision also. Okay, moving further. So guys, now we are talking about effect of stress concentration on different types of material. Effect of stress concentration on different type of material. One type of material is ductile, other is brittle. Okay, for ductile material, under static loading, the effect of stress concentration is not considered, because in static loading, material, you know, plastically can deform. So in ductile material, as it can deform plastically also, so it adjusts itself and neglect the effect of stress concentration. But in case of fluctuating loading, you need to take. For brittle material, you have to take, because here yielding is not there. Okay, so this is about the materials. 1 mark question can be there from this. Now, my dear, we are talking about cumulative fatigue. Cumulative fatigue is the case when we have different types of loadings in the entire lifespan. Like, my dear, I have given you an example, like you are living in Delhi. In Delhi, the average age of the person is, let us say, 50 years because of very high pollution. This is not the correct data. I am just taking an example. In, let us say, Dehradun, this comes to 60 years. In, let us say, Shimla kind of city or Dharamshala like, it is 70 years. So when you see data, at that time you were already of 20 years. So after you have already passed one part of your age, 20 years, you get to know this fact. You say it is very risky to live in Delhi, but at that time you already have completed your this part of life. Okay, this part of life is already completed. It is 40%. Now you said, okay, in Shimla maybe I do not get the job, I can do job in Dehradun. So you went there for 20 years. So you live there for 20 years. So 20 by 60, 1/3 part of the life you are going to use there. Then rest life you say, I will be going to the hilly areas to increase my life. So rest part you would be living here. So this is said to be the cumulative fatigue, where you are living in different areas, where life is different. So overall life will be combination of these. Like let us say 40% here, 33% here. So rest 27% here. Yes or not? Rest 27% here. So the summation of these three will be 100%. So total life would neither be 50 nor be 60 nor be 70. It would be somewhere else. Okay, so this is said to be cumulative fatigue. Likewise, you know the ascent diagram. You know the ascent diagram. You know that material can have a life of n1 revolution if it is subjected to sigma 1. A material can have n2 revolution for a stress of sigma 2. A material can have n3 revolution for a life of, n3 revolution for a stress of sigma 3. These are the values for sigma 1, sigma 2 and sigma 3, n1, n2 and n3. Okay, but material was not there at sigma 1, not at sigma 2, not at sigma 3. It was there at sigma 1, for which the total life is n1, but it was there only for this much number of revolution. Like you were here only for 20 years. Then similarly for sigma 2 you were there for n2. Like for sigma 3 you were there for n3. It can be more than 3 also. So when you will be saying that entire life is 1 only, then what you will say? You will say that n1 plus n1, n2 plus n2, n3 plus n3 will be 1. And if we are knowing the exact life is n, then you can write n1 by n1. How it can be written as alpha 1 times n by n1. What is alpha 1? Alpha 1 is the fraction of this. So once you know alpha 1, alpha 2, alpha 3, you can make this equation to this, that is said to be the cumulative fatigue failure or Minor's rule. With this chapter is also over. Let us see if I have the statement. We will solve one question at least so that you get some confidence on this. Let us solve this question. Fine, let us solve this question. A forged steel link with uniform diameter of 30 mm. Diameter of 30 mm, you can find out the area. Pi by 4d square. After getting the area, it is given as P minimum is minus 40 kilonewton. You can find out sigma minimum. P minimum by area. P maximum is 160 kilonewton. So you can find out sigma maximum as P maximum by area. Okay. You need to find out the factor of safety using Soderberg equation. So when we are talking about the Soderberg equation, what it says? It says sigma m by SYT. sigma amplitude divided by SC is equals to 1 upon n. You know that once you know minimum and maximum, sigma mean is max plus min by 2. Okay, and sigma amplitude is max minus min by 2. Just use it, get the answer. Use it and get the answer. Guys, just like and share the session so that others can also join it. Hope you are enjoying the machine design. Solve it, solve it. Solve it, guys. What would be the answer? Umar, Bhomik. What would be the answer, guys? Yes. Okay, SYT, SUT are not given. Okay, okay, okay. SYT and SUT are missing here. Okay, take. Actually, I do not remember the values of SYT and SUT. Take SYT as 240. Sorry. SE as 240. SYT as 420. Do not see the options because I have given you the values arbitrarily. Okay, so take these values. Actually, I feel it is by mistake it is missed in the question. Yes, yes, yes. Solve it with that. Okay, and SUT is not required actually, but still I am saying it is 600. Solve it now. Yes. Now I feel you can solve it, guys. Wonderful, wonderful. So we are at the completion of the chapter. One more question to go, and then we will start the breaks. I feel my data is perfect then. Okay, if you are getting 1.26, it means my data is perfect. Actually, it is a previous year's GATE question. So that is the reason I remember the exact values. So 1.26 is correct. Very good. So guys, this is how you can solve this. Now we will talk about one more question that is also from previous year's GATE. This is from SN diagram actually. This is from SN diagram. Don't worry, on Sunday, none of the question will be PYQ. You know, you need to make the curve like this. 3, 4, 5 and 6. So this is what you need to do, guys. This is what you need to do, guys. Okay. So you know this value is 0.9 times of SUT, but log base 10. This is log base 10n. So he is giving you these two values, and you need to find out if the stress is going to be 100 MPa. For 100 you need to find out this x, and once you will get x, 10 to the power x will be your answer. Yes, many of you may be remembering also. So how you will use it? Log base 10, 0.9 times of SUT minus log base 10 ST. So this side I have taken, divided by this, because the similar triangle concept I am using is equals to log base 10.9 SUT minus log base 10 100 divided by x minus 3. This is the second triangle I am using. So this is the concept of similar triangle. You will get x and you will get the answer. Yes, solve it guys, solve it. Solve it guys and give me the answer. Solve it guys and give me the answer. Vineet have given the answer to be B. B is correct answer. Actually, you will be getting x to be 5.459. So when you will be putting this, you will be getting n to be 281914 cycles. Okay. Dear, it is mentioned now. He is saying that fatigue strength for 1000 cycles. For 1000 cycle, it is 0.9 times of SUT. Okay. Then he is saying that corrected endurance strength. Corrected endurance strength is SC. Okay. And you need to find out for this amplitude stress. Kartikeya, Bhomik, Ajay Krishnan. Wonderful guys. Malesh. Very good. So answer will be B for this. With this, fatigue loading is over. The method to reduce the stress concentration. If you already have a notch like this, then my dear, you can reduce the stress concentration by providing additional holes, or you can provide additional notches, because by this lines will go straight and there will be no stress concentration like that. If you are having a change of area like this, provide the fillet like this. Abrupt change of area should not be there. Then lines will be having lesser concentrated. Okay. So by these things, by providing additional holes, you can do that. When you go for the ascent diagram, Umar, I didn't get what you want to say. What is 1.265? Okay, for you are slightly behind, I feel. Okay, but the answer is correct. So when we are talking about for aluminium and magnesium, for aluminium and magnesium, ascent diagram is coming like this curvature. It is not having any sharp point. Okay, so that also should be known to you. I have told you the value for that. Moving further, guys. Moving further. Okay, now we will be entering in the breaks. Everybody is ready for the next chapter. We have already completed how many? We have completed loads. We have completed theory of failures. We have completed fatigue loading. 3 chapters are over now. We are entering into the 4th chapter, which is brakes, and this is a smaller chapter. This is not a bigger chapter. Okay, this is not a big chapter, this is a small chapter. After that, bearing is bigger chapter. After that, 2 chapters are there which are big. After brake, one is bearing, second one is joints. Okay, after these 2 we have gears. So today it is not going to be 7-8 p.m. Don't worry. This would be hardly completed by 4 or 5 p.m. Not more than that. It is small subject. If other subjects are of 80 hours, it is of 40 hours. So obviously it is going to be half of that. So now we are talking about the brakes, my dear. So when we are talking about brakes, brake is defined as a mechanical device, first of all. And when we are talking about it is a mechanical device, wherever it is used, if something is there in the motion, you want to stop the motion, brakes are used. Okay, that is wrong, Umar. In that case, that is wrong. It is PYQ, na? When he is saying for 1000 cycle, it is. Ha, that is directly. That's correct, Umar. That is correct. You are doing it nicely. Fine. It is, but it is the value of 0.9 times of SUT. You have done it nicely, correctly. No problem. We are doing that only because they are directly saying for 1000 cycle, it is 490. So this is the value of 0.9 times of SUT. This is the value of 0.9 times of SUT. I feel you are behind the class. Just come live once again, because we are entering to the next chapter. So Midun, clutches we will be covering with the bearings. Brakes we are covering here. Brake is different, clutch is different. Yes, in the previous years they give it in the same chapter. So my dear, brakes are used when something is moving, you want to stop that. So for stopping the motion. If something is going with the high speed, you want to reduce the speed for retardation. Similarly, if something is at rest, to keep it at rest, also brake is required, like lift and escalators, where already when body is coming at rest, to hold it at rest also brakes are required. So these are the application where brakes are required. In the brakes, we are generally converting the potential and kinetic energy. Potential and kinetic energies, they are getting changed into the heat energy. Like whenever something is rotating, it is having high kinetic energy. When you will be applying the brakes, what you are doing? You are providing friction for that. By providing friction, you would be converting the kinetic energy of this drum into the heat energy and give it to the surroundings. So that is done with the help of some element like shoe. This is said to be shoe, or some kind of steel bands. Okay, so either you will be using the steel bands or you will be using the shoes. So that is how the brakes are going to be defined. So my dear, when we are talking about the types of brake, there are some brakes said to be mechanical, others are electrical, other is hydraulic and pneumatic. Okay, so when we are talking about pneumatic, hydraulic and electrical, they are used for high absorption of energy. When high energies are to be absorbed, we use them. But in our syllabus of machine design, we need to study only mechanical brakes, which are used for low power absorption. Low power absorption. Okay, the example of this is block brake, band brake. We need not to study this. Block brake, band brake. Then block brake is said to be small shoe brake and long shoe brake. Band brake is simple band brake and differential band brake. They can also be single shoe and multi shoe. Single shoe and multi shoe. So this is how we are going to classify the types of brakes, guys. So when we are going to move ahead, this is the diagram of a shoe brake. So you can see this is the drum rotating in this direction. And when you are having this drum which is rotating in this direction, my dear, first of all, I would like to say that this element which is said to be shoe or block, this is having some friction lining, which will try to take the kinetic energy of the drum and will take it to the surrounding, give it to the surrounding. So my dear, you can see this is making some angle with the center. If that angle, I am denoting it with the 2 theta. So if this 2 theta is coming out to be less than or equals to 45 degree, then we will call it as small shoe. Then we will call it as small shoe. And if this 2 theta is going to be more than 45 degree, it is said to be the long shoe. It is said to be the long shoe. Is it clear for everyone? It is said to be the long shoe. So this is how we define small shoe brake and long shoe brake. So my dear, now we are going to do the analysis. Actually, every time they are not going to be in contact. Actually, this is going to be the drum and this is going to be the shoe, like this. Okay, so they are not in contact. When we want to apply the brake, then only we apply the force onto this so that they come in contact. Like here I have shown them in the contact. Okay, so my dear, for that we need to apply the force here. That's why when you will apply the force here, contact will be maintained. Now my dear, we are having some assumptions here. The first assumption we are having that this shoe is the integral part of the lever. Means when you will be making free body diagram, you cannot take shoe different than the lever. Means this lever and shoe are same element. They are not different. Second thing, we have taken the rotation to be clockwise. Yes, if rotations are anti-clockwise, results would be different. Sir, in some books it was mentioned 60 degree. No, that is wrong TPM. 45 degrees correct. Okay. So my dear, you can share it to me if you have seen that in some book. Share it with me. I will cross check it which book, whether it is correct or not. Maybe sometime they put it wrong. Then in the new edition they are going to correct it. So my dear, this is something, the second thing. Okay. So first thing is this is integral part. Second thing is what we have said, it is clockwise rotating. Okay. And my dear, third thing is that this angle is less than 45 because we are going to study for the small shoe. So now we have already decided everything. We are going for the free body diagrams. When you will see the free body diagram, first of all, this is how the shoe brake looks like. Okay, you can see this is the diagram for the shoe brake. So when we are going for the analysis, my dear, I have taken drum aside and lever aside. For the drum, you have a normal reaction like this and friction force like this. Why? Because it is rotating in this direction, friction will oppose it. So my dear, because of that, if you want to find out the frictional torque here, it would be mu and r. Mu and r are given to you in the question. We require n value. N is the normal reaction force. So if we require the n value, for that we will use the lever. N value will be coming here like this and mu n will be coming here like this. It is action reaction pair. If lever will apply to the drum here, drum will apply to the lever here. And my dear, we are going to have F in this direction. Is it clear? Is it clear? So this is n, this is mu n like this. So you know this is hinge point. So we need to take summation moment about O to be 0. You know this F is creating anti-clockwise. So I will write minus F into B. Sorry, A plus B. Then my dear, we are going to have this mu n also anti-clockwise. So minus mu n into C. Then we are having n to be clockwise plus n into A. So what we will be having here, F is equals to n minus mu C plus A plus B. We can also write F to be A minus mu C into n divided by A plus B. This is the braking force required. This is the braking force required. So these are the expressions for the braking force, my dear. And if these are the expressions for braking force, here will be three cases. If A is coming equals to mu C, then braking force will be 0. This condition is said to be self-locking, which we do not want. This is the condition when brake will be applied without any force. So it will not be at the will of operator. That is undesired condition. Second condition, you can have A to be more than mu C. For that, F would be coming out to be more than 0. But as friction is negative, it means friction is trying to help us. We are applying the couple in this direction. Friction is also applying the same direction. So friction is helping us. When dushman ban jaye dost, here enemies are becoming friend. This condition is self-energizing. When our enemies are becoming our friends, that is the best condition now. That is the self-energizing. This is the desired condition. And my dear, when you will be having A to be less than mu c, force will be coming out to be less than 0, that is the uncomfort. Here driver will be getting some kind of reaction from the brake side, which is uncomfortable, never is desired. Okay, so this is how the three conditions are coming, but they are coming for clockwise rotation. If the rotation is going to be anti-clockwise, then my dear, this neither self-energizing will come, okay, nor you will be getting self-locking. It would be normally braking force will be coming out to be positive, but friction will not be helping. You can see. So whatever we are getting these three conditions, that is depending on how many things. One thing is it is depending on A, B, C and mu. Second thing, it is depending on the direction of drum rotation. So these are the two things on which it is depending whether we will be getting self-energized or we are going to get self-locking or we are going to get uncomfortable. So if any of these are going to change, the conditions will change. So this we have derived it for clockwise. When you will be having the anti-clockwise rotation, then what you will get? For anti-clockwise rotation, this will be coming out to be A plus mu c times of n divided by A plus B. So guys, you need not to remember this analysis. You need to repeat whatever I have done. How repeat? You need to take first of all FBD of drum, then FBD of lever. If you are going to do these two FBD, finally you have to find out mu and R. Mu will be given, R will be given, F will also be given. So F will be known to us, A, mu, C, B will be known to us. You can find out N from here, put N here, get TF, that will be your answer. This is how the questions are framed in the paper. Okay, are you getting it guys properly? This is about the drum brake. So my dear, here we are having multiple brakes. So in case of multiple brakes, you just need to do this two times mu and R. Okay, two times it will be there if coefficient, if both the shoes are same. If both the shoes are not same, then it will be mu1 n1 R, because drum radius is R only. Then this will be the case. This is the case of double shoe brake. This is the case of double shoe brake. This is the case of double shoe brake. Then we can have long shoe also. So my dear, there are two types of shoes when the 2 theta is less than 45, when 2 theta is more than 45. So when we have the small shoes, like here we have taken the small shoe like this. When you see the pressure distribution for small shoe, it is uniform pressure distribution like this. When we are going to see for the long shoe, if we have a long shoe like this, long shoe is like this, which is making more angle, okay, which is having more angle, which is having 2 theta to be more than 45 degree. Here what you will see, the pressure distribution is coming out to be different. Pressure is not coming uniform. For this, pressure is coming like this. Like this. Pressure is becoming maximum at the center. So when pressure is varying like this, some part of the brake shoe will be getting wear off soon. And if one part of the shoe is going to wear, shoe will not be able to work. You need to change the shoe in that case. So that is why if we are changing the shoe every second day, third day, it is going to be very costly for us. So this is not at all acceptable. So when we are going to have long shoe, we are not going to have them in the form of welded joint, but we are going to pivot it like this. We are going to pivot it like this, like this. The shoe will be like this. Okay. So when it would be pivoted, it can definitely rotate about the turning pair. So because of that, it adjusts itself automatically in such a way that overall pressure is somewhere coming out to be uniform only. So it adjusts itself by that rotation. That effect of curvature is almost neglected. So my dear, what is the difference in the formula if we are going to talk about the long shoe? When you are using the long shoe, angle is more than 45 degree, then frictional torque is coming like this. 4 sine theta by 2 theta plus sine 2 theta. This 2 theta will be in radians. Always remember that. And when angle is less than 45 degree, then you have already seen frictional torque is mu and R. That is the difference. Rest all things remain the same. Okay, rest all things remain the same. Moving further guys. Now we have completed the shoe brake. we are moving to the drum brakes. So my dear, when we are talking about the band brakes, now when we are talking about the band brake, there are two types. One is simple, other is differential. So when we are talking about the band brake, here we are going to have a steel band of this shape. Like this is a band, this will be the band. Okay, it would be having some width, some thickness, that kind of band will be there. Let us say this is rotating drum. So on this rotating drum, when this band will be coming and you are going to apply the force like this, then it will try to restrict the motion by providing the friction. This is what is going on. So you know, on the drum, you will be having two sides of band like this. Now if both the parts of the band are coming in such a way that one is passing through the fulcrum. If one is passing through the fulcrum, one is passing through the hinge, then that is said to be simple band brake. And if both are not passing through the hinge, it is differential band brake. Okay, so this is how we are going to define simple or differential. So in this band brake, you can see first of all how FBDs would be drawn. You will always be given the direction of rotation. Without direction of rotation, you cannot decide the tension in the drum. In the chapters of engineering mechanics, you have seen that if we are having a pulley like this, then one pulley, second pulley, driver and driven. You know, one side is tight, other is slack. So here tension is T1, here tension is T2. And you know T1 by T2 is given as E to the power mu theta. Okay, so what is going to happen when it is going to rotate like this in clockwise direction? To stop this, we need a braking torque in opposite direction. So my dear, you would be getting a tension T at this side, tension T at this side, obviously. But my dear, which one will be T1, which one will be T2? If this is T, this is T dash. Can you tell me which one is T1, which one is T2? Can you tell me guys which one is T1, which one is T2? Can you tell me guys which one is T1, which one is T2? Can you tell me guys which one is T1, which one is T2? Yes, left one is going to be T1. Why? Because you need more in this direction. So it is T1, it is T2. So you can say that this braking torque will be given as T1 minus T2 into R. This is one equation. This is second equation. Theta will be in the radians. And if we are going to take summation moment about O to be 0, summation moment about O to be 0, you need to use the free body diagram of the lever. For lever, this is the direction of force. This is the direction of tension, because if here it is coming out to be T2, here this will be the T2. Okay. So my dear, you know this is passing through here. So T1 will not create any moment. So you know this is F into A is equals to T2 into B. So if F is known to us, we can find out T2 from here. If T2 is known to us, we can find out T1 from here. If both are known to us, we can find out braking torque from here. And in general, the questions are asked in such a way, you need to find out the braking torque only. Okay. Please tell me guys, is it clear to everyone or not? Yes. So don't worry, we are at the completion of brakes. As I said, it is small chapter. In machine design, time is required lesser because machine design is the game of questions. Okay. And we are having practice sessions separately. Here we are solving only 1-to-1-2 question. In TOM, it was a lot to teach. So that is why their time required was more. Okay. You have seen we have completed entire SOM also one day. The point was in TOM, things are more of explanation type. In SOM and MD, we have formulas which are derived. So we can definitely remove or eliminate the derivation in the marathon session, because derivation is not required for GATE, but we cannot skip the explanation. That is why in TOM syllabus was not over. Otherwise SOM we have completed, MD we are going to complete. Okay, the point is only about the type of the nature of subject. Okay, so there only the things are related to explanation. So we have already seen this. Now we are talking about differential band brake. Very good, Malesh. So when we are talking about differential, here both the ends of bend are connecting at the drum. So if you see FBD of drum is rotating like this. This will be T1, this will be T2. Once again you will say braking torque is T1 minus T2. into R. Okay, T1 minus T2 into R. So if you will say this is force F, here you have already decided this is T2, here this is T1. So if you take summation moment about O to be 0, F into A, okay, this is clockwise, plus T1 into B2 minus T2 into B1. So you can write F is equals to T2 B1 minus T1 B2 divided by A. So once again you can see here minus term is coming because T1 is helping the force and T1 are creating same moment. So my dear, you can say if T2 B1 is more than T1 B2, this F is going to be more than 0. Condition is self-energizing. Okay, if T2B is equals to T1 B2, F is 0, this condition is self-locking. This condition is self-locking. This condition is self-locking. Okay, and if you are going to have T2B is more than T1A, sorry, T2B1 is more than T1B2. If that is the case, sorry, less than, then you will be having force to be negative. This is uncomfortable. So what you have seen in simple band break, we are not having that kind of condition. But in this differential band break, we are going to have once again the three conditions depending on the value of T1, T2 and B1, B2. Okay, yes, you are getting something in band break with a number of shoes. There is a formula like T1 by T2. Dear, but that is not required actually. Okay, because in your syllabus till now, even they have not asked differential band break. If you go, there are many things you can go like that, but that is not required for the gate point of view when we are talking about. We will see the break. Okay, I will give you the break, don't worry. So I will be giving you break. Will it be fine? First we will cover this topic at least. After the break we will start the bearing that we can do. Okay, so I will give you 10-15 minutes break at that time. Is it clear? Is it clear for everyone? Is it clear? Okay, first let me complete the breaks, then we will take a break of 15 minutes where I will take tea, you can take whatever you want. I will not take lunch because after lunch it is difficult to take class. Okay, so I will take care of that. So we have seen this, guys. Now let us solve some questions. We will see spring at the end. Let us solve some questions. Let us solve 2 to 3 questions. Okay, rest we have already completed. After 2 to 3 questions, I will leave you for this breaks. And after the break, we are going to see the bearings, joints. Okay, then after bearings, joints, gear, we will complete it around 4 p.m. to 5 p.m. Syllabus will be over. Okay, solve this question. Forces F1 and F2. Forces F1 and F2. F1 is acting in this direction. Okay, F2 will be acting in this direction. You can see that the coefficient of friction is 0.25. 3 pi by 2 is theta. So radius is 1 meter, F2 is 1 Newton. So you can say that F1 by F2 e to the power mu theta. One thing. Second is F1 minus F2 is the braking torque. Design of I will do that, but that is not coming in the paper. So in generally when I teach in classes, I cover all those things which are not coming to gate but coming to ESC also. But in marathon we are strictly concentrating on gate. So in GATE till now there is no question on design of shoe, but you have asked, I am about to take that. After 2 questions I am going to take that. Okay, it is not like when you are saying I was also having the plan to take that, but I was saying that first let us see the GATE type of questions. Okay, so you already know that theta is given to us, mu is given to us. So braking torque will be coming out to be 2.248. Dear, definitely it is important, Teju. So Teju, were you sleeping? You are today very late. Manas, very good. Ajay, very good. You are coming at the time when break is about to come. So after the breaks, we are going to take the break. So guys, here you need to find out the braking torque once again. So you know that this is the drum rotating like this. This is normal reaction. This is mu times of n. Okay. So braking torque is mu n r. And you need to take summation moment about O2 be 0. So this is 1000. This is normal reaction. And this will be mu n. Okay. And the practice session we have just planned. Okay. So practice session we have planned on Sunday for machine design. On that I would be taking some question from those topic also from where question have not been there. Like we are talking about the design of shoe, design of band, we are going to take that. So those concepts I will be telling you with the questions, okay, which you are thinking that are there in syllabus or not. So it would be a complete coverage with the questions, okay. Okay, Sharma ji, was you only. So every day you are coming with different name. Sometime pav bhaji, sometime. So you are doing that thing what generally Utkarsh was doing. Very good. Fine. Midun is saying 64 is the answer. So Midun have given the right answer. 64 is correct. So when you will be taking summation moment about O to be 0, what you will say? 1000 into 800 minus n into 480. Mu n will also be doing in the same. Mu n into 100 will give you the value of n. Mu is known to us. You will find out mu n r. Shreyas, not 54, it is 64. Not 54, it is 64. Okay, 64 is correct. Wonderful, guys. Okay, before we go into this question, I will tell you about the design of shoe. Design of shoe. Okay. So when we are talking about the design of shoe, my dear, you know that this was the lever. This was the shoe. So if you see the shoe, okay, it was shown like this. If I make the figure of shoe, it would be like this. Okay. So this is the figure of shoe. So you know that some normal reaction is acting on this. And you also know that some 2 theta angle, and this is the radius. So if B is the width of shoe, you can write normal reaction is N, and N divided by the area. What is area? This can be written as R into 2 theta. So R into 2 theta into B, that is the induced pressure on the friction lining. Then if we say the induced pressure less than or equals to permissible pressure, less than equals to P permissible. So N will be so this is the design of shoe, guys. You got it, guys? Everyone got it, the design of shoe? This is the design of shoe. I feel you got it. Wonderful, guys. So now let us solve this question. This is from GATE 2005. Wonderful question. You know why I say this question is wonderful? This is saying a band brake consists of a lever attached to one end and the other end. You can see here only one end is coming to the lever. So it is a simple band brake first of all. And they are saying that the braking force applied is 100 Newton. Coefficient of friction is 0.5. No other information is given. For such type of cases, when they say no other information is given, this was the first time when examiner have written no other information is given. Arey bhai, if I have given 4 things, why I am writing no other information is given? Because some information students are looking for, which intentionally is not given. Otherwise, if I am giving 4 things, I am not giving any other thing, it means other things are not given. But here why examiner is writing? Because whenever you solve the question on brake, you are always looking for the direction of rotation. Whether the direction of rotation is clock or anti, that is always you are looking into. Here that is not given intentionally. So he is saying no other information is given. So it is intentionally not given. It is not like we forget. We intentionally have not given. So you will be taking 2 cases, one with clockwise, other with anti-clockwise. And you will find out the maximum tension that can be generated. So you will answer it. The maximum tension will be coming in which of the case? That would be your answer. Very good. So after this question, we will take the break. Don't worry. Wonderful, guys. So Midun is saying the answer to be B. Anybody else? So according to Midun, B is the right answer. What about others? So when you will be taking this as clockwise, you know that if this is, I am assuming that let us say tension in this is T, tension in this is T dash. We can assume it like this. When you will be taking summation moment O to be 0, then this 100 into 2 is equals to T into 1. So T is coming out to be 200. Now my dear, you know that if one tension is 200, if I will be taking this T1, then T2 would be lesser than 200. And if I will be considering it T2, then T1 will be more than 200. I need to find out what maximum I can generate. So obviously what I got, I will be taking it to be T2 only. So I will assume T2 to be 200 Newton. Then you know T1 by T2 is equals to E to the power mu theta. So you will be getting T1 to be 2110 Newton. And you would be getting this value when the rotation is in this direction. Because when this is the rotation, then tension T1 will be coming like this. Then this is T2 actually. Sorry. So direction of rotation should be this. This is T2 and this is T1. So for clockwise, this will be the answer. For anti-clockwise, they have not given any option. So if they have given the options 12110, if one option will be 200, then I am saying 99% people would be answering this C. But the answer is 2110. I feel you got it. Everybody got it? Please tell me. This was about the brakes. Yes. Is it clear for everyone? So guys, actually, to be frank, I wanted to start bearings, but bearing is a big chapter. So that would be better if we take break before, because in between we shall not take the break. So the time is now 1:15. Okay. So after how many minutes we shall meet? Shall we meet? Class will resume at 1:30 p.m. Okay, so okay, let's increase it by 5 more minutes, not more than that. 20 minutes are enough for lunch. बनाना है कि करना है मधुवंशी? Okay, lunch break will take. Okay. So, okay, 1:35 I am saying. 2-3 minutes, it's fine if you are coming late, okay? So I feel 20 minutes are enough if we are taking the lunch, not making the lunch. So we are meeting at 1:35 again, and after that we will start bearings. Bearings, joints. I feel bearings will take 1 hour, joints will take 1 hour, then gears will take 25-30 minutes, then shaft 10-15 minutes, spring 10-15 minutes. So I feel by between 4 to 5 p.m. the subject will be over. So we are meeting after 20 minutes. There is a break. Yes, hello guys. So welcome back. So now we are going to continue further. We have completed some of the topics. We have completed loads topic. We have completed theory of failures. We have completed fatigue. We have also completed the breaks. So now, my dear, we are talking about the next topic, that is bearings. Okay. And whenever we are talking about the bearings, there is a very big table in front of you, which is having the complete classification. But my dear, if I tell you in the broad manner, we need to study here three chapters. First chapter is axial load bearing. Okay. And when we are talking about axial load bearing, this as a bearing is not the part of your syllabus, but this will give you the coverage of clutches. Okay. And then, my dear, we will be entering into the second thing, that is said to be sliding contact bearings. So when we are talking about the sliding contact bearing, actually this is also sliding contact bearing, but here we will see majorly journal bearings. And this is very important type of bearing as far as GATE is concerned. Hello Madhuvamshi. So just like and share the session so that other students also join fast. Then here we will be continuing with rolling contact bearings. In rolling contact bearing, we are going to see the ball bearings. Okay. So out of these two, one question will come. From clutch, I cannot assure you about the question because clutch, brake, spring, shaft. Out of these four topics, one question is coming. Good afternoon, Malesh. So in that way, I can say that this chapter which we are about to start now is very, very important. It will assure your 2 marks. Okay. So bearing chapter will assure your 2 marks for sure. Okay. So my dear, let us start. So guys, first of all, what is bearing actually? So when we say bearing, generally student feels I am talking about bearing of shaft only. Bearing is a generalized word. It is a complete field which is also given the name of, you can say, when we are talking about bearing, the total field name is tribology, where students are even going for masters and all. But bearing generally have a very simple meaning. Like anything which bears is a bearing. For example, let us say we are having a block which is there on the earth surface. You know, I will apply some force onto this block will start moving. So first of all, there are two bodies, one is moving body, other is stationary. So this is stationary body, this is moving body. Okay, one is stationary, other is moving, and this stationary body will be supporting the moving body like this. So when there are two bodies, yes Ajay, hi dear, if there are two bodies, one is stationary, other is moving, so definitely there is a relative motion, and stationary one is bearing the moving one. Then stationary one is said to be the bearing with respect to the other. Okay, or you can say if there are two bodies, one is at rest, other is moving, and the body at rest is supporting the body in motion, then the body at rest is said to be the bearings. So you get to know, first of all, body at rest is bearing and bearing is supporting the other member. So yes, but in our syllabus we are going to talk about bearing with respect to shaft. So if we have a shaft like this, because of the load acting on the shaft, shaft will have a tendency to go in downward direction. So here, my dear, how we will define the bearing? Bearing obviously is going to be a stationary part. Bearing is going to be a stationary element which is going to support the moving element shaft, and it is confining its motion, because shaft can have motion only inside the bearing. It is confining the motion and it is not allowing shaft to move in the direction of applied load. So this is how the definition of bearing is. Bearing is a fixed element which support another moving element shaft, confining its motion and do not allow it to move in the direction of application of force. This is how shaft की respect में bearing is defined. Okay, so guys, now we are moving further. So bearing is defined like that. It is classified into two categories: sliding contact bearing or rolling contact bearing. So whether a sliding surface will bear the load or a rolling element will bear the load. Whether a sliding surface will bear the load or a rolling element will bear the load, based on these two things, bearing is classified into sliding contact bearing or rolling contact bearing. Now sliding contact bearing is of two types: sleeve bearing and sleeper bearing. Sleeper or guide bearing is not in our syllabus. In our syllabus only sleeve bearing is there. So my dear, when we are talking about rolling contact bearing, that is a separate chapter where we will see ball bearing and roller bearing. Further they are of four types. But in our syllabus the questions are coming either with the name of deep groove ball bearing or with the name of the roller bearing. Okay, so we will see that separately. That is a separate chapter now. And now our concentration is on sleeve bearing. So now sleeve bearing, when we are talking about, we can classify them in three categories with respect to load, lubrication and configuration. With respect to load, they can be of radial load type or axial load type. In radial load type, they are full journal, partial journal, fitted journal bearing. For axial, they are pivot or collar. Then pivot or collar can be flat or conical. Collar can be multi-collar or single collar, like that. We will see all of them. Here on one slide I cannot make them, so here I am writing only the names. Then we are talking about, with respect to lubrication, it is thin film and thick film and zero film. Thick film is further hydrostatic and hydrodynamic. With respect to configuration is solid bush type and split bush type. If bearing is in a single piece, it is said to be solid bush type, like this. If bearing is in multi-piece like this, then we call it as split bush type. Okay. Then when we are talking about the lubrication, when you are providing no lubrication, it is zero film. When you are providing semi-solid lubricants like grease, it is said to be thin film. When you are providing liquid lubrication, it is said to be thick film. So in our syllabus, what we are going to study is thick film lubrication. Thin film is not, we are not going to study grease and all. And zero film we are using in food process industry. So in our machine design application, we are going to see only and only the thick film lubrication, in which hydrostatic and hydrodynamic type of lubrication will come into picture. Okay. So moving further guys. So we have seen that sliding contact and rolling contact. Sleeper or guide bearing is this one, which you have seen in theory of machines. This is the sleeper or guide bearing. This is cross head and this is the guide bearing. So that is not in our syllabus. In Scotch yoke mechanism, this is also sleeper or guide bearing. Okay. Is it clear guys? So don't worry, just be there till 4:30. We will cover it because they are very small topics. Here the things are not like explanations are not much. Okay. So when we are talking about the sleeve bearing, okay, this is the shaft we have. So if the load is acting in this direction, we will call it radial load bearing. If load is acting in this direction, we will call it as axial load bearing. Okay, radial load bearing, axial load bearing. So if we see the axial load bearing first. So first we are going to talk about the axial load bearing. And in this clutches will be covered for GATE syllabus. But at the end of machine design, I will tell you some other types of clutches which are generally not mentioned in the GATE syllabus and never been asked also. Like we have centrifugal clutch, like we have cone clutch. I will tell you at the end. But that is not coming in the paper. That is different thing. So my dear, when we are talking about axial, that is of two type, pivot and collar. Okay, pivot and collar. So when we are talking about pivot, pivot is of two type, conical pivot, flat pivot. Collar is also of two type, flat collar and conical collar. So when we are talking about the flat and conical pivot, it is also said to be the footstep bearing. So my dear, this is the case of flat pivot bearing. This is the case of flat pivot bearing. So this is the shaft. You are going to apply some force onto the shaft like this. So my dear, this is said to be the flat pivot. Here is the friction surface which is going to bear the load, and that is why it is coming under sliding contact bearing. Here also my dear, this is going to be the surface. This is conical pivot. Now we will see the collar bearing. Collar, what is collar? Like this is the shaft. On this I am going to weld a layer of material like this. Now this is acting like a collar. If you want to see the collar, this is the shaft. And we will be having this collar like this. This is the collar. And after that the shaft will continue. So as I said, collar is welded over the shaft. So collar is the part of shaft. So shaft and collar cannot be separated. It is one and all only. Okay. So my dear, for collar bearing, what is the case? Like we are going to have the second view of collar bearing like this. This is the shaft with collar. Shaft with collar. Now let us say some load is acting in this direction because we are studying about the axial load bearing. So when we are studying axial load bearing, load will be acting in this direction. Then my dear, bearing would be like this. Bearing would be like this. Bearing would be like this. Okay. So now when you will apply the force here, definitely collar will be coming in contact to this. Okay. So because of which the shaft will not be going ahead. So under axial load, this is how axial load is beared and shaft will not move in the axial direction. So what was the definition of bearing? It confines the motion and do not allow the motion in the direction of applied force. So this is how the collar bearing is working. Now if this collar is going to be aligned at some angle, then we call it as conical collar. If it is flat, we call it as flat collar. If we have one collar, single collar bearing. If we have more than one collar, it is multi-collar bearing. Okay. Please tell me, are you getting it or not? And just like and share the session. So we are talking about design of collar bearing first of all. When we are talking about design of collar bearing, here we are going to define two types of theories. One theory is said to be UPT, uniform pressure theory. Other theory is said to be uniform wear theory. In uniform pressure theory, pressure is going to be constant. In uniform wear theory, wear is going to be constant. And wear is coming out to be directly proportional to P into R. So in other words, we are saying the product of pressure and radius is going to be constant. So my dear, as the loading is axial, if I will show you the bearing like this, bearing will be like this because in this bearing only we are going to have a shaft like this. So in this bearing only we are going to have shaft like this. And obviously there is a collar onto the shaft like this. So guys, if you want to see the pressure distribution, so when we are saying uniform pressure theory, we are assuming the uniform pressure on the surface of bearing. Okay. Because only the collar will be coming in contact. So we are assuming uniform pressure in UPT. In UPT, we are assuming the uniform pressure. And in uniform wear theory, we are assuming P into R is constant. Means if radius will more, pressure will be less. So my dear, here pressure varies. Here if you will show the pressure distribution on the bearing, I am showing you. This is the bearing. I am showing you the pressure distribution. So pressure distribution will be coming like this. Radius increasing, pressure reducing. So pressure distribution is coming like this. Hyperbolic. It is coming out to be hyperbolic like this. So you may be asking, sir, this is real or this is real? So guys, in reality, when we see the pressure, neither they follow uniform pressure nor they follow uniform wear. So in reality, both of these are the assumptions only. Reality is different than them. Then you may be asking, sir, why we are not talking about reality? Reality is complex. Okay. So like we cannot find out actual stress concentration factor. So we were using theoretical stress concentration factor. So similarly, guys, here also when we are talking about UPT and UWT, you would be using that theory which will give you the safe design. So we will see which theory will give us the safe design. But the point here is UPT will assume pressure to be constant, UWT will assume wear to be constant. Okay. So in reality, what is constant, we will see that. Let's move further, guys. Let's move further. So now, my dear, I am taking, like, this is the shaft. This is the shaft. Okay. This is the bearing. When we are showing bearing, we are showing only this part. In other ways, this bearing is complete. Okay. So I will show you that. And now we also have the collar. So collars are also shown. I have shown you the real picture. Now this picture is only for understanding purpose. So if you are going to say that here axial load will be acting, if you want to make this view, then what you will see? You know that there would be a bearing. This is the bearing surface. This green one is the bearing one. This is bearing surface. Then we are going to have this shaft. And then we are going to have the collar. Like that. So my dear, if we say that collar will be transferring the force onto the bearing surface, then only this is the region in which the force is transmitted, because this is the region of contact of bearing and collar. So I am assuming that this radius is the inner radius Ri and this radius is the outer radius Ro. So these are the radiuses of contact. So I am assuming that there is a small element. Okay, I am showing it with different color. Let us say with red color. So I am taking at a radius of small r, a small element I am assuming. And this small element is having the thickness of dr. So if this small element at a radius of small r have the thickness of dr, then you can write the small area as 2 pi r dr. This is the small area. And if I want to find out the small load it can bear is pressure into delta A. If you want to write down the friction force, it can be written as mu times of delta W. Why? Because load is coming perpendicular to the surface. So rotation is going to happen. So you know mu into normal force is said to be the friction force. If you want to write down the frictional torque, it would be mu into delta W into R. Okay. So we get to know that is how we can write down. We can write down the values of forces, friction force and torque. Yes, Ajay, Malesh, Madhuvamshi, Midun, please tell me how many of you getting it. Are you getting it or not? Then you know this kind of derivations would be done for two conditions, pressure constant and P into R constant. So if you are ready, I can directly write down the results. If you are ready, we can directly go for the result, because the derivations are not required, even though they are there in the slides, but you know they are not required. In machine design, derivations are useless. We are not going to use them in the objective paper. So when you will be going for that, you would be getting the induced pressure to be W by pi R naught square minus Ri square. Okay, or you can also say that load is coming out to be P into pi R naught square minus Ri square. Okay, then my dear, if you are going for the safe design, then you would be getting W to be less than equals to P permissible into pi r naught square minus ri square. But these results are coming when pressure is constant, means when UPT is applied. You can also find out the frictional torque for this. So when you would be finding out the frictional torque for this, then frictional torque will be coming out to be, I have written the expression, I feel so. Okay, not written. So you'll be getting 2 by 3 mu W R naught cube minus Ri cube R naught square minus Ri square. This will be the result for frictional torque by uniform pressure theory. Everybody got it? This would be the result of UPT. You can directly remember the result. And what is W here? W is P into pi R naught square minus Ri square. So mainly you need to remember three values. One is friction torque, second is what is W, and third you can see the design. What is the design? Which we have written by the W maximum. When you will say P induced is P maximum. Although this is not required for gate, if you only remember the two formulas, then also it would be fine. Frictional torque and load value. This we have seen for uniform pressure theory. Now we can derive the same for uniform wear theory. So uniform wear theory says P into R is constant. So you would be getting this time P induced to be W by 2 pi R naught minus Ri. So here, my dear, if you want to write down the maximum pressure, you will say minimum radius. So W is 2 pi Ri, R naught minus Ri. When you will write the minimum pressure, it would be W by 2 pi R naught into R naught minus Ri. This is the value of maximum pressure and minimum pressure, my dear. So when we have this, you know that we would be saying the maximum value of pressure should be less than equals to the permissible value of pressure. So you can write W by 2 pi Ri, R naught minus Ri should be less than equals to P permissible. So we can write the value of W to be 2 pi Ri, R naught minus Ri into P permissible. That is the maximum value of load a bearing can bear based on the uniform wear theory. I feel everybody is getting it. So guys, let us move further. When you will be finding out the frictional torque for the same, it will be coming out to be 1 by 2 mu W R naught plus Ri. This would be the expression for friction torque using uniform wear theory. So guys, you can see both UPT and UWT have given the relations. These relations we have derived for a collar bearing. But if we want to use it for the pivot bearing, shall we go for another derivation? I will say no. We need not to go for the other derivation. Because in the pivot, this entire surface is the surface of contact. So you can just consider Ri to be 0 and R naught to be R, which is the diameter of shaft. Because here collar is not there, shaft itself is doing the work of collar. So if you will be using these values, you can directly put them into the expression. So when we are saying TF for UPT, it was 2 by 3 mu W. You know, it was R naught cube minus Ri cube R naught square. So you will be getting simply R naught cube by R naught square. Because Ri is 0, so you will get 2 by 3 mu W R. Similarly, if you are going to find out TF for UWT, you will be getting 1 by 2 mu W R. So when you will be taking the ratio of both, by UPT and UW, what you will be getting? You would be getting the ratio of TF UPT by TF UWT as 1.33. So from here we get to know the frictional torque of UPT is going to be more than the frictional torque of UWT. So uniform pressure theory will give you more losses than that of uniform wear theory. Some people are thinking that, sir, if UPT gives more loss, UWT gives less loss, we will consider less loss always because we wanted less loss. Dear, they are just theories. It is not like if in front of you lion is coming and you just keep your eyes closed and you will say there is no lion, there is no lion. It is not like that. So if you are using uniform pressure theory, it cannot result into lesser losses. Losses are actually happening what they are. These are just to theory to consider the losses. So my dear, whenever we are going for the safe design, I will give you an example. When you are coming after the examination, let us say there was a question for 20 marks. After coming from exam, you are trying to find out what kind of marks you can get. So you say that out of 20, I have attempted for 15. Then you are saying in the bad situation, bad to bad, worst situation, examiner will give me at least 7 marks. Why you are taking that worst condition when you are marking yourself? Because you want to get the worst condition is giving you passing marks or not. Because with the worst assumption, if you are getting the passing marks, nobody can make you fail. That is why you are always taking like that. Similarly, for the design, we are going to consider the worst conditions. So my dear, we have seen that losses of UPT are more than UPT. And when we see the actual losses, they are found to be more than what we have seen in UWT and found to be less than what we have seen in UPT. This we are talking about the bearings. So for bearings, actual losses are more than what UWT says, less than what UPT says. So my dear, for safe design, what we will consider? Anybody? For safe design of bearings, we will consider which theory, UPT or UWT? For safe design of bearing, we will consider which theory, UPT or UWT? Yes, my dear, we are going to consider UPT. So for bearings, if nothing is given, we will go for UPT. For bearings, if nothing is given, we will go for UPT. But my dear, these bearings are not in our syllabus. Why we are studying this theory? For clutches. So my dear, in the clutches, the things are slightly different. So when we are talking about the clutches, what is going to happen there? In the clutches, we are going to have a driver shaft. With that, there is one plate. Driven shaft, with that, there is another plate. And my dear, there is some friction surface. Okay? There is some friction surface. So when this is rotating with some speed, omega, this is coming from engine. Then my dear, power transmission will happen from driver to driven with the help of friction lining. So here, whatever friction is doing is not the loss, but friction is helping to transmit the power. So this time we are having the friction as useful thing. So whenever we are taking design, in design we are using the worst condition where losses are considered maximum, useful things are considered minimum. Like out of 20 marks, you were assuming you will get 7 and you were expecting 13 marks would be cut it out. So this is what we are assuming in the worst condition always. So my dear, this time if we say we are able to transmit the power in lesser friction, then we can definitely transfer it as higher friction. So here for the clutches, my dear, we will be going for UWT, but as I said, we will go for UPT for bearing. You will go for UWT for clutches. But that you will be doing if nothing is given. If nothing is given. If nothing is given. But my dear, if examiner gives something that there is a new clutch. So for a new clutch, for the very first instant, pressure is going to be uniform. If examiner says a uniform pressure of 1 MPa is maintained, once again you will be using UPT. So if examiner mentioned new clutch, if examiner mentions new clutch or examiner says uniform pressure, then you will be going for UPT. And if examiner says old clutch or he says worn out clutch, then you will be going for UWT. So that is how you need to decide which theory will be used. Otherwise, the same formulas you need to apply. And if you will go for the previous year's gate questions of clutches, only with this much clutches are over. But as Vineet have requested, I will go for centrifugal and cone clutches at the end. But for the timing, it is over. And in the question practice session, I will be taking the question from modified Goodman. I would be taking the question from design of shoe. I will be taking the question from design of band. So do not miss the practice session. There you will see a wonderful combination of everything. Okay. So this is how the things are going to be. This is the question. Let us see if any student find out the answer, so that we can say clutches are also over gate point of view. What is the question? A clutch has inner and outer diameters. Uniform pressure of 2 MPa, coefficient of friction is 0.4. Uniform pressure means you need to go by UPT. So TF is given as 2 by 3 mu times W, R0 cube minus Ri cube by R0 square minus Ri square. And you know that W is P into pi R0 square minus Ri square. Just do this, you will get the answer. Very good, Madhu Vamshi. Just solve this question, guys. Then we will enter into the second type of bearings. Okay. So we have covered one type of, I told you na, in this machine design part, explanation requires is lesser, formulas are more. So that is why I am keeping practice session of 2 hours. 35 questions we will solve there. Okay. But theory explanation is not much, because here lengthy formulas and questions are there. And it is a scoring subject for them who have gone through the procedures. Otherwise, people think it is a difficult one. Yes, solve it, guys. Solve it and give me the answer. We will try to finish the bearing by 3 PM, then 1 hour for joint, then 30 minutes for all other things. So my target is to cover machine design before 5 PM. Okay. So just be with me till that time. Your entire MD will be revised. So this session plus practice session will give you everything. So we will not be having another break. We will be having simple completion. Yes. Tell me that. Anybody? Madhu Vamshi, Midun, Ajay, Malesh. Vineet, are you there or not? Manas, if you are also there. Shrut. Solve it. This is only the matter of calculations. Only the matter of calculations. No, Madhu Vamshi, I feel you have made some mistake. These are diameters given. Ri will be 20. R0 will be 50. Have you put it the value correctly? Yes. If you will put that here, this term will get cancelled out. You will be getting TF to be 2 by 3 mu P pi R0 cube minus Ri cube. This is the simplified formula after putting the value of W. Very good. Ajay's answer is correct. So the answer for this will be coming out to be 196 Newton meter. Very good, guys. Very good, guys. Wonderful. So moving further, guys, now there are many questions. Now we will see the last thing, that is shear strength of the collar. Very good, Bhomik. बहुत ही बढ़िया. So now we are talking about the shear strength of the collar. So you know that when you have a shaft and a collar like this. So when collar was applying the force onto the bearing, that is for sure that bearing will also give the reaction to the collar. So bearing will have this kind of reaction. and then bearing will have a tendency to have a shear failure along this surface. This collar will have a tendency to fail from this shear surface. So you can write the shear stresses will be induced. What are they? You know that for this the radius is Ri, and we are saying that this thickness of the collar is T. So we can say force bate 2 pi Ri into T. This is the shear stresses induced. So you can say less than equals to tau permissible. So you will be getting W to be less than equals to 2 pi RIT into tau permissible. This will be the shear strength of the collar. This will be the shear strength of the collar. Okay, this is the shear strength of the collar. So this is the shear strength, and we already know for the pressure, for the friction lining, it was pi R naught square minus Ri square into P permissible. This is W max for friction lining. This is the shear strength of collar. Okay, we have already seen that, I feel so. Okay, now let us move further. Very good, Manas. Bahut hi badhiya. So my dear, now after this we will be entering into the journal bearings. So guys, journal bearings, when we are talking about, this is a special type of bearing, and generally they are used for very high speed applications like in power plant shaft, some cases of IC engine. So in high speed application we are going to use that. Very good, Madhu, Vamshi, Bhaumik and Manas, Ajay, bahut badhiya. So guys, Malesh, you also got the right answer. So for the high speed application we are going to use this, and they are radial load bearing, because here load is acting in the radial direction like this. So in this case we are having a shaft like that, and this is the bearing, you can see. And my dear, in this case, in between the gap of shaft and bearing we have the lubricant. Here we have the lubricant. Here we have the lubricant. So my dear, if I would be showing the another view of this, you would be having this to be bearing like this. And in this bearing, if my dear, we are going to have a shaft like this. So in between shaft and bearing, we would be having the lubricant. Is it clear? So this is going to be the lubricant. So my dear, there is some part of the shaft which is inside the bearing. So this part of the shaft which is inside the bearing, only that part of the shaft is said to be journal. So there is a misconception. People think that the entire shaft is said to be the journal. I will say only that part of the shaft which is inside the bearing is said to be the journal. So this is journal. That's why here they write journal, because this is the part which is inside the bearing. So guys, now let us move further. Okay. So if you see this journal bearing, okay, I am showing it in other way. This is bearing. If I am saying this to be the shaft, obviously load will be acting here like this, and in between we have the lubricant like this. Then my dear, you can see if this is having a radius of R, this is having a radius of R, then R minus R is said to be the radial clearance. D minus D is said to be the diametral clearance. Diametral clearance is 2 times of radial clearance. So we are going to play with this clearance part more. That's why I have defined this thing. Okay. Then my dear, we are going to move further. Now we are going to see the type of lubrication. I already told you here we are going to do the thick film lubrication. We are going to play with the thick film lubrication. Thick film lubrication is of 2 types. One is hydrodynamic, other is hydrostatic. So first we are going to understand the hydrostatic. For better understanding, I am making the diagrams of mine so that I can show you the things properly. This is the bearing. Bearing is the fixed surface, you know that. And initially when shaft is at rest, you would be having the shaft like this. Clearance is very, very less. Generally, you will find shaft and bearing are nearly touching each other. The gap is in microns. But if I will show you the gap of microns, means shaft would be going like this, then I would not be make you understand properly, because gap is very, very less in reality. So for better understanding, I will be showing you more clearance, but otherwise clearance is less. So I am saying this is the shaft or journal. Okay, so my dear, in between we have the lubricant. This lubricant is provided at 1 atmosphere pressure in case of hydrodynamic lubrication. And my dear, the load is acting like this. This is the condition when journal is at rest. So here journal is not moving. So what happened is, whatever the load is coming, bearing will be applying a reaction. And this reaction and W are having the same line of action. So this normal reaction N and W will be equal. Okay. So this is the condition of stationary case in hydrodynamic lubrication. So metal to metal contact is there. And my dear, whenever this kind of thing we are showing, if you see the pressure distribution onto the surface, which is in contact, because load would be coming at that only. So you will see the pressure distribution is coming like this. Pressure distribution is less here. It is becoming maximum at the bottom, and then once again it reduces. So you can see this is a variable pressure distribution. So we always are going to take the average effect. So for taking the average effect, we are going to say this induced pressure would be load but a projected area. And whenever we are going to have the projected area, like if we are having this shaft like this, okay, so this shaft like this, for that projection would be a rectangle. So rectangle would be, if this is the length of bearing and this is the diameter of bearing, so this is D and L. So it is going to be W by LD. So this type of area is said to be the projected area, and this type of pressure is said to be bearing pressure, and this is also said to be the bearing stresses. I derived these kind of things many times, but here we are just going with the explanation. So that is what is going on at the rest condition. I feel everybody is getting. Now we are moving to the second case. So my dear, now what will be going on? Now my dear, this was the bearing. You already know shaft is there. And this time what is going to happen? Shaft will be starting rotation. So this is the position of the shaft, let us say. Now shaft will start rotating clockwise. So when shaft will be rotating clockwise, you know that previously this was the W and this was the normal reaction. They were equating themselves. But my dear, because of rotation, because of relative motion, this time friction will come into picture. On to this journal, the friction will be coming in this direction. So if this is N, this is going to be mu N. No doubt this N was balanced with W, but mu N was not balanced. So because of this mu N, this shaft will move to the new position like this. Shaft will move to the new position like this. And you know W is always acting downward because it is weight. But you know that normal reaction always acts perpendicular, and friction is always perpendicular to the normal reaction, that is mu N. So resultant of there will be R. And obviously this resultant is equals to W, for that only the equilibrium of forces will be there. So that is how this would be moving in this way, because of mu N, in such a way that the resultant of mu N and N together will balance the W this time. But because of this, there is a gap between these two. So they are two equal and opposite forces separated by a distance. They will create a couple, and the couple created by them is opposite to the direction of rotation. So my dear, if this is your shaft which was rotating like this, now a frictional torque is created. And that is because of W is acting here and resultant force is acting here. So if the gap between them is X, okay, so if we are going to take this X as radius and plot a circle, then this circle is said to be the friction circle. In the question, they can ask you the radius of friction circle. Okay, so when you see this friction circle, this is the friction circle, and this friction circle actually is going to give us the value of frictional torque, which is W into X. Okay, which is W into X. So if you want to find out the X, you know this is the radius. You know this is the radius. And you know this would be the normal force N, and this is the friction force mu N. You also know that the angle between R and N is beta. So this angle is also said to be beta. So my dear, you can write that W is equals to W into X. What is X? This is X, this is R. Perpendicular hypotenuse. So you can write X to be R sine beta. But you know, my dear, sine beta, when beta is very, very small, you can write sine beta as beta. You can write tangent beta as beta. So you can write sine beta as tangent beta also. So because of that, you would be having the frictional torque to be W into R into tangent beta. Tangent beta is the coefficient of friction. So from here you can write frictional torque is mu WR. Here X is the radius of friction circle. So if you take this X as radius, plot a circle, that circle is said to be friction circle. And this X is the friction circle radius. This is when the motion is just about to start. This is happening at the slower speeds. Okay. So now you know here shaft will still keep on rotating. When shaft will keep on rotating, what will happen? Because you know you have seen something known as no slip condition. So the lubricant which is around this will start making a layer over the shaft. Because of no slip condition. And if you will keep on rotating, this layer will be thickening like that. And my dear, after some time, this layer, as it is stick to the shaft, this layer always try to go with the shaft. And if this will go to enter into this narrow space, but it is not able to do that because shaft is very heavy. But after some time, when a proper thickness is coming, this thickness is that much enough to bear the load of shaft. This would be pushing this shaft on the other side, and at higher speed, you will find now the shaft is leaving the contact with the metal, and this time it is going to be beared by the layer of lubricant, because when you are rotating shaft at higher speed, the lubricant inside is getting pressurized, and it reaches to the very high pressure in such a way that it can bear it. Now if you take a bucket of water and just rotate your hand there, when you will rotate with a higher speed, you will see water will lift your hand. The same thing is going on. Water, actually the lubricant is lifting this load, but my dear, only at the higher speed. So in hydrodynamic lubrication, metal to metal contact is avoided only at higher speed. So whenever shaft is starting, in the starting it is moving from 0 speed. After some time it reaches to maximum. Then entire day it remains at maximum speed. Then at the time when it is going to be stopped, once again it comes to the slower speed. So 99.99% time it remains there at higher speed. So my dear, here metal to metal contact is avoided because of dynamic action of shaft. Okay, that is why we are calling it as hydrodynamic bearing. So my dear, in this case, if we are going for further some terminology, you know that this is the center of shaft, this is the center of bearing. Then this distance is said to be eccentricity, and this is said to be the radius. And if you see the radius of bearing, this is said to be the radius of bearing. So radius of bearing can be written as radius of shaft plus eccentricity plus this small gap plus H naught. H naught is that layer which is bearing the load. So you can write this: capital R is small r plus eccentricity plus H naught. H naught is the layer who is bearing the load of shaft. I feel everybody got it now. This time metal to metal contact would be avoided. All the conclusions I have already told you. Yes, Malesh, Madhuvamshi, Manas, Bhomik, please tell me you got it or not. Friction circle we have already seen. All these things we have already seen. Now we are talking about the hydrostatic lubrication. So in hydrostatic lubrication, we are going to provide the fluid at external high pressure. So you are using the pump for that. When you are providing the high pressure, even at the fixed shaft, when shaft is even do not rotate, at that time also, yes, it is also said to be wedging action of lubricant or dynamic action of shaft. Okay. So this time, my dear, when you will be providing the lubricant at the very high pressure, okay, then you would always be having a thick layer of lubricant between shaft and bearing. You would always be having this thick layer of lubricant between the shaft and bearing. That is because of external pressure. So in hydrostatic lubrication, we are not even starting the shaft. Before that, only the metal to metal contact is avoided. So if we are working with higher loads at the stationary conditions, or if stationary condition is going to be for more time, we can go for hydrostatic lubrication. In general, we use the mixed lubrication. Like in starting, when shaft is at rest, we will use hydrostatic, so that metal to metal contact is avoided. But when it is rotating at higher speed, then we are moving towards hydrodynamic lubrication, because otherwise pump will be giving you more cost than that of hydrodynamic lubrication. Okay, so we have seen this, guys. So this is a table of differences between both. To save time, I have written all the things. You can see here pressure increases because of dynamic action of shaft. Here pressure is increases because of pump. Here you have metal to metal contact avoided at high speed. Here even avoided at rest condition. Then you are going to have next point. Here lubrication supplied at 1 atmosphere, here at very high pressure. Here you are having less cost, here you are having more cost of lubrication. Here motion of shaft is eccentric, here concentric. Okay, here starting torque is high, here starting torque is less. Then my dear, we have suitable for high speed, suitable for slow speed application. It is used where load is lighter, here load is heavier at the starting position. Application: IC engine, crankshaft, steam and gas turbine, electric motor. This is for heavy machine, bowl mills and all. So this is how we can see the difference between them. Okay, now we are going for terminologies. For terminology, we already have discussed the radius of journal, radius of bearing, diameter of bearing, radial clearance, diameter clearance. Okay, eccentricity, H naught, all these terms I have already told to you. Okay, we have already seen that. So what we have seen, capital R is small r plus E plus H naught. That is for hydrodynamic lubrication. For hydrostatic, this H naught will become C1, radial clearance. Okay, so you can say R minus R. Okay, but we are talking about hydrodynamics, so leave it. It is E plus H naught. So you know this is radial clearance, E plus H naught. So you can say E is equals to C1 minus H naught. So if I divide it with the radial clearance, E by C1, 1 minus H naught by C1. So guys, this is said to be eccentricity ratio. This is said to be eccentricity ratio. So eccentricity ratio is E by C1, which is 1 minus H naught by C1 or 1 minus 2 H naught by diameter clearance C. I feel everybody got it. Are yes or no? Yeah, just like and share the session, guys. I am teaching, I am just revising the complete machine design for you. I do not require that kind of revision. This is only for you. Now we are talking about the bearing characteristic number. Bearing characteristic number is defined as Zn by P. Okay, here Z is the viscosity of lubricant, N is the speed in RPS, P is the bearing pressure, where bearing pressure is given as load but a projected area. We already defined is L into D. Okay, sometimes they write diameter of shaft, diameter of bearing, because they are very close to each other. Then my dear, after this I would also like to tell you 1 to 2 more things. There is something called as Sommerfeld number. Zn by P into D by C ka whole square, or Zn by P R by C1 ka whole square. You know, for two identical bearings, Sommerfeld number is same. For two identical bearings, Sommerfeld number is same. So generally questions are coming for Sommerfeld number. Okay, generally questions are coming for Sommerfeld number. So okay, generally questions are coming for Sommerfeld number. Now we are talking about the power loss. So my dear, you are already having this hydrodynamic bearing. If this is hydrodynamic bearing and this is the shaft, if I am going to see this portion in the zoom view, you will say there is one plate which is fixed, other plate which is moving with a velocity of pi dn. Here d is the diameter of shaft, because you know when it is rotating like this, the speed of this would be pi dn. Okay, this is nothing but r omega. Pi dn is nothing but r omega. So my dear, you know this is the velocity profile it is going to follow. H naught is the gap between the plates. You have seen this type of thing in the fluid mechanics, where you say that shear stress is given as mu times du by dy. But here viscosity is denoted by z, velocity is pi dn, and then y is h naught. H naught is for hydrodynamic and C1 is for hydrostatic, because hydrostatic is concentric motion. This is the value of shear stresses. If we want to write down the expression for shear force can be written as shear stress into area. So it will become Z pi dn by H naught into pi dl. This would be the force. Torque is force into d by 2. Then it will become Z into pi dn by H naught into pi dl into d by 2. If even they are asking about the power loss, which is T into omega. So power loss will be Z pi dn divided by H naught pi dl d by 2, omega is 2 pi n. When I am writing small n, no need to divide by 60, because small n is revolution per second already. Okay? So n is already RPS. So we need not to divide it by 60. RPM needs to be divided by 60, because that is in revolution per minute. So Bhomik, is it clear for everyone? So this is what we have seen. Now my dear, there are three conditions. When length and diameter of the bearing are given equal, it is said to be square bearing. If length is smaller than the diameter, it is short bearing. If length is bigger than the diameter, it is said to be long bearing. So my dear, square bearing and short bearing, if we are using this, then it is considered to be a simply supported beam. Okay? And if we are going to consider the long bearing, it is considered to be fixed beam. Why? Because long bearing is keeping the shaft inside for more length. So that is why we are considering them to be fixed beam, because fixed beam are also embedded inside like this. Halaki these things are required for conventional note for the objective paper. I feel everybody got it. Now my dear, if we are going for the design of bearing, I am going for the procedure of this bearing. We are at the last point of sliding contact bearing. So as I said, by 3 p.m. or 3:05, 3:10, we will complete the rolling contact bearing also. Rolling contact bearing hardly have 4 formulas. Okay. So now we are moving fastly. Similarly, in joint, we have two types of eccentric loading majorly. So likewise, we are going to complete it fastly. So just be with me. Before 5 p.m., I will make you free from machine design. Now, my dear, we are seeing the design procedure for journal bearing. You know, journal bearing is coming for the shaft. So before that, design of shaft is done. So when we are talking about the design of shaft, okay, so from design of shaft, when we are talking about that, we have seen in the strength of material. If you remember, we have done comparison of shaft for two conditions. Okay. So my dear, when we have done that, now we would be getting the diameter of shaft using the shaft design. Then you know that this ratio, which is C by D, it is not C1 by D, it is C by D. This ratio is said to be diametral clearance ratio. So whenever we are going for design of bearing, we are knowing about this ratio. This ratio lying between this range. So before starting the design, we would be knowing this diameter clearance ratio, that we need to design somewhere in between this range. If you have this ratio C by D, diameter of shaft is known to you, you can find out diametral clearance. Once you get diameter clearance, D can be written as D plus C. You will be finding out the dia of bearing. When you are going to design bearing, there are three things which are required. One thing you require the diameter, second thing required is the length, third thing required is the lubrication. So these are the three things we require for the design of this bearing. So guys, we have already found out the diameter of bearing. Now let us see the second part. Please tell me guys, are you getting it or not? Yes, we are at the design of bearing. So then you will say that pressure induced less than equals to pressure permissible. You know, bearing pressure is defined as W by LD. That should be less than equals to P permissible. D is known to us, W is known to us, you will be getting the value of length. So you got two things out of three now. You got the diameter of bearing, you got the length of bearing. Guys, just like and share the session. We are still at the mid of this bearing, and then we will have joints, which is the most important topic, and then gears also. Moving further guys, just wait. Okay guys, if we will see that we found out the length, now we will be finding out power loss to get the information of the lubricant. So my dear, power loss is given as mu WV. Okay, why we are taking mu WV? Because design is always done for the worst condition. Worst condition is when metal to metal contact is there. So we have seen two kind of formulas for power loss. One is mu WV. Second we have seen that was Z pi dN by H naught pi dL into d naught by d by 2 into 2 pi n. So this was power loss due to viscosity. This is when mu is the coefficient of friction. So we would be using this formula because you already know that we are going for the worst case when metal to metal contact is there. So my dear, when we are talking about this mu coefficient of friction, for that two methods are used. One is theoretical calculation, which was taken care by Petrov. Petrov have given one equation to find out this. He said mu can be written as 2 pi square R by C1 ka square. This is same as Sommerfeld number. Zn by P will also come. Okay, so Zn by P, R by C1 ka square nahi aayega, just it was square in case of Sommerfeld number. Here it is not square. You would be getting this. Or square aayega? What do you say? Square aayega or nahi aayega? Will there be any question on bearing numbers? Yes dear, from bearing characteristic number till now there is no questions asked. Okay. Yes Madhuvamshi, it needs to be remembered. It needs to be remembered. Okay. Okay guys, so this is the formula for coefficient of friction for Petrov. Mackey's have done experimental analysis, and Mackey have said that coefficient of friction is a function of bearing characteristic number and D by C ratio and L by D ratio. So when he said that, he have also given more or less the same factor. He said 2.006 pi square into Zn by P, okay, then D by C plus K. Here K was the leakage factor. K was the leakage factor. And this value of leakage factor depends on L by D ratio. But in the question, they will give you what is the value of K. So you need not to remember that. So if the question comes, you will be using same value of Petrov, because 2.006 and 2, they are nearly same. So you can use any of the formula to find out. Okay. And if you find any difficulty, I have also shared you the notes. This is the Mackey's formula. Okay. Yes. Here D by C will come. R by C1 and D by C are same things, because we have multiplied 2 times. So you can see K will be 0.002 if L by D ratio lies in this range. It is 0.03 when L by D is more than 2.8. But this is from data book, will be given to you in the question. You need not to worry about that. Okay, let us move further guys. So this was the design procedure. Now you would be getting the power loss, because you know the value of coefficient of friction. Now you know, my dear, heat generation would be power loss. Power loss is mu Wv. So you get to know the power loss, which is the rate of heat generation. Now if heat is generated by some rate, then definitely it should be dissipated, otherwise it would be storing inside the lubricant, and lubrication, if it is getting stored, heat would be stored, temperature will increase. If temperature will increase, viscosity will reduce. So we want it to be maintained. So for that, my dear, whenever we are finding out heat generation, we need heat dissipation also. So heat dissipation will be going on majorly by convection. So we can also find out the heat dissipation. Heat dissipation will be HD as HATB minus T infinity. It is very difficult to find out TB all the times. So for convenience, we converted it into a temperature T0, which is that temperature, that maximum temperature up to which lubricant can maintain its viscosity. Lubricant can maintain its viscosity. So heat dissipation will be coming out to be HA TB minus T infinity. So TB minus T infinity can be written as 1 by 2 T0 minus T infinity. This is once again from the data book. Okay, from this part never question have come. Still I am teaching you because I want to give you some factor of safety. Here when we are going to say this, area will be pi dl. You know area will be pi dl. Why area will be pi dl? I am writing it heat dissipation ka rate H A TB minus T infinity. After putting H, area is pi dl, you can say it is T0 minus T infinity 1 by 2. So you know already, my dear, when we are writing this heat dissipation ka rate, this is 1 by 2 into H into pi you are having. So my dear, when we are going to say this H into pi, this together is said to be CD. CD is not coefficient of discharge, it is the coefficient of heat dissipation. So we define it as 1 by 2 into CD into projected area. Why we are doing this? Because in this chapter every time we are using projected area term. So now we get the same way T0 minus T infinity. Now in the paper T0 will be given to you, T infinity is the atmospheric temperature, projected area is D into L, CD is nothing but H into pi. So this will be having the same unit as that of H. So when you read out the question, you need to see whether you are given CD, which is coefficient of heat dissipation. Either CD is given or H is given. You need to see carefully because both have same units. Okay. So my dear, this is how the formula is derived for this case. I am going to share the short notes of machine design also in my Telegram channel, where you can definitely use them for revision purpose. This PDF will also be coming to you, don't worry. Okay, Tom PDF was not able to recover, but still I am making it for you. Maybe by Sunday I will share that also to you. Significance of bearing characteristic number. So when Mackey's have done the investigation, he plotted a curve. This curve is said to be the Mackey's investigation curve. So my dear, if I ask you if this is the investigation curve where coefficient of friction is on the y-axis and bearing characteristic number, which is Zn by P, on the x-axis. So if on the x-axis we have Zn by P, on the y-axis we have coefficient of friction, and someone asks you at which bearing characteristic number you want to operate, you will say, sir, that bearing characteristic number where coefficient of friction is minimum, I would love to operate there. And you are very innocent if you are saying that. Definitely every person must say that. But my dear, here story is something different. If you see this part is said to be the thin lubrication. This is said to be the semi-thick. Okay, and this is said to be the thick lubrication. So if you are looking for operating at this point, there is a small problem. Not small, a big problem. If you are operating at this, then my dear, if you are operating at mu minimum, no problem. You are operating at a Zn by P, which is said to be bearing modulus alpha. This is defined as bearing modulus alpha because here coefficient of friction is minimum. Let us say we are operating at this point, no problem. By mistake, my dear, by mistake, let us say slightly load have been increased. It can happen na, sometime load can increase or decrease. So by mistake or by some reason load get increased. If load get increased, you know that power is mu WB. Power loss will also increase. Power loss will increase. Rate of heat generation will also increase. Rate of heat generation will increase. Temperature will increase. Temperature will increase. Viscosity will decrease. Viscosity will decrease. Then bearing characteristic number will also get decreased. If this get decreased, you will shift to the left side. And when you will shift to the left side, automatically mu will increase. Here you have not done anything for mu, but automatically mu got increased. If mu got increased, this time once again it will give rise to the increase of power, and the cycle will repeat again and again. Once again, because of power loss, heat generation, temperature, Z, Zn by P. Once again you will shift to more left and you will reach to this position. I always say here, if you have seen the movie of Nana Patekar, where there is a famous dialogue of his, "Aa gaye meri maut ka tamasha dekhne." I don't remember that is in Tiranga or which movie. So if you see that movie, that is the dialogue said by Nana Patekar. So here bearing is at the same place of Nana Patekar. So because once you are operating at this, by mistake only once the load have changed, after that nothing is in your hand. Automatically bearing will move towards his death, because coefficient of friction keep on increasing, friction will increase and member is going to get failed. Nothing will be in your hand. You will just see how bearing is getting failed within some seconds or minutes. Okay, so that is why we will never operate here. This region is said to be unstable region. But if on the other way we are operating here, this is said to be stable region. There, my dear, if you are operating here, the same thing happen. This time if Zn by P will reduce, you will come to this, and this time friction will not increase but reduce. So that is why you will once again come to the original position. So here this is stable region, this is unstable. So operating range is starting from 3 alpha to 15 alpha. Means we are not operating here. We are starting our operation at 3 alpha. We don't want to take risk of this region. Even we are not operating in that nearby region, because we have that difficulty. If by mistake it comes here, bearing will be out of our hand. It will simply die. Is it clear, guys? So those who have not joined the Telegram channel till, do join it, where you will be getting the short notes of all the subjects as well. Okay. So moving further, guys, now. This is the bearing characteristic number. If, my dear, sometime you are going to have heat generation ka rate is more than heat dissipation ka rate. Sometime you need to go for coolant also. So along the bearing surface you need to provide the coolant. Then for that also you write m dot CPC delta T of coolant will be equals to heat generation ka rate minus heat dissipation ka rate. From here you can find out the mass flow rate of coolant. Till date there is no question on this, but still I am telling you to make you on the safer side. With this, sliding contact bearings are over. We are entering to the last type of bearing, where we need to study only 3 to 4 formulas, not more than that. So within next 15 minutes bearing will be over as per my promise. So by 3:05 or 3:10 bearings will be over. Then joint will go on for 40-50 minutes. Before 5 we will complete. Are you enjoying or not? Audio book of machine design. Yes. अरे आ रहा है मजा कि नहीं? We are going like anything at bullet train speed. That machine design 5 to 6 mark subject. Wonderful. Very good, Midhun. So on Saturday we will be once again joining for the rest part of tone and vibrations. We will complete on Saturday that too. Sunday we will have a machine design practice session, and then once again material science will be there on Tuesday, and maybe engineering mechanics also on the same day. Okay, be ready for that. Moving further, Now we are talking about the rolling contact bearings. Okay. In the rolling contact bearings, there are two things, ball bearing and roller bearings. You have just seen for the sliding contact bearing, the curve for friction is like this. And when we see for the roller bearing, it comes like this. For the ball bearing, it comes like this. This is for ball bearing. So if you see that coefficient of friction is low, coefficient of friction is low for ball bearing up to this speed, and then we are having roller bearing up to this speed, lesser coefficient of friction. After that, coefficient of friction is less for sliding contact bearing. So my dear, we get to know when we will be having the lower coefficient of friction. So friction, coefficient of friction will be lower at slower speeds for the ball bearing up to this speed. So up to this speed, we have least value for ball bearing. After that, we have least mu for roller bearing. Then we have least mu for sliding contact bearing. So we get to know in which range, which type of bearing to be used. We already have completed this. Now we will cover ball bearing and roller bearing. So as their coefficient of friction values are less, we also call them anti-friction bearing. We also call them anti-friction bearing. We also call them anti-friction bearing. We also call them, so name is a misnomer. Anti-friction doesn't mean friction is not there. Friction is there, but it is lesser. Okay. So this name is a misnomer. Okay. So my dear, this is how the deep groove ball bearing looks like. Okay. This is how a deep groove ball bearing looks like. Okay. If you want, I can make it for you. This is going to be the deep groove ball bearing. Like this. So here, my dear, what are the parts of this? This part is said to be the inner race. This part is said to be the inner race. This part is said to be the outer race. This part is said to be the outer race. And these are said to be the rollers or ball. Anything can be there. And these are said to be the cage or separator. So my dear, why these separators are there? To make the balls at their position. These balls are generally equidistant to each other. If separators are not there, all the balls will be collected at the bottom. All the balls are going to be collected at the bottom. Very good, very good, very good, Madhuvamshi. So my dear, cage or separator is not here to bear the load. Ajay, roller contact bearing and deep groove ball bearing. Yeah, no. Dear, deep groove ball bearing are ball bearing, and roller bearing means both are different. Actually, if you are using ball, it is ball bearing. If you are using roller, it is roller bearing. Okay, they are both coming in the same category. Formulas are also same, but in reality, they are different type of bearings. Okay. So my dear, when we are talking about these bearings, they are also said to be either ball bearing or roller bearing. But here we are talking about balls. So we are talking about deep groove ball bearings. So this diagram is for deep groove ball bearings because we are talking about ball bearings. So they are said to be deep groove ball bearings. Okay. So they are said to be deep groove ball bearings. I feel everybody got it. Everybody got it. Okay. So roller bearing is used if more loads to be bared. Roller can bear more amount of loads. So we use roller bearing when more loads are there. Okay guys. So let us move further. So my dear, now we will say that these rollers are always equidistant. Maybe in this figure you may not find it, but they are always equidistant because their position will decide how much load they can bear. If you will change even the position of one roller, my dear, their load carrying capacity will change. Okay, if any roller will change its position, its load carrying capacity will be affected largely. So if that is the case, my dear, we are going to have cage or separator to keep them at some fixed position. That is why cage and separators are used. Now my dear, I will be telling you one more thing, that when we are talking about the second view of this bearing, it is like this. It is like this. Second view is like this. Okay, so both the views can be used. As this is the kind of bearing, we are saying ball bearing, or we are saying a roller bearing, it can majorly bear the radial load, but it can bear some amount of axial load also. So majorly it is bearing the radial load, but some amount of axial load can also be beared by this. This type of bearings are made by SKF and Tata. SKF and Tata are the manufacturer of this. Then my dear, there is a terminology also for this bearing. As I said, these ball bearing are of various type. One is deep groove ball bearing. Okay, there is some thrust bearings, some angular contact bearings, some cylindrical roller bearing, needle roller bearing. So ball and roller bearings totally are of 8 types. But my dear, we need to study majorly on deep groove ball bearings. So every bearing is given a specific number. Like we are having names, they are having number. So deep groove ball bearings are given the number 6. 6 is the number of this bearing. So always the nomenclature is given like this. When I am saying 6104, what do you mean by that? 6 is the bearing number. Here 100 is the preferred series. 100 is the preferred series. Preferred series. And 04 into 5 will be the dimension. 04 will be the dimension. So when you see this type of nomenclature 6104, there are total 5 series. 100 is a series, 200 is a series, 300 is a series, 400 is a series, 500 is a series. When you are going from 100 to 500, my dear, its load carrying capacity is increasing, its cost is increasing, and its size is also increasing. So my dear, this 100 is said to be extra light. 100 is extra light. 200 is light. 300 is intermediate. 400 is heavy series. 500 is extra heavy series. If you want me to differentiate them, I have other figures. You can see for both of them, inner diameter is same only. Inner diameter is same only. For both of them, let us say this diameter is 20 mm. 20 mm. So what is different in them? Size is different. You can see this is small, this is bigger. So this may be 6104 and this may be 6404. Preferred series is different in both the cases. Very good, Madhuvamshi. So every time we do not go for into 5. This into 5 formula is applicable only from 6104. After that you can multiply. If we have 6100, size is 10 mm, 6101 12 mm, 6102 15 mm, 6103 17 mm. From 04 onward, you will just multiply the last 2 digits by 5. Okay. Indian standards have different nomenclature. In Indian standard, we show it as IS 40 BC 03. IS is for Indian standard. 40 is the size. BC is the deep groove ball bearings. And 03 is the preferred series. So here 03 means the series is 300. So this is how we can see the nomenclature. Questions are never asked from the nomenclature, so don't worry about that. Okay. Questions are coming from the terminologies which we are going to discuss now. Okay, one by one. So my dear, everything we have seen that. Now we are talking about bearing life. So you know, life is very, very important fact. Bearing life. Bearing life, generally people are saying that, sir, number of revolutions. Yes, or number of hours. We are defining the life in both the ways. Either number of revolution before failure or fracture, or number of hours before failure or fracture. But this is not as simple as you are looking for. Here we are going to define the rated life. Rated life means we will be taking 100 bearings and those bearings will be subjected to some load and they will be rotating at some RPM. And my dear, one by one the bearing will start failing. There would be a time at which we would be having 90 bearings safe. and 10 bearing got failed. So for that there would be some number of revolutions which are completed. There would be some number of hours which are completed. Then that number of revolution or number of hours is said to be the rated life, denoted by L90 or L10. This is the life for which 90% of the bearing will survive, or 10% of the bearing are going to get failed. So that life is said to be the rated life, L90 or L10. So my dear, when we are going for L90 or L10, we can also define this life L90, L10, L80, L20, L70, L30, L60, L40 and L50. So L90 means 90% bearing pass, L10 means 10% bearing fail. Similarly, 80 pass, 20 fail, 70 pass, 30 fail, 60 pass, 40 fail, 50 pass, 50 fail. We never have 40 pass, 60 fail, because we are assuming minimum reliability of 50%. When we are making friends, we may make anyone to be friend with a zero reliability. But in machine design, there is a minimum criteria to be a friend. We will be defining the bearing life only for the bearings which have a bearing life of rated life of more than 50%. Minimum 50% bearing shall survive that life. So there should be some relation between them. Yes, it is. So we can write L50 by L90. It can be written as ln 1 by 0.5, ln 1 by 0.9, 1 by 1.17. You can write down the relation L30 by L90. 30 means what? 70% pass. So passing marks would be considered. You will write ln 1 by 0.7, ln 1 by 0.9, 1 by 1.17. So always in denominator we have L90. In numerator you can find out any rated life of your choice. And my dear, I would also write one thing, that what is that? When you will see L50, it is said to be average life. And it is coming out to be 5 times the L90. This relation is permanent. When you will use this, you can find out L50 is 5 times L90. This is how we can go for the rated life, my dear. And if number of hours, if the life is given in number of hours, and we need to find out in the number of million revolutions, then also we can apply a formula. Number of hours into 60. Okay, this is coming in minutes. Now speed in RPM divided by 10 to the power 6 million revolution. So if you want to find out L90 in million revolution and you know the life of hours, you can apply this. Is it clear for everyone? Is it clear for everyone? Please tell me that. Is it clear for everyone? Please tell me that. Then my dear, okay, moving to some empty slide. Okay, there is no, somewhere we will see, don't worry. Okay, here I am telling you. Here I am telling you. Okay, so we are going to have sometimes FR is the radial load, FA is the axial load. So both type of loading this bearing can bear. So we are defining equivalent radial load because majorly we are designing it for radial loads. PE is defined as XV FR plus YFA. There is no question till now from this formula. Still I am giving you. So XV FR plus YFA into service factor. So here X is said to be the radial load factor. X is said to be the radial load factor. Are everybody got it or not? Y is said to be the axial load factor. FR is radial force, FA is axial force. What is V? V is race rotation factor. We are taking V to be 1 if inner race rotates. We are going to take V is 1.2 if outer race rotate, because out of these two only one race can rotate. One race has to be fixed because of definition of bearing. So sometime you need to find out the equivalent radial load also. Okay, is it clear? Is it clear for everyone? This is the formula for equivalent radial load. Sometime you can also have one thing like cumulative fatigue. You have seen multiple types of load. Sometime in the entire life period, speeds are changing. Let us say loads are changing. Here I am showing the load, here I am showing the time. So let us say for T1 time, I am writing the time here. For T1 time, the load acting was FR1, axial load was FA1, and speed was N1. Then for some other time T2, we have seen FR2 was the radial load, FA2 was the axial load. Then for some other time T3, FR3 was the radial load and FA3 was the axial load. So there are three parts of T1, T2 and T3. Total life is T, you know that. So my dear, for this case, if I ask you what is the number of revolution, you will say, sir, RPM into time. If I say number of revolution, you will say, sir, RPM into time. If I ask you number of revolution, you will say, sir, RPM into time. And if I want to find out the equivalent load, you know, for this time equivalent load 1 would be for FR1, XV FR1 plus Y FA1 into service factor. This is how you can find out equivalent load for first part. Yes, very good, Madhu Vamshi. Similarly, you can find out PE2. Similarly, you can find out PE3. Okay. So my dear, if you are going to have this type of situation, then which equivalent load I will consider? PE1, PE2 or PE3? For such cases, like Madhu Vamshi is saying, cubic mean load is defined. Cubic mean load says N1 PE1 cube, N2 PE2 cube, N3 PE3 cube divided by N1 plus N2 plus N3 to the power 1 by 3. This is the formula for cubic mean load. If you have that kind of variation, then cubic mean load is defined like that. S is the service factor. Service factor is defined because sometimes we have fluctuations. Value of service factor generally is given in the question. You need not to remember it. Very good, Manas. बहुत बढ़िया. So I feel you got this formula. Now we are moving to one last thing, that is load carrying capacity. Load carrying capacity. There are two types of load carrying capacity. One is said to be static, other is dynamic. Static and dynamic. Static load carrying capacity is defined for static conditions. Dynamic load carrying capacity is defined for dynamic conditions. Dynamic means when shaft is rotating. In our cases of calculations, we would be requiring dynamic only. So when we are talking about the static load carrying capacity, it is that maximum load. It is that maximum load. Which load? Maximum equivalent load. For which the deformation of heavily stressed point, the point where stress would be highest, deformation of heavily stressed point is equals to 0.0001 times of diameter of ball. So this is not useful, you can leave it also. I defined it because I need to teach you all these things. So it is not required for exam, may be required in interviews. So it is that value of load for which the deformation of heavily stressed point would be this much. Now what is dynamic load carrying capacity? Dynamic load carrying capacity is that value of equivalent load for which rated life is 1 million revolutions. 1 million revolution. This is that value of equivalent radial load for which the life is 1 million revolution. So guys, I feel you are getting it. So just like and share the session. We are about to complete the bearings. Then we will be entering into the last topics like joints and all. Okay. So I feel you are enjoying machine design. I know it is less weightage subject, but still we are covering every subject on the same pace, at the same level, and covering all the topics. We are not having any partiality that MD is coming lesser, we will not cover it. Material science is coming lesser, we will not. We are covering everything. Okay. So that is your choice, what you want to do, what you don't want to. So guys, now after that, we are having one last equation, that is load life relationship. And this is the thing from which every question have been asked in the paper. Whatever I taught you here doesn't matter, because questions are coming only from one thing. And that one thing is L90 is equals to C by PE to the power K. K or 1 by K? You tell me now. K or 1 by K? This K is 3, 4 ball bearing and 10 by 3 for roller bearing. Now question may be from ball bearing, maybe for roller bearing. You just need to remember the value of K. Generally they are asking from ball bearing, but if roller bearing comes, only K value will change. So this is said to be load life relationship. And like for two bearings which are identical, in case of journal bearing, their Sommerfeld number is same. Similarly, in case of ball bearings, their dynamic load carrying capacity is same. This dynamic load carrying capacity is also said to be catalog rating. This is also said to be catalog rating. Some questions they are saying catalog rating also. Let us do one question, guys. Very good, Manas, Midun, Madhumamshi. Let us do one question and we will enter into the next topic, joints. Okay, I want the answer of this question. Which one? Okay, let us see this one, because this is covering all the concepts. And do like and share session, guys. We are at the completion now. And after that, joints will come, which is also important topic. One question is coming every year. So we are left with 1 2-mark question more. Then we will see gears also. Gears is very small, 2 formulas are there only. Yes. So guys, the expected life of a ball bearing. The expected life of a ball bearing subjected to a load of 9800 Newton. So equivalent radial load is 9800 Newton. Working at 1000 RPM. Okay, for that the life is 3000 hours. 3000 hours. Then expected life for the same bearing. Same bearing means dynamic load carrying capacity same. At the load of 4900 Newton at 2000 RPM. You need to find out LH for that. Dynamic load carrying capacity is same. So L90 1 by K PE is equals to C. And if that is the case, you can write PE1 into L90 to the power 1 by 3, 1. PE2 L90 to the power 1 by 3, 2. You can apply this, but you need to convert it into million of revolution, because here we will put the value million in revolution. So you apply this formula and you will be getting the value of LH2. Try to solve it. Yes, guys. Try to solve it. Let me share this session also till now. Just solve this question. I want answer from your side. Yes. Yes. Anybody solved it? Malesh, Midun, Madhuvamshi. Very good, Midun. The answer will be 12,000 hours. Okay. So because speed is also different, so I feel you can put it very easily. No, 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 Ajay, I feel you have done some calculation mistakes. 12,000 hours. Load is getting reduced, na? So load is getting reduced. Because of that, the number of hours will increase. Shreyas, have you done some mistake? You can write it like this. 9800. What is life? 3000 hours into 60 into 1000. Divide by 10 to the power 6. 1 by 3. Is it ball bearing or roller bearing? Ball bearing. So K is 3 only. K is 3 only. You will write it as 4900. Number of hours is going to be, for that you need to find out. Into 60. Into 2000. Divide by 10 power 6. 1 by 3. So you will be having LS2 to be 12,000 hours. Very good, Manas, Malesh, Shreyas. Okay, okay. So dear, why different formula? Apply the formula which is there. Why you are going with different formula? Okay, guys. So now we are starting the next chapter. Next chapter is joints. Okay. So my dear, you can say this is the next big chapter, and we will be completing this also within 1 hour. Then rest 30 minutes we will use for all other topics. As I promised you, before 5 p.m. we will cover everything. Okay. Before 5 p.m. syllabus would be over. So we are going to start the joints now. Now you know that first of all we have talked about what is the difference between joint and coupling. What is the difference between joint and coupling? Can you tell me that? What is the difference between joint and coupling? Joint versus coupling. What is the difference between joint and coupling? Yes. Joint and coupling. Anybody? Ajay, Malesh, Manas. Ajay, Malesh, Manas. That's fine, Ajay. Very good. In joint, there is no relative motion. But what I want to say is, because of which joints are used for load transmission, couplings are used for power transmission. That is the difference. Okay. So my dear, when we are talking about riveted joint, first of all we must understand what it is actually. Okay. First of all, I would like to tell you, rivet is looking like this. Rivet is looking like this. This is the rivet. This is said to be rivet head. This is said to be rivet head. This is said to be shank. And this is said to be tail. So how riveted joints are going to be made? First of all, we take one plate. Then we take another plate. Then we are going to make the hole in these two plates. Then we are going to put that rivet inside. When we are going to put rivet inside like this, then you are going to apply some forces to close this rivet. So as you are closing the rivet like this, rivet is a permanent joint. And to avoid the leakages, we are going to provide either fullering operation or caulking operation. So either fullering or caulking are used to close the joint to avoid the leakages. Okay. So my dear, when we are talking about this riveted joint, what are the benefits, advantages of this? First advantage is different materials can be joined. Second advantage is no heating is happening, so no heat affected zone. Third is different thickness can be joined. What is disadvantage? You are producing hole in the plates, strength is getting reduced. So efficiency of riveted joints is always less than 70% generally. It comes like 65 to 70% in general. Then my dear, one more disadvantage is sometimes leakages also may happen in this type of case. This is about the riveted joints. Now my dear, when we are talking about a riveted joint, in riveted joint we are going to have generally two things. One is plate, other is rivet. One is plate, other is rivet. Then if plate will fail, joint will fail. Rivet will fail, joint will fail. So you need to save the failure of both of them. You need to save the failure of both of them. So my dear, I will tell you that when we are talking about plate, plate can be failed due to tearing. Tearing means tension only. Rivet can fail because of two reasons. One is shear, other is crushing. So these are the two types of failure happens in the rivets. But before we go into that, I will tell you some terminology of the riveted joints. Like if we are having a plate like this, this is one plate, this is another plate. If we want to join these two plates, I am showing you the top view this time. I am showing you the top view this time. So maybe in this top view, you will be able to see one row of rivet like this. 3 rivets are applied in this row. 3 rivets are applied in this row like this. So my dear, if I show you this region only, then I will show you one row of rivet is this. Other row of rivet is this. So my dear, the line joining the centers of rivet, this line is said to be the gauge line. Along a gauge line, this distance is said to be the pitch. The gap between two gauge lines is said to be the back pitch. And the gap between two diagonally opposite rivets is said to be the diagonal pitch. We can write the diagonal pitch to be equals to the square root of pitch ka square plus back pitch ka square. This is the case of chain riveting. If you are having rivet in front of rivet, that kind of riveting is said to be the chain riveting. That is said to be the chain riveting. And my dear, we are having one more type of riveting that is said to be the yes, zigzag riveting. We can have rivets like this. This is zigzag riveting. Once again, this is gauge line. Once again, this is gauge line. So this is diagonal pitch this time. This is back pitch this time. And this distance will be pitch by 2. Because overall this is the pitch. So for this case, we can define the diagonal pitch as square root of pitch ka square plus back pitch ka square. Pitch by 2 ka square plus back pitch ka square. Okay. When we are going to classify the riveted joints, it can be classified into the categories like lap joint or butt joint. So you know, when we are going to join like this, which type of joint it is? Which type of joint it is? Can you tell me, guys? Which type of joint it is? Which type of joint it is? Tell me that. Lap or butt? This is said to be very good, Manas, lap joint. And when we are talking about butt joint, in butt joint we cannot just put them together and like welding is done. It is not like that. If we are putting two plates like that, butt joint cannot be made like that. So if you want to make butt joint between the plates using the rivets, then you need to use some strap plates. So we use a strap plate like this. And in this strap plate, we are going to make the hole, and then we will be making the riveted joints like this. Sometimes we are using multiple strap plates also. Sometimes we are using multiple strap plates. Like these are two plates. strap plates 1, strap plate 2. So my dear, what happens when we are using two strap plates? Obviously the strength will increase. I will show you how it is going to increase. So this is said to be lap joint. This is said to be single strap butt joint. This is said to be double strap butt joint. I feel everybody is getting it. Very good Bhomik, बहुत ही बढ़िया. Very good Bhomik, बहुत ही बढ़िया. So guys, I am not showing that much classifications because only this much is required. So if we are going to talk about the simple case of failure, how it is happening, I am showing you that. Okay. Let us say we are having the plate failure. So how the plate failures are happening? If in this plate you are going to make the holes like this, you are applying the forces like this, then you can understand the stress, which is tensile stress, will be coming. If load is P, W is the width. Can I write P divided by W minus 3 times of hole diameter into thickness? Can I write this should be the tensile stress in the plate, maximum tensile stress in the plate. I am telling you, Midun, don't worry, I will tell you that. First let me complete plate, then I will tell you that we are going to discuss. So my dear, this is the stress induced in the plate. It should be less than equals to the permissible stress. It should be less than equals to the permissible stress. So we can write the load to be less than equals to W minus 3dH into T into sigma T permissible. This will come if we are having 3 holes. If we have 4 holes, then 4 dt will come. Okay, then 4 dH will come. So you can write the tensile strength of the rivet as equals to W minus n times of dH into T into sigma T permissible. This is the tensile strength of plate or tearing strength of plate. Tearing strength of plate. Is it clear for everyone? Now Midun, I am telling you what you are asking. Okay, for that I need to define the shear strength first of all. Okay, so now let us say we are talking about, like, you are having this plate 1, plate 2. This is the hole. You know that generally in this hole you are placing the rivet. So rivet diameter is different than the hole diameter. This is the hole diameter because we have made the hole in the plate dH. In this, rivet will go which have a diameter of dr. So my dear, now when you will apply the force, there will be a tendency of failure along this area, and this tendency of failure will be across this area. So this force is parallel to this surface, so this is said to be the shear failure. So when we are talking about the failure of shear, you will write the induced stresses in the rivet to be force bate pi by 4 d square. Here I have shown you only one rivet, but if I will show you the top view of this plate, and let us in the top view, as we have made the 3, so obviously there 3 rivets would be there. So now the same load P is beared by these 3 rivets. So if there are n number of rivets, I must multiply with the n to the area, because more number of rivets, more area will be resisting the load. Okay. So my dear, if that is the case, we can write tau induced should be less than equals to tau permissible. So it will give us the shear strength of the rivet as n is the number of rivets into pi by 4 dr ka square, rivet diameter into tau permissible, that is also of the rivet material, because this is the shear strength of the rivet. Please tell me, is it clear or not? This is the shear strength of the rivet. All these are valid if loading is passing through the centroid. Okay, we are not talking about the eccentric loading till now. Is it clear for everyone? Now my dear, what we have defined is, if we are going to have what, that butt joint. This is butt joint. And my dear, if I am going to make this strap plate, double strap plate. So my dear, if we have double strap plate, then we have this hole 1, this hole 2. And let us say we are going to have a rivet like this inside. So this time if you have rivet like this inside, then my dear, this time when you will be applying the forces, you will apply the force on the plates like this. Shear will happen at the two areas. Shear will happen at the two areas. So you can see in the same rivet, two area will resist the same. So because of that, generally when we see the shear strength of the rivet, which we have already defined, n into pi by 4 dr ka square into tau s permissible, that we have already defined, no doubt about that. You will be multiplying it with 2. In reality, it is 1.875, but we are approximating it to 2 because two areas are resisting. Practically, it is coming out to be slightly lesser than 2. Now you got it, Midun, please tell me that. Midun, you got it or not? Similarly, when we are going to find out the crushing strength, you know, like in the bearing pressure, you have defined load but a projected area. Similarly, in the crushing, we are going to define load but a projected area. How we are projecting like that? Because whenever we are going to have this reverted joint, you know that hole is of bigger diameter. We are having hole is of bigger diameter and rivet is of lesser diameter. So hole is of bigger diameter, rivet is of smaller diameter. So it is similar to the bearing and shaft case. So like when you will be applying the force like this part will be coming in contact. This part will be coming in contact when you will apply the force like that. So this is the thickness of plate T. So projected area you will be defining force is P. This is dr into T, because for the cylinder projected area is a rectangle. It is similar to the bearing pressure. Okay, if you remember, we have discussed all these things. Here I am going in this in such a way that which is exam oriented. Otherwise, if you remember, these derivation I have taught you for 2 to 3 hours. This is just a revision type of thing going on. So guys, now we get to know the crushing strength. Similarly, this is for one rivet. If we have n rivet, we need to multiply it with the n areas. So you would be having P crushing n dr into T into sigma crushing permissible. But I would like to say here there is no effect of double strap plate. This is coming because of double shear, but there is nothing called as double crushing. Double shear is possible, double crushing is not. Why? Because even if you will take this, when you will apply the formula, when crushing you will be talking about, then that kind of thing is not explained like that. Double shear we are going to define it. Is it clear for everyone? Bolo bhai. Is it clear for everyone? Yes, yes, yes. Please tell me that. So guys, now we are reaching to the eccentric loading case. Yes, yes. Guys, just share the session. If you guys will tire, then how I will continue. Okay. So I need all of you to join the session. Still we are left with a lot of things. Yes. Fine guys. Bhomik, Madhuvamshi, very good. So we are moving further guys. This is when the load is passing through the centroid of the rivet. Okay. Now we will be going for the eccentric loading, which will be the last part of riveted joint. Moving to the eccentric loading. So my dear, if we have this type of case, just look at it carefully. We are having this plate. This is the plate. This load is acting here, whereas rivets are here. This is the case when we are joining two plates. Like this is the one plate, this is another. You are joining these two plates like this. And when you are joining these two plates, here is one rivet, here is second rivet, here is third rivet, here is fourth rivet. And this is the applied loading. So my dear, here load is here, rivets are here. So I feel that you can feel one thing, that this is the line of action of load and this is the centroid of rivet. In the previous case, when we were having the loads, if these were the rivets, this was the centroid of the rivet, load was passing from the centroid of rivet. So when load is not passing through the centroid of rivet, we will call it as eccentric loading. And when load is passing through the centroid, we do not call it as eccentric loading. So this is the case of eccentric loading going on. And this is something on which every year a question is coming. And whether the question comes from riveted joint or bolted joint, you need to follow the same steps here. You need to follow the same steps. Nothing is going to change for that. So my dear, when you are going to have this eccentric type of loading, what is the procedure I am telling you? First of all, you will identify the centroid. First of all, you will identify the centroid of the rivets. This is the centroid of the rivet. Then you will find out the eccentricity of the load. That load is at how far, how much distance from the centroid of the rivets. Then after getting this distance, my dear, we need to see the equivalent effect at this centroid. You will apply one force here, other force here. This P and this P are two equal and opposite forces separated by a distance, and they will be creating a couple. So if you see the net effect, you would be having one force P and one couple like this. This couple is nothing but P into E. So my dear, you can see this force is parallel to the cross-section area of the rivets. It means this force is direct TSL as it is passing through centroid. This couple is having the plane parallel to the plane of cross-section of rivet. So this couple is said to be the twisting couple. Now in strength of material, we have studied direct TSL will be giving some average shear stress load butta area, and twisting couple will be giving similar to the torsion. We are going to repeat that. So we have two loads, one is DTSL, one second is twisting couple. Now we will see the effect of them one by one. So first of all, let us see the effect of P. Let us see the effect of P. So centroid calculation we have already done. Eccentricity we have already found out. Effect also we have already found out. Now we will see the effect of P. So you know that at the centroid, P load was acting. All loads are equidistant. All rivets are equidistant from the centroid. So they all will be bearing equal loads. So everywhere P by 4, P by 4, P by 4, P by 4 will be coming, and the forces are said to be primary forces. So FP1, FP2, FP3 and FP4. Primary because they are coming because of force. So the formula would be force bate the number of rivets. So this is the effect of direct TSL. Now we will see the effect of twisting couple, my dear. Now we will see the effect of twisting couple. What is that? So you know this force and this force is creating a couple like this. So my dear, you have studied whenever we were having a shaft and some twisting couple T was acting. Then for a cross section, how you were writing the shear stress distribution? Radius perpendicular, joining them like this. This was the stress distribution. Similarly here, we will say radius perpendicular. In the direction of couple, radius perpendicular. So if you remember, this entire couple is divided into these secondary forces. Let us say FS1, FS2, FS3, FS4. So this total couple is divided into 4 forces. So definitely their effect should be same. I can write P into E total couple can be FS1. These are secondary forces as they are coming because of couples. So FS1 R1, FS2 R2 plus FS3 R3 plus FS4 R4. You also know shear stresses are directly proportional to R. So shear force will also directly proportional to R. So if that is the case, shear force is directly proportional to R, we can write Fs as C times of R. So Fs1 will be C times of R1. So we can write P into E as C R1 का square, C R2 का square, C R3 का square, C R4 का square. C can be written as P into E divided by R1 square, R2 square, R3 square and R4 square. This will give you the value of C. Once you get C, you can find out Fs1, Fs2, Fs3, Fs4. You can see that they are also shear forces. Primary forces are also shear forces. If one is normal, other is shear, it is combined loading. But when both the forces are shear, they can directly add it up. So if you see the combined effect, 1, 2, 3, 4, this is centroid. You know, primary forces are like this. Secondary forces are like this. They are having some angles between them, theta 1, theta 2, theta 3, theta 4. You know how to find out the resultant forces. R can be found out, square root of primary का square, secondary का square plus 2 FPFS cos theta. Okay. So similarly, you can find out the resultant forces at all the 4 rivets, and out of these 4 forces, you are calculating R1, R2, R3, R4. Sum of them is going to be maximum. You would be considering the maximum force. Generally, those rivets would be having maximum force which are near to the applied loading. Like in our case, when you were having these 4 rivets, this and this, and force was acting somewhere here. So to this load, this and this rivet are closer. So 2 and 3 would be found to be the critically loaded rivet. You can directly find out R2 and R3. Once you get this resultant force, you can find out the induced stress maximum by considering the maximum resultant divided by pi by 4 dr ka square, that is less than equals to tau permissible. So my dear, R max is known to us, tau permissible given to us, you can find out the diameter of rivet. You may be thinking it is a very lengthy procedure, but in paper, if you have practice, you will be able to do this in 1 to 1.5 minutes. Because they every time do not ask dimension. They generally ask primary force, secondary force, resultant force. Generally dimensions have never been asked. Is it clear for everyone? And I have taken 4 rivet case. They can give you 2 rivets, 3 rivets, then things will become easier relatively. So I have told you the general procedure. If they would give you that, already we have seen that. If they would give you a case like this, then also you will be going in the similar way. This is the centroid. You will apply one force here, other force here. This and this will be making a couple like this. Once again, you would be having the 4 rivets. Primary, 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 primary. I am showing the direction of load, not the stresses. Secondary, 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 secondary. You can see this rivet is near to the load. So this is going to be critically loaded rivet. Here primary and secondary are directly added up. This would be the critically loaded. So you can directly play with this. No need to go for resultant of every rivet. This is how you can move on, guys. Just like and share, guys, we are having this. You can also have this kind of combination. So I am showing you this so that you can solve the questions. On Sunday, we will see every type of question. Be ready for that. This time, this is the centroid, you know that. One force here, other force here. This and this will be making a couple like this. So this time what you will be doing, there are 3 rivets. Here primary 1, primary 2, primary 3. As you know, this is the couple. So secondary here will come like this. Here will come like this. Fs2 will be 0. So here this and this, you will get more torque. Otherwise all seems to be critical, but for second rivet there is no effect of couple. So this is how you will solve in that case. All other things remain the same. Okay, now we are moving to the bolted joints. Everybody got it? Riveted is over. We are moving to the second joints. Don't worry. By 4:15 or 4:10, this chapter will be over. Is it clear, guys? Very good. Shreyas, Midun, Madhumamshi, Bhaumik, Malesh. बहुत बढ़िया. मजा आ रहा है? चलिए. So now we are moving to the bolted joints. My dear, actually bolt is having some different geometry, but whenever questions are coming from eccentric loading, we consider bolt also like a rivet. Vinod, yes, welcome to this session. So guys, when we are talking about the bolt looks like this. This part is said to be shank. This part is said to be threaded portion. This is said to be head. Shank is also unthreaded portion. This is temporary joint because you are using nut to close a bolt. So that is why it is said to be temporary joint. You can open the nut and open the connection also. So my dear, threads can be of two types, external and internal. Here the threads are internal. External threads are those which are made like this. Like this. These are external threads. And my dear, when we are talking about the threads, they are known by their external diameter. If we are making a thread like this, then this is the diameter of thread and this is the core diameter. Core diameter is having some relation with the external diameter. I am taking one special type of threads, V-shaped threads, for which the angle between these threads is 60 degree, which is said to be flank angle. For some particular type of threads, this core diameter is given as 0.84 times of D. But it is not always true. This is for some particular type. Okay. So that is why, as if we are not given the relation between D and D core, we cannot play for DC. Okay. We cannot find out D. That is why in gate question, when they do not give these kind of things, we are considering bolt as a rivet only and we find out the rivet diameter. But in reality, DC is having some relation with D. And as DC is the minimum diameter, in reality design should be done for DC. Because if DC is lesser, their chances of failure are more. Ashutosh, where external threads are used and where internal. Dear, actually, when you want to provide the bolt of uniform strength, for that case you can go for the external threads, because in external threads the entire bolt will be of uniform strength. Why? Because shank will also be having the same diameter as the core diameter of the threads. Okay, so that is how we are going to talk about. Okay, Madhuvamshi, I will share you the notes for that. Okay, don't worry about that. Fine. Okay. Even if possible, I will try to share the lecture of that also. Okay. So my dear, now we will see about the threads. The very first type of threads are V-shaped threads. They are generally used for fastening purpose. This flank angle for this is 60 degree. Then we are also having one more type of threads known as square threads, where angle between them is 0 degree. They are used in screw jack. They are used in screw jack. Then we have acme threads. Acme threads are making the angle of 29 degree and they are used in lead screw of the lathe. Lead screw of lathe. Lead screw of lathe. Is it clear for everyone? Lead screw of lathe. Then we are having buttress threads. This is buttress. they are like this. They are making an angle of 45 degree. And my dear, they are used for power presses. They are used for unidirectional power transfers. Okay, this is for only one type, as I said. So if eccentric loading is coming for bolted joint, you will consider it like a rivet. So I am talking about the second type of eccentric loading. First type we have seen in rivets. Second type we are looking in the bolt. But otherwise both are valid for both the things. Then after this we will enter into the welded joints. This time the things are going to be different. This time what is going to happen? This time, my dear, we are going to have like this. This time this plate is there, and that is, let us say this is the plate, or you can say this is the wall. And with this wall we are having this plate to be welded. So if you are going to take this plate out, this time this is the view. Previously we were having like this. Previously we were having 1 rivet, 2 rivet, 3 rivet, 4 rivet. Now we are having this type of connections. Okay, you can also consider it like this. If I show you this, I am having these plates are connected like this. This is said to be the type 2 loading. If load will be acting here, this will have a tendency to take it away. So this time different type of stresses are getting induced. That is why different analysis is required. Here you can see this is one row of rivet, this is another row of rivet. If you want to see that number of rivets, you need to come in this view, and then you can feel it how many rivets are there. And let us say if I see the cross section, I found the rivets like this. So there are 2 rows of rivet and every row have 2 rivets. Okay, this may be the case. So when the load will be acting like this time what we will do? This would be given to you separately. You will find out the centroid. First step is same. And that centroid you can make it here also. Here this would be the position of centroid. So you know load is acting here. What you will be doing, you will be finding out eccentricity of the load. This would be the eccentricity. Then my dear, you will apply 1 force downward, 1 force upward. This and this will be making a couple like this. Now my dear, you know that this cross section plane is like this. Couple is coming like this. So this couple is a kind of bending couple. So my dear, load will be shown like this P, but this time couple is coming like this. I cannot show in the air. So I am showing it like this. But this is a bending couple, not twisting couple. This is not like this, this is like this. Can you feel it? So that is why it can be better shown here. So because of this couple, the tendency of this body will be to go like this. Like this. The tendency of this will be to go like this. So couple will be making this. Obviously this force is a direct TSL. But this couple is like bending couple. Because the plane of couple is perpendicular to the plane of cross section. So what it is doing, this rivet will be getting extended like this. Like this. So this couple is creating tension in the bolt or rivet. This also will be extended like this. So this is creating tension. So my dear, which couple creates tension? Bending or twisting? Obviously bending. So this time we will say I am having one direct TSL which will create shear, and second bending couple which will create normal. Here both normal and shear, that's why theory of failure would be required, and that is why this type of case do not come in the GATE exam, because very lengthy question would be there. First you will find primary force, secondary force, then theory of failure. That is why. But I am telling you the procedure, don't worry. Okay. So we have seen the net effect. After getting the net effect, we will be moving to the primary forces. What are the primary force? Primary forces are same. Like we have this as rivet 1, rivet 2, rivet 3, rivet 4. This is the load P. So you will say P by 4, P by 4, P by 4 and P by 4. So similarly, all primary forces FP1, FP2, FP3, FP4 should be equals to P by N. Is it clear? Then you would be going for secondary forces. This time secondary forces are coming because of bending couple. So you know that as this will be bent like this. So obviously here, if any rivet would be there, it would not be getting deformed. So this axis is considered as neutral axis. So the distance of this rivet is L1. The distance of this rivet is L2. L2. So my dear, this time what will happen? This is going to be the deformation diagram. If anywhere rivet or bolt is there, they will deform like this. This is the deformation. Similar to the bending case. Hai na? So when we have this, you can say this time what is going to happen? You know there was a bending couple like this, which was P into E. This would be providing the tensile forces in all the four rivets. And tensile forces will be outwards. So from here outward force, here also outward force, here also outward force, here also outward force. So this is the secondary force 1, secondary force 2, secondary force 3 and secondary force 4. So we can write this time P into E, secondary force 1, Y1, secondary force 2, Y2. These Y are the distances from the neutral axis. Fs3, Y3, Fs4, Y4. Then my dear, you also know if tensile stress is directly proportional to Y, force is also directly proportional to Y. So we can also write force to be C times of Y. So F1 will be CY1. So secondary forces can also be made like this. C1Y1 square, CY2 square, CY3 square, similar to the previous case, can be written as P into E. Then my dear, you would be getting the value of C, P into E, summation Yi square. I is 1, 2 number of rivets. After getting this, you can find out secondary forces. Okay. This time all the forces are not shear. Primary are shear, secondary are normal. So my dear, this time it is a case of combined loading. If you see the bolt or rivet, what you will feel? What you will feel? You will feel that primary effect is shear. Secondary effect is normal. So you will try to find out shear stress as primary force by pi by 4 d square. Normal stress, secondary force divided by pi by 4 d square. So you would be having a loading like this, normal and shear. This is a combined loading. So from this you will find out the principal stress sigma 1, sigma 2 and tau max. Or you will find out only sigma 1 and sigma 2. After that, you know how to apply the theory of failures. Once you will get sigma 1 and sigma 2, you just need to write what? Sigma 1 comma sigma 2 less than equals to SYT. This is the case if we are having brittle materials. For brittle materials, we will apply MPST. For ductile materials, we will apply MSST. But you know that for both the material, if principal stresses are of same nature, then my dear, you would be applying this for both. But for ductile material, if sigma 1 and sigma 2 are of opposite nature, then you would be having sigma 1 minus sigma 2 less than equals to SYT by N. So the point is you would be going for either MPST or MSST. But that kind of question will not be coming in objective. You can leave it if you want, okay? This would not be coming in objective. This type of things are coming in conventional only. But they can ask you primary or secondary forces. Up to that they can ask. Final they will never ask. Because it will, if they ask, do it at the end. Because this is not a 2-mark problem then. It will waste your time a lot. Okay? So we have already seen that this is the third type of loading. This have also never come in the paper. But you just need to see what would be this effects. If you see this force, This time you will find out the centroid. You will apply one force here, other force here, and this will be giving you a bending couple once again. So this time primary force will also be of tensile because this is perpendicular to the cross section. So this time if you will make the 4 rivets, this time primary forces are also of normal nature and secondary forces are also of normal nature. So they will be directly added up. It is similar to the first case. So you will find out resultant of 1 is FP1 plus FS1. Resultant of 2 is FP2 plus FS2. So you can find out R maximum by pi by 4 d square. This would be the normal stress less than equals to permissible stress. Please tell me you understood or not. I have gone through this fastly because one thing is it never been asked. Second thing, it is very easy. Because here also the tendency of this force is to create bending only. So this time primary is also normal, secondary is also normal. Previous to that primary was shear. Very good Midun. बहुत ही बढ़िया. So guys, we are at the completion now. We have done the bolted joints also. Okay, you can see this, the same thing we have done it. These are the PYQs. I feel you can try by your own. Now if you have this type of thing, this is directly twisting couple given. So here you would be having only secondary forces. Here primary forces will be 0. So this is case number 1, type number 1. Okay, with only twisting couple. Here only secondary will come, primary will not come. Moving to the welded joint, guys. The last type of joint. Manas, we are going to have. That's why actually in machine design, if I will start solving numerical, then it will once again become lengthy. So this time I am doing all the cases in front of you. So you will come up with revision. That's why we are having more than 30 questions. Why we have kept. There would be no repetition. If one question is from Soderbergh, second will not be from Soderbergh. If one question is from Miner's rule, second will not be from Miner's rule. Every topic will be having only one question. Midun, Fs is equals to C times R. Because all the time they are equidistant, because they have already mentioned it in a circumference. They have mentioned all the bolts in the circumference like this. So obviously this R will be same. I have answered you, Midun. I feel you got it. Manas, you also understood this. Let's move further. Okay. My dear, we are knowing well about welded joints. So you know that in welding, efficiency is more, but heat affected zone is a problem. So when we are talking about this, we are generally going to talk about two types of joints. One is lap, other is butt joint. So when we are talking about the welded joint, I will tell you there is one joint as lap, other as butt. Here also direct formulas are there. Butt joints are like this. Like this. Lap joints are of three types: parallel, transverse, combined. Parallel means if we have one plate like this, other plate like this. If welding is like this, this is parallel fillet. It can also be said to be fillet weld. Parallel fillet. If you have this, another plate, this is transverse fillet. When weld is parallel to load is parallel fillet. When it is perpendicular, it is transverse fillet. And if we have both kind of things, like this is parallel also, transverse also. then we will call it as combined fillet. Okay, you need to remember two very important points. So maximum thickness of weld joint in parallel and transverse in which angle, sir? Dear, maximum nahi, minimum you want to ask. Okay, so it is not about minimum thickness, it is about maximum stress. So when we are talking about the parallel fillet, first of all, fillet welds are weak in shear. And second point, butt joints are weak in tension. So parallel fillet, transverse fillet, combined fillet, when we have, we will be taking their failure at shear. So my dear, for parallel fillet, actually shear stress is coming maximum where thickness is minimum. So when you will see this minimum thickness, that is coming at an angle of 45 degree. So there only stress comes maximum. Okay. So that is why whenever you are going to find out the force for parallel fillet, whenever you are going to find out the force for parallel fillet, the strength or force, okay, let me write strength of parallel fillet, that is coming out to be 0.707 T. L is the length of weld, tau permissible, because they are getting fail in shear and they are getting fail at a plane of 45 degree. Similarly, when we are going for transverse fillet, it comes out to be 0.828 TL tau permissible. It happens at 67.5 degree. But my dear, I would also like to add one more point here. Maybe this is fine, but we will consider this 0.707 only. Because if this is 0.828, no doubt the strength of transverse fillet is better than the parallel fillet. But we need not to check whether the fillet is parallel or transverse. If we are taking 0.707, it can be used for both. Because even if it is transverse, our design is going to be on the safer side. So you can always take for fillet weld 0.707 TL into tau permissible. Always remember this L is the length of weld. This L is the length of total weld. I feel you got it. This is for the lap joint or fillet weld. Now we will see about the butt joint. So when we are talking about the butt joint, okay, this is the case of lap joint only. This is the question which came. Here they have mentioned the total weld length to be 30 mm. So you just need to apply the formula 0.707 TL tau permissible. I feel everybody can find out the answer. Solve it. Solve it, solve it, solve it. Solve it, guys. For other topics, we need to see only the formulas. You know that. I feel spring was covered in soam. Spring was covered in soam. When we have taken soam, spring was covered there. Yes or no? Shreyas, Midun, Madhuvamshi is saying C will be the answer. That is correct. Guys, do you remember in the strength of material marathon, spring was covered? Yes or no? Very good. This is correct. So my dear, now if we have butt weld, like that, this is the root gap, and you know this is the thickness. This is the width of the plate or width of the weld, let us say. So this time in butt joint you will apply this force. Here failure will happen because of tensile tension. So you will write sigma induced is P divided by W into T. So P would be coming out to be less than equals to W into T sigma permissible. And if some undercut is given, what is undercut? If I am saying that weld is like this, between these two plates, weld is like this, and we have an undercut up to U length. Undercut means molten metal is not filled in this region. Then the formula will become W into T minus U, sigma permissible. Here sigma will be coming. This is the strength of butt joint. Great. If we have two plates of different thicknesses, one is having a thickness of T1, other is having T2, then you would be taking butt joint strength as W into T minimum into sigma permissible. Only this much is required from the joints, guys. How and why undercut is dear, it is not provided, it is a defect. Okay, Ashutosh, it is not provided, it is a defect. Okay, so in the welding chapter, in the production, this comes as a welding defect. This is when process parameters are not proper. Is it clear, Ashutosh? Please tell me that. So guys, this is about the welded joint. Okay, so now my dear, in the gears case, what we need to study for the gears? You know that in gears, all this interference and all are covered in theory of machines. What we are going to cover in machine design? Yes, Ashutosh, got it or not? Please tell me that. So we have seen the joints. Now we are entering into the gears. We are entering into the gears. So in gears, we have seen that one part in the tome. Not seen, we are going to see on Saturday. What would be that part? There we are going to see the terminology of gear, gear train, interference, all these things we are going to see. Law of gearing and all. Minimum number of teeth. Yes, all those things we will see there. So my dear, here we are going to see only two things. One thing is, we are going to have one thing is, that is, can you tell me? Force analysis. Force analysis and Lewis equation. So out of these two you will get some question. Here only this thing is there in syllabus. Okay. So overall gears would be covered plus in tome plus vibration both. Sorry, in tome plus MD both. Madhuvamshi, wear strength is again not required for gate. That I taught you for ESC. Okay, wear strength they are not asking in gate because that is a formula from data book. But still, if you want to remember, you can. Okay. So let us talk about the force analysis now. We are having this as a gear. This is the shaft. So on the safe side, you can go for wear strength also, but in general, it is not there. This is the net force coming, you know that. This net force is having one component as tangential, other is having radial. And this is making an angle of phi. So you can write Ft to be equals to F net cos phi and Fr is F net sin phi. But the problem is F net is not known to us. We are given the power which is torque into omega. So we know about the torque which is tangential force into radius. So we know tangential force can be written as T by R. T is the torque, R is the radius. That is known to us. So my dear, torque and radius known to us. Radius can be written as what? You know, module is diameter by number of teeth. So diameter can be written as module times number of teeth. Radius can be written as module times number of teeth by 2. So you can also write Ft to be torque by mz by 2. 2t by mz. 2t by mz is the Ft. 2t by mz is the Ft. Then F net can be written as ft by cos phi, and f radial can be written as f net sin phi or ft tan phi. So my dear, this is the force analysis. Either they will ask you the ft value or fr value or f net value. These are the questions which are coming from this topic. I feel everybody got it. Please tell me that this is the force analysis we are having. Okay, this is the force analysis we are having. Then my dear, sometimes they are asking the question from center distance. Like if this is one gear, this is another gear. This is one center, this is another. Then this center distance, which is denoted by x, can be written as r plus r. X is r plus r. You know, r can be written as module times number of teeth by 2. Module times number of teeth by 2. They will have same module because they are mating gears. This question is also very famous. Okay. Very good, very good. Asutosh, वैसे तो this we are going to cover in TOM, but you are asking, then I am telling you. Actually, whenever we are talking about a gear, we are going to have a pitch circle. Okay. So when this is a pitch circle, when two gears are mating, their pitch circles are always in contact. So this is pitch circle 1, pitch circle 2. And my dear, wherever these pitch circles are coming in contact, that point is pitch point. That point is pitch point. And if you are going to make a tangent at the pitch point, that is defined as the common tangent. That is defined as the common tangent to both pitch circles. Common tangent to both the pitch circles. And if it is the common tangent to both the pitch circles, there is no problem. Now my dear, wherever one gear is touching the other gear like this. This is one gear, this is other gear. So if one gear is going to transfer power or transfer force to the other gear, it would be transferring along the point of contact Q like this. This is said to be the line of action on which the force is getting transferred. This is perpendicular to the gear profile. So this is said to be common normal. Common tangent to the pitch circle, and this is common normal to the gear profile. Both are different things. Many people feels that the angle between common tangent and common normal will be 90 degree. But it is not like that, because that common tangent is tangent to pitch circle and common normal is normal to the gear profile. And my dear, this is the line of action along which the force is getting transferred. If I am just going to coincide both of them, then angle between this common normal and common tangent is the pressure angle. Got it, Asutosh? Asutosh, you got it? For you, I went into in-depth definition of the pressure angle. Am I pass in that? Yes. Great. Moving further. So now we are going to see about Lewis equation. Lewis equation. Wonderful, guys. So when we are talking about the Lewis equation, I feel you all know it is S into CV times F actual is less than equals to MBY sigma B permissible, where this F actual is FT T by R. S is said to be the service factor. CV is said to be the velocity factor. You need not to remember these values, CV and S. It would always be given. Always remember one thing, the product of them should be more than 1 always. If they give this factor less than 1, it means they have given the value of inverse of it. You just need to do one thing. Just put it here, the product. This is torque button radius. Torque button radius is nothing but mt. Sorry, it is 2t by mz. We have just derived it now. Radius is mz by 2. So if you know the torque, you can apply this. When the question is coming from Lewis equation, generally they are asking you sigma be permissible and they give you all other things. This y is said to be Lewis form factor or tooth geometry factor And my dear, this B is the width of top length. M is the module. Module is diameter by number of teeth. Here Z is the number of teeth, T is the torque. Is it clear for everyone? Please tell me that. Bolo bhai. So I was thinking of springs, but I get to know that spring is already covered in SOM. Okay. Spring is already covered in SOM. Then we are talking about the shaft. For shaft also, we have covered in SOM. Only one thing is not covered. That is the design part. We have covered the comparison, but we have not covered the design. So that design we are going to see right now. Okay, when we are going for the design of shaft, you must be aware of that shaft can be of two types. One is axle, other is transmission shaft. Axle is something which would be subjected to only load as not rotating. So it would be under uniaxial loading because it would be under bending stresses only. But transmission shaft will be subjected to load, because of which bending will come, and because of rotation, twisting will come. So generally transmission shafts are under combined loading. And when something is under combined loading, we need to go for theory of failure. So if you are talking about a brittle shaft, you will go for MPST. If you are going for a ductile shaft, you will go for MSST. I feel everybody aware of this. Everybody aware of this. So what you would be doing, like if you have, you can calculate sigma 1 and sigma 2 from the given loading. Then you can write for MPST sigma 1 or sigma 2 is less than equals to SYT. Okay. So my dear, when you would be calculating sigma 1 and sigma 2, you can also go into that. Sigma XX is sigma bending. It is 32 m by pi d cube. When you will find out tau xy, it is tau s 16t by pi d cube. Why? Because a transmission shaft is subjected to bending moment and twisting moment both. So bending moment will cause bending stress, twisting moment will cause shear stress. Is it clear? So because of that, when you will find out sigma 1, 2 as sigma yy is 0, you know the formula is sigma xx plus sigma yy by 2 plus minus square root of sigma xx minus sigma yy by 2 का square plus tau xy का square. You know that we would be getting from this sigma 1, 2 as, you would be getting 32 me by pi d cube, where me is 1 by 2 m plus m square plus t square. This is said to be equivalent bending torque, equivalent bending moment. So when you would be saying this sigma 1 comma 2 less than equals to sigma permissible, you will be getting the maximum value of bending moment permissible as pi d cube by 32 into sigma permissible. Similarly, you can find out for ductile. For ductile, you will go for MSST. You will say tau max is equals to what? It is square root of xx minus yy by 2 ka square plus tau xy ka square. It would be coming out to be 16 TE by pi d cube. TE is equivalent twisting moment and TE is given as square root of m square plus t square. Everybody got it? Wonderful, guys. So you also would be knowing one thing, that if KB is, KT is, they are the impact factors, impact or fatigue factors for bending and torsion, then equivalent twisting would be defined as KB times m ka square plus KT times t ka square. With this, the shaft is also over. Is it clear for everyone, guys? I feel we have covered everything now. Now on Sunday, we will meet for a 2 hours practice session where all types of questions, old, new, will be covered. Okay, Madhuvamshi, for that, if you're talking about, if we are going to have cone clutch, the formula will remain the same. TF for UPT is, that is 2 by 3 mu. This is generally the normal force, Wn, that is R0 cube minus Ri cube, R0 square minus Ri square. But generally, when we are having the cone clutch like this, they are making the angle. This angle is cone angle 2 alpha. So they are going to provide you the axial load, but we need the normal load onto the friction surface. So that can be sorted by putting applied load divided by sine alpha. This is for cone clutch. Okay, so we will see that also in the question, but these things have never been asked in GATE. You are saying, so I am telling you the formulas. Then multiplate. You will just write TF for multiplate N into 2 by 3 mu W R0 cube minus Ri cube. Okay, I am writing for UPT. Can you repeat it for UWT? Can you repeat it for UWT? Just you need to change the value of this 2 by 3 as 1 by 2 and this as R0 plus Ri. That can you do, guys? Midun, Madhuvamshi, Malesh, Ajay. We are about to complete now. Yes. So now we are talking about centrifugal. You know, there is a drum on which some friction surfaces are present. We are having a shoe on which also friction surface is there. There is a spring. There is a shaft. So when this shaft will be rotating, there would be a centrifugal force. है ना? And because of that the shoe will go away and some spring force will be coming inside. There will be an instant omega 1 is the speed in which this shoe and this will come in contact. So I will say when contact begins. Actually we are operating at omega 2 operating speed. So my dear, what is the net force acting on the drum? What is the net force acting on the drum? You know that when they will be coming in contact with each other, at that time shoe will be having centrifugal force mr omega 1 square and a spring force ks. At omega 1 they are going to equal. Mr omega 1 square will be equals to k times. This is the spring force k times of x. K times of x. This would be equal. And at omega 2 speed, when speed is omega 2, this force will become mr omega 2 square. But this spring force cannot increase beyond that because this shoe cannot go beyond the drum. So once it is reaching to this point, it cannot go beyond. So I will be saying this time this is once again going to be k into x only. So net force will be mr omega 2 square minus mr omega 1 square. This r is the radius of shoe up to centroid. So this is the distance when shoe is present here from the center. This is rs. This is drum. Is it clear for everyone? So this is the net force which is acting. Now what is the friction force? Mu times net force. What is the power loss? FF into radius of drum. Radius of drum is this RD. So you will say power, sorry, this is not power, this is torque. So torque loss is mu times net force mrs omega 2 square minus omega 1 square into RD. This would be the power torque loss formula. Power loss is torque loss into omega. Understood, guys? Yes. Please tell me how many of you enjoyed this session. We have completed all the things. Radius of center of gravity involved. Ha, Madhuvamshi, that's why I said. You can see now I am saying RS will be up to this. Radius of shoe I am taking up to centroid. Okay. Radius of curvature I am taking up to, sorry, radius of shoe I am taking up to centroid. Then this is the radius of drum. Tell me, guys. With this we have covered everything from the loads till clutches. Hope you enjoyed the session. Yes, if still not, we cannot say anything about that because now MD is over. Okay. So we would be meeting, guys, on Saturday for rest part of tom and vibrations, and also on Sunday we will see some practice session. So guys, with this I will say goodbye to all of you. Thanks for your presence. Thanks for your love and support. Keep doing that so that we can also meet for other topics like material science, engineering mechanics to help you more. So goodbye, guys, for this session. Thanks for joining. Goodbye.